Okay.
The V-gate sucks it in.
Only when you get it close enough, and you need to, in order to do that, you need
Yes.
to push it harder than if it wasn't there to begin with.
I've seen the guy push it. Barely touches it. I think in one of the videos he said, "Look, I barely have to touch it to get it to go in there."
I think we've dragged this up long enough. Is there anyone else in here who wants to talk? Not necessarily to me, I was just saying. If there was anyone
Yeah, I
else
don't
in here.
want to talk to you, but I do want to give you my appreciation for all the hours you put in arguing.
Oh, yeah,
I mean,
no problem.
without you, these arguments wouldn't carry on just monotonously.
Oh, yeah.
Like,
It's
crazy.
it's like I said to Crit. Or no, is it Crit?
Are
No,
you still
it's
talking?
whoever.
Like, I
Is
wasn't
that,
done.
yeah, this place wouldn't be alive without us
Oh,
clubbers.
yeah, it's definitely a lie because of you and the
Yeah.
way you just argue any point as the expert on the opposing view. Thank you. Tell Kosho I said hello too.
Thanks for all your hard work.
Yeah,
Thanks for all your hard
You're
work.
welcome.
Gotta be
You're
hard
welcome.
work. Now, I don't think I heard. Well, I did hear once. I heard once today them saying that Zanuck was wrong about something, or somebody
yeah.
was wrong.
I didn't quite agree. I didn't quite agree with the way Zanuck was talking about it, but
Thank you for that too.
yeah, you're welcome. So, do you think that you gain energy from a V-track, Rakia?
Did you just ask me a question when I very, very clearly said I don't want anything to do with you? I was just thanking you. Yeah. See you later. You're nothing to me, man. You're just an arguer, a time waster. Yeah. See you later.
Yeah, I mean, really, we should instead of arguing against it, we should be trying to get this to work. Revolutionize, energy and electricity and shit.
But that's what I'm saying, Jeremy, is in order for us to get this to work, we need a V-track that gives more energy than we put in. And I don't know how to do that. Do you?
No, you need a V-gate to move something from a lower elevation to a higher elevation. That's what you need.
Yeah, that's the equivalent of putting in energy.
And that's what we see them do with the V-gate magnet tracks on YouTube.
Well, yeah, only by putting in energy to begin with. We're just arguing in circles.
The V-gate sucks it in, dude. Just because you have to move, if something's sucking something in, just because you have to move something close enough to get it to suck in, not sucking it in.
For the first little bit, you have to push harder, and then it starts.
You don't have to push harder. You don't. I heard the guy say on the YouTube video, "I barely have to touch this to get it to suck to move up the V-gate."
So you're
the expert,
him?
though. You're the expert, though. I know.
You trust this YouTuber?
There's a guy that's done it, and then there's you, the guy who hasn't done it. I'm going to believe more, the guy who has done it or the guy who hasn't done it?
Well, you trust him that it's giving more energy than it's taking.
What I said? Who am I going to trust, the guy who's done it or the guy who hasn't done it?
Maybe you trust the guy who isn't making the claim that it's giving more energy than it's taken?
Who would you trust, the guy who has done it or the guy who hasn't done it?
The guy who hasn't done it, because the guy who claims he has done it is claiming he gets more energy out of it than he puts into it. That is an extraordinary claim.
The guy who hasn't done it is saying the V-gate is sucking it in. Have you ever touched the V-gate magnet track?
No.
Okay, I'm going to trust the guy who has touched the V-gate magnet track.
Even if he's making the claim that it gives more energy than it takes.
For 100% until I do my own, obviously. But from here on out, as it stands, take the guy's word who has touched the V-gate magnet tracks. I mean, please forgive me if that doesn't make sense to you. Say there's two guys on the side of the road. Is an expert mechanic. I never touched a car in his life. Who do you think I'm going to let work on my car? take advice on how my car
Neither,
works.
because they're both random strangers. But so let's apply this logic then. Do you agree that if you want to think about gravity or Cavendish, you should ask Biodual? You shouldn't make a statement yourself because you haven't made any such experiment. Biodual has. So you should listen to anything he says. Yes?
Why, has Biodual touched the V-gate magnet track?
No, but he's done a Cavendish experiment, so you shouldn't make any statements about Cavendish. You should ask him.
Okay, great. We're not talking about logic. Cavendish.
Okay, so you agree with that then?
We're talking about Cavendish. We're talking about a V-gate magnet track.
This sounds like all.
Do you agree with that sentiment?
Yes. When it comes to something working, I'm always going to take the guy's word who's touched the thing over the guy who hasn't touched the thing.
Okay.
Absolutely.
I have touched a Foucault pendulum, and I can tell you it does work in showing Earth rotates. You haven't touched a Foucault pendulum. Do you believe me?
Okay, you can say that something does something. Okay, now there's a difference here. You can say something does something.
Okay.
You've touched. As far as the cause of why it happens, no.
Okay. So if I say I've used a Foucault pendulum and it does precess.
Your word for it. Precess is great.
Did you notice the change of topic? And just question after question.
Yeah, it was an Altard Unite tactic.
Yeah.
So Crit, do you think a V-gate gives more energy than you put in?
On.
Yeah.
You think it does?
No, I was saying to Brakia.
Okay, fair.
I don't know. The first time I ever heard of a V-gate.
Okay.
Yeah. First time you've heard of a V-gate too. Never touched one. You have no idea how much energy it takes to put it in the track.
Just enough energy that you get out at the end. Yes.
Yeah, I know.
It's quite simple, to be honest. Otherwise, you're breaking the second law of thermodynamics. I'm sure you like that one.
I know it won't work. We know you're
so
a naysayer. We know.
Why not break the second law of thermodynamics? I thought you agreed with it.
You can't shut up, can you? Are you paid by the word? I mean, you can't give it up.
Wait, so you do you or do you not like the second law of thermodynamics?
They all think that they know it, and then when we call them on it, we can't use that word because it doesn't work because we have a special case, special pleading.
Dude, you're a V-gate keeper. We know you're a V-gate keeper.
Yes, I am your V-gate keeper, correct.
There's a different guy who said that if it's in contradiction with the second law, then you're false or something. I can't remember the exact quote, but that's a Globe guy who said that.
Yeah, well, that's saying that because what Jeremy's supposing is something that breaks the second law of thermodynamics, so therefore he's false.
Or the first law.
Or the first law.
It's breaking both in the way he's describing it.
And that's
it's fine. Let's just both agree that the second law of thermodynamics doesn't work, so we can have gas pressure next to a vacuum, and you can have your fancy V-gate. And let's never use the word or the second law of thermodynamics again in these conversations.
That's a good idea.
I would do that, Jeremy. I would agree that your V-gate works if you just give up on the second law of thermodynamics and allow vacuums next to pressurized.
But the irony of the second law that doesn't it doesn't have anything to do with it doesn't have anything to do with that. Yeah. But I know what you're saying.
The second law doesn't have anything to do with gas pressure?
No. It's a measurement. It's a measurement of what happens. It's a measurement. It's a measurement. No, it has to do with energy's direction. Energy moves from high to low. Heat moves in one direction,
low pressure,
from hot to
right?
cold.
High pressure to low pressure, right?
It's not. It only moves from high pressure to low pressure when there is a force.
Okay, when you have a vacuum,
there's got to be a net force. Like, for example, you have high pressure in a container, and so it doesn't escape because you have a force keeping it in. So does that break the second law of thermodynamics?
Right. I don't know. Maybe we'll just talk about stuff later when all the naysayers are gone.
We know that air has weight, so that's a force also. So there's no difference between a force of its weight or a force of a container to keep high pressure next to low pressure. And you can see it every day by looking at the atmosphere. It's lower as you go up. Pressure goes down precipitously if you go up.
So Jeremy, when we talk about when we talk about things, you become a naysayer. When we talk about the globe, you become a naysayer and ask for proof and all of this. But when you want to present your magical perpetual motion machine, you don't want to hear a shred of doubt or questions or anything. You just want people to nod their head and agree that you're smart.
No, I just wanted to kick around the idea of maybe this is possible. Maybe we should try it. Something to progress,
but if you
progress us. Not just sit here and go, no, that won't work. It'll never work.
But we're not just saying, no, it won't never work. We're telling you this is the reason why it wouldn't work. And you don't know, you have no answer really to those questions. You're just waving them away. That's not us being naysayers.
I've seen the guy push the thing into. Listen, I'm not interested. Really, okay. I'm not interested. You guys can sit here and just try to shut it down all you want. It's fine.
Yes.
Let's talk about the chocolate. The chocolate is more interesting to me. I can't stop watching that.
Oh yeah, the infinite chocolate.
I can't stop. I'm trying to figure out. I know if I cut it out and do it myself on a piece of paper, I'll figure it out. But do you know the answer? What the optical illusion is?
Yeah.
Do you want to tell me, or should I be left in suspense here for?
I can tell you if you really want me to.
I don't know if I want you to, though. Right?
That's the thing, yeah.
Oh God, thank you for that. I appreciate it. Okay, can I answer what is it? Is there one frame where they kind of switch it up and you don't notice it because it's jerky, or could you do this smoothly and it would be the same effect?
So you would see in this specific GIF. Yeah, so in this specific GIF, there's one moment where, or well, two, because it connects in two different occasions, where they appear to scuff it. They add in a little bit. So this GIF specifically, I just watched it in slow-mo. So in this GIF, they are adding back some things that's happening in the animation. So they're actually adding back some chocolate. But you could do this same thing in real life, and you would get an extremely similar effect, but there would still be something you could notice to figure out why it's happening.
Okay, that's really good. Who thinks of this stuff, man? It's awesome.
I'll see if I can find a real life GIF. Because yeah, you can do it in real life. You just need to. Here might be one. Yeah, here's one, posting it in chat. That it? Yeah, there we go.
That's a good one.
I mean, the end result is that it's shorter, so it's just because it's slanted up. The cut is slanted up. It's not the same size as it was at the beginning, obviously. It just looks similar because you cut one out and the slanted line accommodates for the one that you took out. So the whole bar is smaller.
Yeah.
I mean, it looks kind of cool, but it's not really.
Yeah, it's more of a it's a little cool the first time you see it, but as soon as you know what's actually happening, it's no longer cool.
Yeah, I see it. Yeah, and I think thankfully did it on the that wood table where you can see the relative height.
Yeah, because in the if you were to look at the bacon skiff again, right as they recombine it, like they move the chocolate up to recombine it, they add in that slanted line. They add it back in.
Right.
So it is the exact same height when at the end, but that's only because they add that back in like some within one frame, so it doesn't look.
Yeah, pink. They stop it and add it in at the same time.
Yeah.
So everything missing on that diagonal is equal to one square.
Yeah, exactly. It is still interesting that you can kind of like you can cut out. You can cut one square out, but you can still make it look like it's got the exact same number of squares. That's still an interesting little thing.
But Jeremy's still hung up on that perpetual motion idea. I hope he finds that billionaire to make this this concept.
Yeah.
I mean, I'm honestly not even interested in talking about it with you guys. You're V-Gate keepers.
No, I mean, I'm not anti V-Gate. I think it's interesting. You're using the correct logic, but in actuality, you're missing some of the aspects of the magnet. Yeah.
Okay. Well, then
because you've done it in actuality. I know.
I don't have to do it. I already know how things work.
Yeah, Zanuck, do you
have
agree with my
notion
assessment
of how the world works, and you're scared to step out of your box? I know.
Yeah. I love the idea of a perpetual motion machine. I think it's brilliant.
Yeah.
If it worked, it would be it would be lovely. Yeah. It really would.
Well, we'll never know if it was up to these guys. If it was up to these guys, we'll never know if it works or not.
Jeremy, if you want,
they'll just say it can't work and never do it.
Jeremy, if you want to talk to, for example, Hugh who just joined about it, I will completely not respond. If that's what you want, just say.
Yeah, I'm talking to him about it. it. So Hugh, if it was up to these guys, we'd never know if it worked or not because they would just say it can't work and just never do it.
That's the essence of, in my mind, that's the essence of exploration, right? Is to suggest something that can't be done, and then to do it.
At least try it, right?
everyone to say you can't do that, you can't do that, and then go and do it. But the thing about it is that you have to go and do it. So I mean, I'd love to be shown that actually really working. That'd be brilliant.
Absolutely.
Yeah, think how great that would be to be able to create this kind of V-gate system on a large scale to, never need any more energy. Just use the energy of these magnets. And we already know that. The reason we all poo-poo is because we know energy cannot be found in magnets. And number two, we know there's no such thing as perpetual motion devices because we know the first law of thermodynamics is actually still valid, never been proven wrong. Yeah. So because we know those two things are true, we can just, unanimously say that it's not going to work.
Well,
so we're never going to try it, and we'll never know if it works or not. I know.
No,
well, you can try it. Hey, you can make billions of dollars if it worked.
Even if that marble,
it's
metal
okay.
marble,
I'll go after you.
Okay, cool. Even if that metal marble thing was perpetual motion, I mean that would be fabulous, right? That would be great. All right. But you can't harness any of that energy. There would be no way to harness any of the energy. So it would be just a curiosity. But then to find out it was powered by batteries in that video, that was too good. That was too good. But even if it did work without batteries,
I wish people would stop relating my thing to that thing with the marble and the and if there's batteries in that. I don't know. That's not the design of my thing. Please stop relating my thing to that thing.
No, I don't know.
They've done it like 4 times already.
I'm sorry, I didn't know what your thing is. I just saw the video just now. Anyway, Ricky, how's it going?
Yeah, pretty good, man. Thanks for letting me go. I don't think the best thing would be to figure out how a perpetual motion machine would work. I want to hear when the amazing scientists and humans of this world do figure it out. I want to hear y'all deny that y'all didn't say it. It's impossible. That's what I want to hear.
It'll never happen. It's not going to happen.
I know.
Because you can't get energy for free. Energy cannot be created nor destroyed. First law.
It sounds like the guy like 30 years ago going, "We'll never have."
No, there's no example of anything that says that we've broken the first law of thermodynamics. Not one.
I mean, the cord has to be hooked to the wall to be able to work. There's never going to be hands-free phones. Never.
Yeah, you can never have a phone small enough to be able to just hold in your hand. I know that's the thing. That is the thing, Ricky. I totally agree.
But those don't break. Those are more probabilities, not laws.
It's just the idea of being told you cannot do this. It's impossible, and then someone goes and does it. I like stuff like that. I'm into stuff like that.
What about you can't go into space because space doesn't exist, and then suddenly you find out that space does exist? How's that going to make you feel, Rakia?
So you can't create or destroy it. Oh, sorry, Rick.
I just said I don't know what he's talking about. Go ahead.
So you can't create or destroy energy, right? That is the current, and I'm not disagreeing with that, right? That is what it is, right?
Correct.
Yeah.
What is 0-point energy?
A magnet.
Excuse me?
A magnet? Would that be considered 0 point?
Vacuum energy, 0-point energy is a magnet?
You got to differentiate between those two because they're not the same. 0 point and 0 point and vacuum energy, I mean, they're not the same.
I could be wrong, but that's what they refer to it as now. If you have a different explanation and you'd like to challenge me on that, go right ahead. And tell us the difference if you know, Gummy.
He's Googling it right now. Be an expert. Give him 5 minutes.
That's all he does. He's give him 5 minutes. He's gonna go. I'm doing this from memory now. I'm sitting in the balcony, enjoying my beautiful day.
I mean, if you want me to, do you want me to tell you from memory? Is that what you want?
You just challenged the notion, right? You just challenged the notion, and just like that, now you're gonna become an expert, having not known anything about it.
I
said energy cannot be created or destroyed. Then I asked you, what is 0-point energy? And instead of addressing that, you do what you do, Gummy.
Okay.
He's buying time. Go ahead, Gummy.
Yep.
No, I'm asking him a question. I'm playing a game at the same time. I'm asking him if all he wants is for me to tell him from memory why it's different.
You know what? I don't want nothing from you, bro, because you've shown what you do today. There's nothing really that I want from you ever, dude.
All he asked was, what's 0 point energy? I don't know what the big... Why are we making it a big thing? You know what 0 point energy is or not? If not, I don't know. Okay, what is it?
It's the lowest amount of energy within a quantum mechanical system.
So 0 point energy is a photon?
No.
I thought a photon was the lowest amount of energy.
No, that's not within a quantum mechanical system.
So if there's no such thing as creating or destroying energy, and I'm not disagreeing with that, my question is, how does this vacuum energy just come out of nowhere? That's my question.
Well, have you heard of
problems in your model?
But have you heard of Noether's theorem?
Go ahead. What is it?
It's essentially that, like for each symmetry in the universe, there's a conservation law.
Okay,
and the one that the symmetry that gives rise to the conservation of energy is the time symmetry. And you know that time symmetry isn't equal everywhere, especially in space, where space-time is expanding, and therefore it doesn't apply there.
So time symmetry gives rise to vacuum energy? Things that just pop out of nowhere? Is that what you're saying?
Time symmetry gives rise to conservation of energy.
I like it, Gummy. I like the detail.
Yeah.
Yeah, do you understand? Okay, since you like it so much, explain it. You take over. Explain what he just said, please. Go ahead.
No, this is him. You got it, Gummy.
Yeah.
I mean, he probably knows exactly what
details. What does he mean by it?
Exactly what I'm talking about.
Let him explain it then.
It's up to him to decide.
I don't want to take over his thing. You guys do your thing, and I'll come in at the end.
You guys are just sophists, man. That's all you do. That's all you do all day. That's all you've been doing all day long.
That's tough.
Okay. So, did you have any problems so far with what I said?
Nah, I'm not really interested in talking to you, Gummy.
Okay.
I just want to show.
So you got shut down with
your hypocrisy.
You got shut down with logic. You got shut down with logic, and now you don't want to talk anymore.
Not with you. You're a time waster.
This isn't discussion. What is
that's
this?
fine.
That's not discussion, guys.
Yeah, that was SC telling me he didn't want to discuss anything with him, and Gummy Bear interrupted him.
20 minutes ago, Gummy Bear said he was done adding his thoughts about 0 point energy.
No.
And he still hasn't done it.
No, I did not. I said I wouldn't talk about Jeremy's
Gummy Bear
experiment
interrupting
thing.
Again. Or another person talking.
What do you mean? I'm not interrupting anyone.
No. As he was speaking.
Wait, can I not hear him?
Probably.
Let me rejoin.
Anyway.
So can somebody besides Gummy Bear address the issue? And I'm not saying that I just figured something out. I'm just saying, isn't it weird when they say you can't create or destroy energy, and then they tell us that, yes, energy comes out of nowhere in the vacuum? Don't you guys find that a little disturbing?
Listen, if they were wrong on a law, that'd be a fucking shocker to anyone. Newton's law of gravity is incorrect. We have multiple citations. I heard Jay cite Schenker yesterday. I have a citation from Schenker.
I talked to Schenker.
Newton's law. Newton's law is still good.
I know this is the time where you guys don't let me finish.
No. Newton's law has never been disproven. Newton's theory has been disproven. It's a different thing.
Come on, man. Let him finish.
Go ahead, Zanuck.
I literally just said I talked to Schenker. That's all I said.
Yeah. So, I mean, were you using them as a reference or citation or anything, or are you just saying you talked to Shanker? That was it.
I've talked to him about this. I talk to him quite often, but I talked to him about this before. He
about
thinks
Newton
it's
being
funny.
wrong?
He thinks it's funny that you guys try to use him to say these strange things. But anyways,
well, I mean, it's not only him; it's Andrea Ghez, Feynman. I got tons of quotes from high-ranking people in physics and all kinds of science shit.
Yeah, but it's just like gotchas, right? Like
no,
everyone in
it's just
physics
somebody saying
understands
Newton's wrong.
this.
It's not a gotcha. It's your own people telling you that Newton's wrong, and it's you just denying it. It's not like your science people.
I've never.
I don't want to call you a. I don't want to call you a science denier, but you got your own science people telling you that Newton's wrong, and you're denying it. So I mean, you can make of that what you will.
I've never once denied that.
So you agree then?
I like to see the quotes.
Do you agree then, Jace? If I
Sure.
felt like you were trying to go and argue against it.
No, I'm not trying to argue against it.
Oh, all right,
I think you're just looking for a gotcha. I'm going in an elevator. Be right back.
It does feel like that.
Felt like you was, yeah, I know, right?
It's like the feels.
They think they can just say words, make and just continue off, just appear out of nowhere. 0 point energy.
So when I gave you my explanation earlier, did you see that as just being words, even though I cited several things, several theorems that build up to this? Like Noether's theorem, or however you pronounce her name.
Noether. Noether.
Noether's theorem. For example, I brought that up to you. But did it land? Do you remember anything about Noether's theorem?
Tell me, I want to know. What is that?
I can't say it again, but he can try and explain it if he wants.
Okay.
Right. It's a
seemingly he doesn't.
It's a mathematical theorem. So the proof of something, and basically, it's and when you find symmetries in your system, that means that there's a conserved quantity. They're interchangeable, and for the conservation of energy. So when you're trying to derive the conservation of energy, the symmetry that you find is time translation symmetry, which means in any system that if I were to perform the experiment today or tomorrow and it would look exactly the same, then the conservation of energy holds. In any system where if I perform the experiment today or tomorrow and there could be any difference in what it would look like or what the results would be, either of those, then the conservation of energy is no longer valid for that system.
And something like just normal translation, like just moving it around in space and it's the same, that gives rise to conservation of momentum, for example.
Where does this energy come from? Where does it spontaneously come from? This vacuum energy, where does it come from? Where do you think? Not you, Gummy. I'm not interested in what you have to say. I'm asking the other guy, the chemist.
Right. So with general relativity and the metric for expanding space-time, which is the FRLW metric, the time, there is no time translation symmetry isn't present in that. So there is no conservation of energy. It can be broken.
Oh, sorry. I thought you were finished.
Yeah. Conservation of energy can be broken in the case of things involving that. So dark energy it can just come. We don't know where it comes from, but it's just something that's measured.
So you do agree with me then that this is kind of weird, right? Because the first law states, you would agree, right? That it's kind of doesn't make sense, right? Contradictory. Because the first law says you can't make or destroy energy. And then they tell us on the other hand, well, in the vacuum, it just comes out of nowhere.
Like I just said, the first law is applicable in time, where time translation symmetry, it can be approximated, which is in systems like if I were to do a chemical experiment today and do it tomorrow, it would look basically the same. The results would be basically the same. So the conservation of energy holds in that case. But in the terms of the universe and FRLW metric, it doesn't hold because the past doesn't look the same as the present.
You're starting
there is
to
no
make a little
time
bit of
translation symmetry.
Yeah, okay, sure. I respect the way you answered, and you're using the terms that you learned, but really, it's just another way of saying something from nothing. Time translation symmetry. I mean, what does that even mean? You read that somewhere, right? Time translation symmetry. Well, what does that mean exactly?
It's a variable in the Lagrangian of a system. So the equations of motion of a system, if they have a certain kind of symmetry, it corresponds to time translation symmetry, which means if you can solve the equations using one time and another time, and the answer is the same, that's a symmetry of time translational symmetry of that equation.
No, I could understand that. And nicely, very nicely, laymanly explained, but how does that bring matter into existence?
Well, right, no cosmologist or astrophysicist, they don't deny that this dark energy thing, we don't know where it comes from. It's just something that's measured.
No, this is not dark energy we're talking about now. This is vacuum energy. These are two different things now.
That's what you're talking about.
As far
dark
as I
energy,
know, in my layman head.
Right, so here's where I would want to define things like the vacuum state of like a quantum system or a quantum field, or the vacuum energy. Those are like the lowest values those systems or those fields can take. The 0 point energy, or the if you're talking in terms of dark energy, people have called it vacuum energy before, meaning like the vacuum of space and the energy that's out there, right? But that's not the more common usage of that term in science.
To be honest with you, this is the first time I heard the correlation between dark energy and vacuum energy. Maybe I'm slow. Maybe, you're more up to date than me. But nevertheless, you have to explain this truly mysterious, if true, fantasy thing, like literally something just popping into existence.
I think what you're talking about is like the vacuum 0 point energy or whatever, where like the discrepancy in the dark energy value that they measure and the theoretical, like if you sum up the vacuum energy states of all the quantum fields, what that value is compared to what the dark energy value is, the whole Michikaku thing. Is that what you're talking about?
No, Michikaku is he's in another fantasy. He's into vibrating strings and the 12 different dimensions. He's in a world of his own. Like, don't even mention his name.
He's talking about it in a much more simpler way than that, JS.
No, he's out there in freaking La La Land, this guy. Just listen to him talk.
Right,
rambling on.
It's unknown where the dark energy comes from. It's posited that the vacuum states of the quantum fields and stuff are what the dark energy is, or a contributor of it. But those vacuum states, they're not in they don't break the conservation of energy. It's the dark energy is what's doing that. There's
I would say so too, yeah. Especially when they don't know what it is. They can't measure it. They can't touch it. They can't smell it. They can't interact with it. But they know it's there.
Virtual particles popping in and out of existence. Don't you love it?
Well, hold on. That's a different. The virtual particle thing is different. That's due to fluctuations in the lowest energy state, the vacuum energy state of the quantum fields.
That's what he's talking about. Yeah.
That's what I'm trying to get at. Doesn't violate.
That's why I made the comment.
That doesn't violate the conservation of energy. That's just due to the Heisenberg uncertainty principle with quantum mechanics.
Okay. So is it possible that you could solve some of these problems by changing the medium?
What problem? Posit a problem.
Well, you just said dark energy violates the conservation of energy.
Yeah, but there's no problem with that. He explained why it's not a problem.
Okay, so dark matter and dark energy are objectively problems. Within the paradigm, they're undefined. But is it possible that you could account for the phenomena if you were to change the medium?
Go ahead. You can, work that out. Give us the results. See how that works.
Yeah, dark matter is nothing more than the substantive characteristic of the medium itself. Energy is a motion within that more substantive, dense medium.
Not even, bro. They just made it up. Nobody has any clue what it is. Don't even try to say you think you know what it is.
Okay, to clarify, there's an area isolated in the sky, right? What they make up is all these stories about what is what, and they try to explain it mathematically in a vacuum. So it's not that there's nothing in the sky. Like, we got to be careful by saying stuff like that. Like, you can look in the sky and see things. It's
no, we don't say that, bro. They say that. We definitely know there's stuff in the sky.
Yeah, I'm just explaining to him that if you're being honest, it's actually not a problem with a more dense fluid medium. It's very explainable. The difficulty is explaining it in what was assumed to be empty.
So how does a medium explain dark energy?
I'd love to see how that...
Yeah, maybe you should listen. I'll say it again. So dark matter is nothing more than the substantive quality of the background itself. The energy is nothing more than motion within it. So you're still just all you're doing is characterizing, the medium.
So you're saying that dark energy is just the medium moving?
Yeah, it's a movement in the medium. That's right.
Okay.
Gentlemen, with all due respect, you're both arguing about nothing. There was nothing wrong. There's nothing there that wasn't there before. This is all fantasy due to their miscalculation of gravity. That's all it is. Nothing has ever changed. There's no dark matter. There's no dark energy. None of that exists. It's all
there has to be dark. If there's not dark energy, Einstein's wrong, because then you got things moving faster than light speed.
That too.
What?
You got to have dark energy.
Who told you without dark
I don't know about that. I don't know about that.
Faster than light.
Galaxy rotational speeds move too fast.
Well, we have galaxies
you guys
moving
keep
away
conflating
from each other faster than we have galaxies moving away faster than each other. Google search what's the fastest galaxy moving away from us, and you'll see that it's more than double the speed of light, which means without your dark energy, space expanding, you've got a serious problem with Einstein.
No.
Yes, this was discovered in the
50s. So there's no problem with things moving.
And you guys need to stop conflating dark energy and dark matter.
We're not conflating. What Jeremy says is correct. First, they said speed of light cannot be exceeded. Then, what happened? They found the galaxy traveling faster than the speed of light, and they said, "Oh shit, what do we do now?" So they made up a cockamamie idea that it's the space that expands, not the light. It's the space that it's going faster.
Which is ridiculous. Literal empty space is being created.
Yep.
Somewhere. What? I don't know, man. Whoever thought up that one's fucking genius.
I want to clarify, though. What are you talking about? We're conflating dark matter and dark energy. In the 50s, they discovered the galaxy rotational speeds. The edges of them were far too fast, right? And then they understood that there was a problem with relativity. And what did they use to explain the galaxy rotational speeds? What are we misunderstanding?
Dark matter.
Okay.
Dark matter.
And
They use.
those are not faster than the speed of light.
No, the rotational speed of the galaxy is not faster than the speed of light. That's two different things.
The thing I said is faster than the speed. The thing I said is faster than the speed of light.
Yes.
And without dark energy, you got a serious problem, because now we would have things moving away from each other at faster than the speed of light. So you had to make up some crazy idea of empty space being created somewhere. I don't know how you fathom that.
Not only created, but faster than the speed of light, expanding. Yeah. Crazy stuff, man. They must have seen an episode of Star Trek with the warp drive or something, you know?
Where do you get empty space being created out of nowhere? Like, who even thinks of that shit? With I don't know.
Guys,
imagine space expanding faster than a light switch. When you turn on the light switch, imagine that. It's like insane, man.
The truth hurts, I guess.
Dude,
not the truth, bro. It's what you've been convinced.
Wrong for, dude, 70 years ago, bro. They found out that relativity was wrong 70 years ago.
Yeah.
You put a mathematical band-aid on it, patched it up with some conceptual abstractions, and then just kept waltzing right through like we didn't just watch that happen.
Yeah, that helps you sleep at night.
Well, there's two options. What the Globers say is that's how science works, and we figure out more stuff over time. This vague sentiment that no one you discover things over time. Therefore, it's the fix-all to everything. The second option is that the fundamental framework that you're trying to explain things within is wrong, and you're going to continually find discrepancies that don't work. These are objectively the two options.
So
right. So either it's right or it's wrong.
There's no.
So come up with an alternative framework instead of just come up with an alternative framework.
Already have. Yeah, a substantive fluid-like medium.
Come up with it. Don't say it. Just come up with it.
Look, it's something. It's something. The honest thing to say is here on both sides is we just don't know. Could be dark fluid. It could be dark energy. It could be dark this, dark white, pink. We just don't know. That is the honest.
Do you know that the cosmological constant was originally just naturally in Einstein's original theory that he developed? So dark energy, what the dark energy constant is, that was when he developed the theory. That was just in there. It was just naturally part of the derivation of the theory. He removed it because he thought the universe was static at the time. Observations indicated that the universe was static, and he liked that idea. He thought that was correct. And so he removed the ability for the universe to either contract or expand via this natural constant that was in his equations. And now they found that is actually what is happening, that constant was there because it's just a natural part of the theory.
It wasn't a thing that he liked or disliked.
Biggest blunder.
Yeah, you just said it's because he liked the idea of it being static. No, he speaks in depth about how he thinks it's not very probable that it's not static. So he based on probability.
Yeah. He thought the observations and measurements at the time were indicative of a static universe.
And that the implication of contraction...
Are you talking about the cosmological constant, Jeff?
Yes.
Yeah.
And it's more so that expansion or contraction just further complicates the theory. Like, it further complicates the application. He was very specific about that.
When you derive Einstein's theory, it's just a natural thing that's there. You have to physically remove it out. You have to take it out mathematically yourself. You derive his equations.
But he was saying that the difficulty was the application.
Yeah, because at the time, they didn't have any indication that there was a cosmological constant or that the universe could contract or expand. They didn't have any measurements or observations of any of that at the time. So he would have thought it was ludicrous.
It is.
Yeah, science is provisional.
Well, but it is ludicrous, though. So.
Can you admit that Einstein was just another man and he's just as prone to being wrong as any other man on this planet?
Of course, he was wrong about this. Like I just said, he took out something
Hallelujah.
and called it his biggest blunder.
Hey,
he admitted it himself.
Is it possible that relativity is entirely wrong?
Sure.
Thank you.
Do you have a better?
Nice. So I can't believe this. We're getting somewhere here. Nice. Thank you.
I do have a better. Yeah, the actual mechanism that's invoked may be present, but it requires a substantive fluid-like medium. Pretty simple.
Okay, how does that change Einstein's equation so that we can test this?
Well, the equations are pretty much dependent upon distant assumptions, so it doesn't matter.
Right. If you're going to propose a new theory or a new idea, there's got to be some difference that we can test so we can verify it if it's this idea or your new idea. There's got to be some difference. Otherwise, you're just umbrellaing the old idea under your new thing, and that's unfalsifiable.
That's what he did. He pieced
When you say test, you mean test as in a scientific experiment where we have an independent, dependent variable and all that stuff? Or just some willy-nilly bullshit?
Oh my God, you got me, Jeremy.
Is that funny, or?
You got me.
No, he's asking you how you test, because that's the limit. Like me and Witsit and SE or whatever, if we came up and Jeremy came up with new theories, how are we supposed to get it into the mainstream? We're just ordinary folk out here, right? Kind of like, some of the people in the past, they had more time, they had to go get funding and blah, 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 and had to get pushed. It's hard to do. It's even harder now. Takes more money. Not the
I ain't even worried
person.
about that. I'm just worried about how do we test it. Can we not have an independent variables and dependent variables and all that, or can we just do some?
Yeah, we can just look at the sky and make up stories. We just get to look.
I don't know why he laughed. I'm still waiting for his answer on that one, because he did laugh at it, and I want to know how we would test it. Like, what test are you talking about?
Yeah.
Someone else can do the whole scientific
that's what I thought.
game. It's boring.
What do you guys?
So we can just look up at the sky. How we're gonna.
No, I didn't make any proclamations of how it can be done. So don't say we can just, or you said we can just. Don't.
I'm saying if that's what your side can do, then that's what we can do. We can just look at the sky and make up claims.
And you're answering everything. You were answering every question until it came to that. I don't understand. It's actually the easiest question you've been asked.
Because it's just gotcha word.
Just be honest, man.
It's not interesting.
Astrophysics cannot in any way verify things with scientific experimentation. It is an area that is excluded from personal accessibility.
There's astrophysicists come to chemistry department all the time to verify things that they're measuring.
They're not verifying that anything's happening in the sky, dude. They're just verifying the possibility of a reaction. No, they're not.
Of course they are.
Okay, so
they
you're
spectra,
being fundamentally dishonest.
They want to ionize things and get the spectra of certain molecules and try to match them and stuff.
Astrophysics is philosophical.
Match them and stuff.
Yeah, to support their philosophical ideas.
So if you get a spectrum, right, from a star or whatever, and then you go in the lab and you ionize an element or take some molecule and you get its spectra and it matches that spectra you got from the star, then what do you think the odds are that it's not actually that thing, it's something else, but it just matches perfectly? This very minuscule thing just happened to match perfectly.
When you say it matches, it's just a frequency, man. So you need to know the medium, dude. Jeez.
It's light. It's photons of light and their energy.
Exactly. So you need to understand light and the medium, bro. That you need to know the medium. If light's nothing more than the medium, and the medium's different there, because light is intrinsically dependent upon its medium. This is where we're obviously going to split roads, right? You think that it's you think it's a particle and a wave, even though waves aren't things and duality doesn't exist in nature. It's just insane.
Because the medium would also be giving light, be giving photons. Like every medium we measure it's going to give you a spectrum as well. So that would be present in your spectrum that you obtain.
Correct. The interpretation of the spectrum is relative to the medium.
The problem is with astrophysical spectra, those aren't present. That's the discrepancy.
What's not present?
A medium, a signal for a medium is not present.
Yes, it is.
Okay. So
Is there plasma in space?
In stars and things, yes.
Okay. But in between the stars, we know that there's nothing there because we would be able to detect the medium. Is that what you're saying?
Yes.
We know there's some things there. Cosmic rays exist.
Any medium.
Come on in, Xanax.
Jason,
I just thought I'd correct one small incorrect assumption. Yeah, we have measured things coming from...
Cosmic rays aren't plasma.
They're not?
No.
They're made up of plasma?
No.
Well, I think I've heard otherwise.
Wrong again.
Does plasma come from the sun?
Yes.
Okay, so the solar rays are plasma.
Well, the core of the sun is plasma.
But what is coming from the sun is plasma.
The solar wind is a plasma, yes.
Right.
But so cosmic rays aren't constantly, like the same source isn't blasting us constantly. Cosmic rays are emanating from sources all over the place.
Right. Like black holes.
So plasma is reliant on the density of the charged particles too. It's not just that it's an ionized, gas molecule. There's got to be a certain density of them for it to be a plasma.
Well, when we have a vacuum, we have 0 point energy.
Well, they are electrons, right? These cosmic particles.
Yes, some of them. Right, like we're getting into minutia here. There's, gotta get into the detail.
Right,
there's
but that's just to make his point that there's not exactly nothing in between us and these other galaxies. There are cosmic rays that are shooting out in all directions from all different sources and they're all different types as well.
There's baryons in between. Right, there's hydrogen atoms and hydrogen nuclei and helium atoms and helium nuclei.
So when we make a vacuum on the Earth
that they found,
when we make a vacuum on the Earth, it's nothing in there, right? There's no medium. That's what you think in there. In quantum, there's nothing in space. That's what I'm asking.
Well, could there be gamma rays traveling through a vacuum that's on Earth? Would you say that's nothing? The moment that gamma ray flows through the vacuum, or a cosmic ray,
No, I'm saying that before you send the gamma ray through, there's still something there.
No,
it's called 0 point.
It's not 0 point energy. How about in space?
Xanax, real quick.
How about in space when they're
asking a question? Hold on, Xanax, real quick. Winston is asking a question. How do we know that what the medium is? Jace told me last week that they can use spectroscopy. That's how we know space is an empty vacuum. Right, Jace?
Yes. If there was a medium, right, when we do spectroscopy of like solutions, the medium that we dissolve a molecule in, that medium, that solvent gives a signal. You know what the medium is. You know what it's in, right? So if there was a medium in space, that signal would be present. It's just simple logic, guys.
Okay, so what if I do spectroscopy of a vacuum chamber? Is that signal present of the background that's inside the vacuum chamber?
No, if it's not made of atoms and molecules, no. Not if you're doing normal spectroscopic methods of like chemistry.
Okay, so there is something there. So that's my point. Thank you for making my point.
What do you mean by something, right? Because like physicists will posit that there's quantum fields, like you get electron self-energies and the Casimir effect and things like that. But those aren't mediums. They're not like physical mediums that we can interact with.
Well, we do interact with it when we shoot light or radio waves or frequencies or anything.
Yeah, that's all. What is the medium of the vacuum?
That's
inside the vacuum. What is the medium?
Like I just said, the quantum field is what physicists posit. If you have just no matter, so no fermions present, no electrons, no protons, no atoms, molecules, they say that the quantum fields still exist and they have energy because of the Heisenberg uncertainty effect, right? Or uncertainty principle. They can never go to zero energy. So they always have a tiny bit of energy. And that causes effects that we can measure and observe. Things like the Casimir effect and self-energies of electrons, the Lamb shift, and things like that.
Perfect, bro. That's our point, though, because the claim is just that there's a quantum field there surrounded by nothingness. And no, it's just a field that's there, and you're isolating certain phenomena within the field. Do you understand? It's a philosophical difference. It's an assumption on your behalf. And quantum field theory was introduced in the relatively recently mainstream as a Band-Aid, because they used to say there was nothing in that vacuum.
Everything's always a Band-Aid.
It is, dude. They said there was nothing in the
version of science history.
Dude, they said there was nothing in the vacuum, and then they had to double back. So,
right, the Lamb shift and the analogous magnetic moment of the electron, self-energies, all that stuff. The value of those was derived long before they could be measured by people, years before. And it just so happens that those values match exactly.
Yeah, okay. But the point is
what
that
are the
you're invoking a field. You're invoking a field, but you're ignoring what the field is in. It's very, very ridiculous, man.
What do you mean, what the field is in?
Yeah, you're acting like there's one thin little line of a field.
No, there's over 100 different quantum fields.
Yeah, and it's all just different characteristics within one singular field. Do you not understand that is objectively a viable framework?
No, that's what some people call space-time.
Okay, now I obviously don't make claims about concepts having physical properties, so I'm going to have to part ways with you there, but you get the bigger point.
But you're saying there's a medium other than this, right?
Yeah, there's a overall background medium, and you say that it's just concepts, right? But it's not. It's just a substantive background. It's just not material. It exists in a different vibration than matter.
Well, that's just either you substantiate that, or it's just a proposition.
Sort of like space-time, only mine actually fundamentally makes sense because I'm not attributing physical properties to anything other than something that can have physical properties. So I'm just ahead of relativity. I'm not even claiming to know all the answers. I just know it's better than relativity.
All right, man. If you think so.
Yeah. I'm glad you agree.
The whole model contradicts reality. Almost every single part of it contradicts reality.
Well, there's fundamental logic. Like, you can't bend love, man.
I want to know how you get space. I want to know how you get space being created out of nothing.
Yep.
How does that happen?
Especially since the first law, right, Jeremy?
So you're going to pretend?
Space. 1 minute there's not space, and the next minute space just pops out of nowhere.
Jeremy, were you here when I talked about the Noether's theorem, the symmetries and time translation symmetry in the Lagrangians?
No, we heard that, bro, and I even complimented you on how eloquently you explained it, like layman terms. But still, that's just saying stuff, bro. It doesn't mean because you said what you said that you can make stuff come out of nowhere just because you said Lagrangian and this and that.
But no one's saying
just some guy.
No one's saying that. That's nowhere close to what I said. Right? Like you guys love to like make up a position for me or for other globers and then attack that when it's not our position. Right? I clearly stated that even like astrophysicists and even myself, they say that the dark energy thing, it appears to pop out of nowhere. There is no explanation for where it comes from, right?
So we're in agreement, bro. We're in agreement.
Yeah.
Why do we have to go further than that? It's ridiculous. Why do you need to explain this guy's or that guy's way of thinking about it? Why not just stop there?
Because it's a
Have you measured space coming out of nowhere, or have you measured things moving away from each other faster than the speed of light?
They measure the recession velocity.
Sorry, what?
They measure the recession velocities. The second thing you said. Obviously, you can't measure space coming, Jared.
Yeah, so they didn't measure space coming out of nowhere. They didn't measure space coming out of nowhere. They measured things moving away from each other faster than the speed of light. And then you can't lose Einstein, so you just say, oh, space must be created, even though they never measured that.
I don't think anyone claims they measure space being created, right? It's just
or if they haven't, because it's
interrupt me again.
My bad. Go ahead.
It's just a thing. Typically, when you're talking about this, these are mathematical equations and concepts that explain most of the data. They can umbrella most of the data.
Yeah. Or you can explain it by saying that things are moving away from each other at faster than the speed of light, which is what we actually measure.
Well, I would say we don't measure it here, but
we don't measure it here in reality?
Here on Earth, like using light that we are sending, right? We can't send light faster than the speed of light.
Measuring it with the galaxies. Measuring it in the galaxies, by the galaxies moving farther away, faster than the speed of light. We know.
Yeah, but this is something that's occurring off of Earth. It's not occurring.
It's occurring in reality, right?
Yeah.
Okay.
It's a crazy notion. Everybody should humble themselves, I think.
Moving away.
Yeah.
Well, it goes even deeper.
Things moving away at faster.
Good. I was just gonna say it gets even crazier because, like, what, like, if you were to, talk to an astrophysicist who's familiar with what general relativity really says, it's that it's not even the speed of light really that matters. It's causality, and so as long as causality isn't broken, you can't send a signal, communicate with another patch of space faster than light, then anything, can move at a speed faster than, as long as you can't
you just
communicate
said a word
back
now,
and forth.
Causality. How does causality affect the speed of light?
So, are you saying things can move faster than the speed of light, and that's fine?
Yeah, as long as you're not communicating, right? Like if something's moving faster than the speed of light and you're able to send a signal to it, that would break causality.
That's another way of getting around it. In other words, Jeremy, you can send like a message, right? But not an actual, hey, what's up, bro? That's what they're trying to say.
No.
What are you telling me that? Man.
In a layman's term.
That thing.
So say something was. Oh, Jeremy, you're breaking up, Jeremy.
Go ahead.
No, you're clear now. Go ahead.
So you're saying as things moving faster than the speed of light is fine. That's what you're saying?
Yes, as long as you cannot send a signal to it. So you can't send like a radio wave to it.
Yeah. But things can definitely move faster than the speed of light. That's fine.
In reference to you, right? If you were to measure its velocity and you got a speed that was faster than the speed of light, in reference to you,
you could never send it like a radio wave or an X-ray or anything like that, any kind of signal or communication, nothing to that object.
Yeah, but things moving through space faster than the speed of light, there's no problem with that. There's no problem with that. Things can move faster than the speed of light. That's fine. That's what you're
Yes,
claiming.
long as they're not communicating with each other while moving faster than the speed of light, away from each other's frames.
Are you sure about this?
Yes, 100%.
Who told you that? Who told you that?
I'll see if I could find a source for you.
Yeah, I mean, I would look for a source of people saying nothing can move faster than the speed of light, but I'm sure I wouldn't understand, or I'm taking it out of context, or something.
There's always nuance.
I'm not even gonna waste my time with it.
There's always nuance, right?
Yeah. Oh, yeah. Always.
Right, like some things when I'm explaining or discussing with people, I simplify them. Doesn't mean that that's an absolute truth. It's just I wanted to simplify it for means of the discussion. But if we need to go into deeper layers of abstraction and the real, the real physics and chemistry and biology and things like that behind it, we can. And I feel that's done a lot. These people simplify things, and then that's tried to be taken advantage of. Right? Even like science communicators, Scientific American and Nat Geo, right? They're writing for general audiences. So, right, like they're not going to publish how to solve Einstein's equations and get into the weak field limit and get to Newton's equations and stuff like that, right? Like that's way too much detail for the general public.
I know. So you're telling me special relativity doesn't say that nothing can move faster than the speed of light?
Yeah, as long as they're not communicating with each other, they can move whatever speed
you're saying
they
Einstein's special theory of relativity doesn't? Does Einstein's special theory of special relativity say that they can move faster than the speed of light? Yes or no?
No, it says they can't communicate with each other faster than the speed of light. It's really the speed of causality.
What's a good citation place for you?
Yeah,
Physics World, Forbes.
Because space time is bending, and you can actually travel great distances in shorter time, even though you're going less than the speed of light in that path relative to another. You're communicating with someone else, but as far as the actual distances go, you are going faster than the speed of light, and that's what the special relativity talks about.
So, right, Jeremy, a lot of this stuff I know is because I ask other professors, like if I could sit in their lab with them while they're working sometimes, and we just, spark up conversation. And I ask them about these things and ask them to, go as deep, give me all the nitty gritty details, like don't leave anything out. And so that's when you find out what these real things are. No, I'll find a source.
Good source.
Give me a second.
Source. I have a source. Is Wikipedia good?
It's not a scientific source, but depending on what it says, I could gauge how accurate it is to what I know. But let me find you a source.
I'm finding a lot of places on the internet that are saying. I'm finding a lot of places on the internet that are saying in special relativity, it is impossible to accelerate an object to the speed of light.
Yes.
Massive objects move at the speed of light.
Yes. For you to accelerate an object to the speed of light, that's impossible. Yes. I agree with that. That doesn't mean that something...
Albert Einstein's special theory of relativity dictates that no known object can travel faster than the speed of light in a vacuum. Dude, this shit's all over the place. According to Albert Einstein's theory of special relativity, published in 1905, nothing can exceed the speed of light.
Yeah.
How many citations do you want? I can give you about 1,000 of them.
Well, here's one. It says...
I can give you about 1,000 citations says it can. So all these places are wrong. Media, physics world,
No, they're just
all these places are wrong.
They're simplifying a
it, or are they
difficult
wrong? Because they're
concept.
saying nothing.
They're simplifying
it, or are they wrong? Because they're saying nothing can move faster than the speed of light. And here you are saying, no, that's incorrect. Things can move faster than the speed of light.
You're just screaming like a maniac. They're simplifying.
No, he's
right?
not. This is why we get angry at you. You can't answer a simple question.
Hot, dude. I'm getting hot because you're saying they're simplifying it. However, not simplifying it. They're just wrong. Things either can or can't move faster than the speed of light. And
of course, Jeremy, right? A bunch of astrophysicists proclaim that there's galaxies moving faster than the speed of light. So obviously things can move faster than the speed of light, man. This is just simple logic, dude.
They're not saying things are moving faster than the speed of light. They're saying the space is expanding. They're not saying things are moving faster than the speed of light. They're saying the space is expanding in between them.
Yeah, faster than the speed of light.
Unfucking believable.
Brother, with all due respect, do you know what dialetheism is?
Unfucking believable.
Because I do believe you might be suffering from a touch of it. Just a touch, maybe.
You guys ever going to learn a new word this
Hey, Blue.
This is hilarious.
I got a new word for you. I got a new word for you. Scooter.
I got two words for you. Guess what they are?
University of Tennessee.
So right, Jeremy was.
Damn, that's 3 words. Cavendish Storage.
Jeremy.
Mass.
If you're standing next to a particle accelerator, you know, something like the Large Hadron Collider, and that thing's whizzing some particles around in opposite directions at nearly the speed of light. You'll see those particles, if you're standing beside that thing, appearing to approach each other, close on each other at almost twice the speed of light, won't you?
Yeah, the difference is the galaxies that are, they claim that the speeds of the galaxies, they're moving away from each other at faster than double the speed of light.
Right, that was
big difference from faster,
right?
Big difference from faster than double to almost, difference of faster than double to less than double. Yes, with less than double, you could have it your way. More than double the speed of light, you lose.
So this source here says the speed of light should really be called the speed of causality. You can think of causality in relation to a concept known as the space-time interval, which states that causal connections, i.e. signals, are the only order of events that all observers, from wherever they're positioned in the universe, can agree on. Right, so that's a little bit more deeper detail on that thing.
And so what? What do you think that means exactly?
It means that if you're in a frame and something is moving faster than the speed of light in reference to your frame, you can't communicate with it. That would break causality. You can't send a signal to it.
So you're fine with things moving faster than the speed. So you're fine with things moving faster than the speed of light, even though
with space
Einstein's theory is
with space expanding faster than the speed of light. I'm fine, Jeremy.
We already went through that. We already went through that.
Well, that was your gotcha, right?
Now. I know. Go ahead, Jace. Ramble on.
That was your gotcha, right?
Bro,
does science change
it's
now?
about logic. Listen to what you're saying.
Is science changing now?
Blue, you think he's ever going to learn a new word besides gotcha?
Has science changed now?
Jace, have you heard of dialetheism?
Has science or reality changed now?
No, nothing has changed. Everything is as it is. We don't see too far. There's no dark matter. This is all stuff people come up with, dude. Everything is how it's supposed to be. Now, we're just little creatures trying to find out what the hell it is. That's it.
There's people who would tell you that dark energy and dark matter is what it is. It is what it appears to be.
No, you can't say that. You can't say there's something there that I can't see, touch, smell, interact, measure. It's nonsense, bro. But you just can't seem, because of your high education, and I can tell you're very educated, you have a stringent way of thinking. You will not think for yourself. You have no original thought.
X-rays don't exist and work, and you can see bones in your body.
You guys have no original thought, man.
Crazy way of thinking, dude.
See, you're once again showing that you're not willing. It's willful ignorance on your side. Your logic, I get it, but you're really not stepping back and looking at yourself in the mirror and saying, you know what? Maybe I just don't get it. And it's not dilithium crystalisms, as you said. It's just the way
it's
it
what
is.
you suffer from, Zanik. Dialetheism. You believe that it's a possibility to accept two truths.
And I listened to your video, and I laugh because it's not a slight on me when I watch that video of yours. It's a slight on you for thinking that I truly believe in two things that can't be simultaneously true. When in fact,
you do, and I can prove it to you right now in the next sentence.
Right. Prove it to me right now.
Okay.
Prove me I said something that I'm a dilithium crystalism.
Okay, now you guys heard this. I didn't start this, right? He started this. So I'm going to prove it to him now. Okay.
Yeah, we'll do it again. We'll go through this exercise again and prove how silly you're going to be.
Okay. In the Coriolis, right? On the merry-go-round. Yes. We throw a ball, right?
Yes.
There's two people. We throw the ball. The ball travels in a straight line. Now you say that
with respect to what? With respect to what?
What do you mean with respect to what?
Well, it has to be straight with respect to something, right?
When the ball leaves the person's hand, does it travel in a straight line?
It depends on what reference frame you're looking at it from.
Okay.
This is where we're getting to the problem.
So let's not beat around the bush.
I'm asking about. So yes, when you throw a ball, it should be inertial because no other forces are acting on it based on Newton's laws, and so it will go in a straight line with respect to the inertial reference frame.
Yeah, let me get this sentence out because I don't want to go half an hour. I said I'd make you do it quick.
I'm doing it quick.
So, on the merry-go-round, when the ball is thrown, it's traveling both in a straight line and in a curved path.
Correct.
Yes? It's not just a visual effect, yes?
No, it is actually what you will see. It actually has forces associated with it. It can be predicted. You can predict its paths in a point coordinate system, whether it be an inertial net reference frame or a non-inertial reference frame. So yes, in the inertial reference frame, it goes straight. In the non-inertial reference frame, it goes curved. And all the forces, all the positions, everything can be predicted based on what reference frame you are looking at it from.
There you go. You guys heard it. He said the ball both travels straight and curves at the same time. There you go. Dialetheism in a barrel, ladies and gentlemen.
You got to try to it if you like, SC. Make a reference frame where the ball is the coordinate. The ball is the reference frame. Now it's standing still, isn't it?
Oh, don't tell me you're going to go with.
No, now the ball.
This is Ruhiv's. It's both moving.
Standing still in a third reference frame, and we can come up with an infinite number of reference frames.
You guys hear that? This is Ruhiv's take on this. The ball can be both traveling and stationary, ladies and gentlemen, boys and girls, at the same time.
Depends on what you choose as the frame of reference, SC.
If you're on a train, SC, and you throw a ball, is it going 20 miles an hour when you throw it across the train, or is it going 60 miles an hour as viewed from someone on a park bench next to the train as it flies by? Which is true.
It's remarkable. I should just let you guys continue talking.
I answered your questions. Don't insult me. Just say, if I throw a ball inside of a train, which is correct? The 20 miles an hour I threw it to my friend a couple rows up, or me looking at it from a park bench as a train flies by, watching it go 80 miles an hour? Which is the correct speed of the ball?
Is the ball in? That's not what you're saying. Is the ball in motion or is it stationary?
You throw the ball in the train. And I view it from the train because I threw it, and I'm throwing it 20 miles an hour, a nice little lob to a guy 6 rows in front of me, and he catches it. Now, my brother is on a park bench outside the train as the train flies by, and he watches that ball through the windows travel across this field of view, and it looks like it's going 80 miles an hour because the train's going 60. How fast is the ball going?
That's not the same thing as the merry-go-round. You're saying that the ball is both traveling straight and curving at the same time.
Which is true? Let me ask you, the ball
that you threw in the train, is it taking a curve?
Which is the actual speed of the ball?
Do I get to talk, or you just talk?
Can you? This is why we know you're being Dunning-Kruger at this point.
What are you talking about, bro? You're changing the thing. Is the ball that you threw in the train going in a straight line or in a curved path?
No.
What is it? How is it moving?
I just want to give you a definition and an example for relativity.
Yeah, you're saying the two different speeds, but
20 miles an hour, or is it going 80 miles an hour?
It doesn't correlate to what we're talking about. We're talking about a ball traveling straight.
What is the actual?
Forget it, man. Forget it. Just talk with yourself. Somebody else talk with this lunatic.
Dude, it's just a matter of you not understanding that things are reference frame dependent. Everything you look at is reference frame dependent. And Blue just brought that up. He asked you, he even gave it one step further. But all I do is something very simple. If I look at it from a
Zanuck, the thing is, dude, no one wants to talk with you when you just interrupt people, you dominate over, you don't let anyone else speak. I was away from my computer. I was away from my computer. I even have to mute you while I'm talking. I was away from my computer, and I'm thinking, oh, Zanuck needs to be muted so SE can speak. Dude, it takes way too much work for us to have to do this every time. Either figure out how to speak in communication or don't come here, please.
Why can't people answer the questions? I give them the polite response. Why can't they give me one?
Well, because you ask a question and then you do what Rumpus does. You just start talking. You talk over them. Because you get triggered that you think they're wrong or something happened, and you just explode and you just have to talk. It's obnoxious.
He didn't respond, Gio. I responded to him. He made fun of me. I'm a dilithiocrystallistus. And then I asked him, well, what about the train thing? Which is the actual move? And then he goes on a complete other tangent. He can't answer the question. It's completely related to his question, by the way.
All right, but that doesn't really matter. In the communication, the best you can do is you make your point, 20 seconds. You pass the mic, they make their point. Even if they said something wrong or they didn't answer your question or whatever series of things you think that they didn't do correctly, that's fine. Stay calm, mute your mic, give them 30 seconds, 45 seconds. If you need to take notes while they're speaking, take notes. But they get their 30 seconds or minute or however long. And then when it's your turn, you can say, well, hello, sir. So what I'd like to say is I didn't agree with this, this, and that, because that way the audience can hear what's happening. Otherwise, it just turns into chaos. You're talking over everybody. You're triggered. You're spiraling. And the whole thing just turns to shit every time.
Okay, you're right. So I'll just one quick question, SC. The ball in the train, guy throws it going 20. Guy looks at it from the park bench. It looks like it's going 80. Which is the actual ball speed?
It depends on the person. The person on the train will see it going at 20, and the other person obviously will combine the speed of the train. What's so hard to understand about that?
So which is the actual speed?
What do you mean? Which is the actual?
Well, we know how fast the train's actually going, right?
60.
The actual speeds of things on. Yeah.
How fast is the ball actually going?
Train. Just like we know the actual path of the ball is straight on the merry-go-round.
Jeremy,
yeah,
I wanted
that's the actual issue.
You're making it a little more complicated. Just real simple, SC. Which is the actual speed?
80 miles an hour. We know the actual speed of the ball because we know what speed. We know what speeds they're going at. Which speed, and we know the actual. And we know the actual.
I wanted SC to answer. It's a critical question.
1 second. And we know the actual path of the ball when the guy throws it off the merry-go-round because we know how to throw a ball straight in reality. And we know that it's actually going straight and it only appears to curve. It's a visual effect.
Yeah, you're trying to skirt the question.
Your boy Bob. Remember that example that Bob thought wasn't Coriolis, that me and you knew was Coriolis? He told us that's just a visual effect.
And I showed how that was incorrect.
The visual effect. It's not Coriolis. Because it's the same exact fucking thing. You don't remember the example of two guys standing on the ground, one guy's throwing the ball? Bob said that's not Coriolis.
I'll ask one last time. What is the actual speed of the ball?
80 miles an hour.
SE, not you.
Yes, 80 miles an hour. You happy?
That's so the guy in the train seeing it go 20 is not correct.
Is the train actually going 60 miles an hour?
What if the Earth is traveling 30,000 miles an hour, 100,000 miles an hour?
Oh, here we go. You see what they do to
well, no,
to go
the point
around
is
the merry-go-round that he doesn't want to admit that it's crazy that he said it's traveling both straight and curving. He's doing this. This is why I don't want to talk to you, Zanuck. You're not an honest broker, bro. You're very... Forget it. Okay. I yield the mic to somebody else.
You said forget it. I was very clear in stating that motion is relative to the reference frame. And if you have, especially motion, where you're looking at inertial and non-inertial states, it is critical to identify what reference frame you're looking at, because in every reference frame, that motion can be plotted. Do you know what that means, plotted? In a point coordinate system, I can tell you where it is at any point in time, and I can plot its path and predict its future position based on that prior path. And that's going to change depending on what reference frame I'm looking at it. So every reference frame, actual path will be different if one's inertial or if they are inertial versus non-inertial reference frames.
Zanuck, you remember
it's not that hard to understand, SC. I know even you can understand this.
My bad. Zanuck, remember the example of that Bob didn't think was Coriolis?
He was wrong, and we talked about it. He got it at the end.
He was wrong, yes. However, while he was denying that was Coriolis, do you know what he said that was?
What?
You know what he said that was? He said it was just a visual effect.
That's exactly what Coriolis is. It's a visual effect. It's looking at a motion of. It's an
I've
object.
been saying that for years now. What did he just say? Did I just hear that correctly?
As viewed from a non-inertial reference frame, that is the effect. You'll see what you see is what the effect is. It's a curved path. That's the effect.
Oh my God! So you're changing your story now once again, Zanuck.
No, I'm not. So I'm gonna try a dilithium crystalism.
So we know the ball.
You're not listening. You're not listening.
So we know the ball's actually going straight. The
in
curved
an inertial reference frame.
And that the curved path.
In the non-inertial reference frame. It's an actual curved path. It actually is what you see. It's an effect called Coriolis. The view of objects seem to break. Okay.
God,
they seem to break the laws of Newton, but they're not really breaking the laws. They are reference frame dependent.
Jeremy's trolling us.
On the reference frame. Why is that so hard to understand?
The point is, it's just an optical illusion, a visual effect.
No, in the second reference frame, in the rotating reference frame, it actually happens. It truly can be plotted. You can predict its position, and it is a curved path, breaking all the laws of physics. That's how you know you're in a non-inertial reference frame.
Didn't you just say it's visual? Just 2 seconds ago.
Means you see it.
An optical illusion. That's what Bob was using.
Oh my God! Okay. That's what Bob was. You guys, this has been going on for 7 years. I don't expect me to change your obstinance in the subject matter. So I'll just.
I feel like banging my head against the wall. I swear to God, bro.
Because if you were studying physics and you were trying to look at relative motion, in fact, specifically in things like centrifuges or things where the objects do move in rotating reference frames, or certain in mechanics. In engineering that you need to know this, you will do transforms. And transforms allow you to plot and equate certain motion to inertial reference frames. So you have local reference frames and you have absolute reference frames. And this is part of physics. And you guys don't know it because you never took physics. So when you learn it, you'll understand, oh, I get it now. Now this makes sense why I need to know about this. But for you guys, it doesn't matter. It's just like double talk. All to you it is double talk.
Okay,
and it's not.
Yeah. Don't try to play us. Listen, we know how to throw a ball straight in actuality, right, Zanuck? Yes or no, please?
Try to throw it straight on a merry-go-round with spinning. Go ahead.
Do we know how to, Zanuck, in reality on Earth, do we know how to throw a ball?
In reality, on a spinning reference frame, yes. In a spinning reference frame. Good luck with that.
Zanuck, do we know how to throw a ball in
your buddy in your car as you yank on the steering wheel and take a left turn and have him fly out the right door. That's pseudo.
Do we know how to throw
reference frame dependent also, but it's very real. When he flies out the door, he's just like, yeah, it was real. I did 5 tumbles before I cracked my head on a pole. It's real. The effects are real, visual and real.
Do we know how to throw a ball in a straight line on Earth, or do you think that's not possible?
No, it's not possible.
Impossible to throw a ball in a straight line. Wow,
that's impossible.
All right, I guess never mind then.
Because you're looking at it from a rotating reference frame, and on rotating reference frames, all things thrown straight or in inertial states will have some degree of curve. As minuscule and minute as it may be, they are curving.
So we don't know how to throw a ball.
I thought he was kidding. Did you just realize what you made him say, bro?
Yeah, no, I know. I don't even know where to go from here because I didn't think he was going to say. I thought he was going to say, "Yeah, we know how to throw a ball in a straight line."
All objects moving in a rotating reference frame experience Coriolis. Period.
Yeah, so we don't know how to throw a ball on a straight line on Earth.
No, we don't. It's not possible.
Yeah, I hear
that. It's literally impossible.
Yeah.
In an inertial reference frame, it's impossible to throw something straight if that reference frame is not inertial.
Yeah, we can't throw a ball in a straight line on Earth. I gotcha.
Well, are there any inertial reference frames on Earth? You could make one. You could actually create one if you wanted to.
That's fine. I mean, you live in a world where we can't throw a ball in a straight line.
If you were to create an inertial reference frame, you could throw a straight ball.
No, we don't know how to throw. Yeah, of course you want. I bet you do want to take that back. You want to take a mulligan?
No, I didn't think about us being able to create an inertial reference frame. You could theoretically create an inertial reference frame and throw a ball straight.
So we do know how to throw a ball in a straight line.
It's complicated. It'd be very difficult to do, but you could do it.
Really? I could hand my
now we can do it. Now we can do it.
If you create a synthetic inertial reference frame, because nowhere on Earth are there inertial reference frames.
Synthetic? Oh, this is a new one now. Oh my God.
Yeah,
you're on a roll today,
you guys
bro.
on your toes.
You don't think some of those best baseball pitchers, the really good ones, can throw? I mean, I get if you're talking about straight. I guess if you go down to some micron level, but I mean they can throw a pretty damn straight. But they can throw a straight ball.
No, it's a touching that's always going to curve. Always. Has to. Based on the laws of physics.
Yeah. It has to curve, of course.
Are you saying because the Earth is rotating? Is that what your reason for that?
Of course.
Oh, okay. Well, that's your reason for real?
How do you have two objects that are on the surface of a spinning body that doesn't experience Coriolis? It's not possible because by definition, that's what Coriolis is. An object moving in a rotating reference frame will experience Coriolis, period.
It has to. It's required. It's not even the right question. The question is whether or not the Earth is spinning. Because if it is, Coriolis is mandatory. You can't get away from it. It has to be there.
Agreed, yeah, if it's spinning.
Okay, so
this is the big eye here.
Not on Coriolis. Coriolis is exactly what Xanax says it is.
Blue, do you think we know how to throw a ball in a straight line?
I agree with what he said. You're in a non-inertial frame of reference here on the Earth. It's not possible for anything to move in a straight line under those conditions. It can't be done. You would have to generate one way or the other an inertial frame.
So, I mean, you guys live in a world where we can't throw a ball in a straight line. I mean, I could hand a 10-year-old a ball and tell them throw it in a straight line, and they'll probably get it pretty close.
Yeah, over the distances we're talking about, as small as that force is, sure, it's going to look like straight to you.
You know what else I could do? I could put a ruler on the ground. Follow the path of the ball over the ruler and see if it went in a straight, or a straight ruler. Can rulers be straight?
You follow the path of the ball over the ruler. Yeah, you could do all that.
And rulers can be straight?
How about the merry-go-round? Could you
plot the basics
all over that merry-go-round?
I know we got to start at the basics though, because I feel like we're way off in the weeds. So, are rulers straight?
You should be able to get a straight one, yeah.
Yeah, we can get a straight ruler. Yeah, no doubt. I believe you. So we can put a straight ruler on the ground, right?
Yeah.
Then we can throw a ball over. Maybe we throw it 10 times, and somebody can't throw it perfectly straight. But eventually, somebody's going to get it to go directly over the path of the ruler, right?
Yeah.
Yeah. So we just threw a ball in a straight line.
Can you throw a ball in a curve? Can you throw a curveball?
Yeah, but no. Let's not get off of this thing real quick because We just did throw a ball in a straight line, right? It followed the path of the ruler, the straight ruler.
Okay, all right.
Yeah, but they're talking on a different scale, though. You know the way they say with the bullet. It's not really going to. Coriolis is not going to be in effect unless it's a long enough distance. So
I know, but we're just talking about on the merry-go-round thing. I don't want to bring it to Earth yet because they can't even get the merry-go-round thing straight, Gio.
No, yeah, I'd like to get the merry-go-round thing straight.
I've got it.
We're doing that right now. We're doing a merry-go-round thing.
I listened to Zanic's explanation and Blue's explanation, and it makes sense. And the first thing I thought of was the merry-go-round. If you spin it really slow and have two people throw a couple of balls and film it, all right, and throw balls to each other, those balls look like they're going in a straight line. But you speed the film up, those balls are actually moving in curved lines. That makes sense to me. That's something my tiny little brain can figure out.
So you're saying a ball could travel both in a straight line and be curving at the same time, like Zanuck, correct?
Yeah, depending on who is looking at it. If you got two kids throwing a ball to each other on a merry-go-round spinning slowly, they will, to them, those balls, as they throw them, they can catch them, no problem. To those two kids, those balls are moving in a straight line. But if you film it and then watch the film, if you track those balls and track their path, those balls will be moving in curve lines because you're looking at it from a different viewpoint.
But that's not the question. I understand the different perspective of the viewers. That's not the question, though.
Oh, okay.
Irrespective of the two viewers' perspective, what is the ball's true path?
The ball's true path is curved.
Even though you threw it straight?
Even though you threw it straight. Yes, I mean, what is it? If you look at it, I mean, imagine you're looking at two kids throwing a ball backwards and forwards. To you, as you watch it, and they're going around the merry-go-round, it doesn't even have to go that slow, does it? So just, one revolution a minute. You can watch the merry-go-round turn and see the path of the ball's actually curving. But to the kids, it looks, the balls are actually moving in curved lines, yeah.
No, you almost said it. You almost said
there is no actual. No, I was just going to correct this and say there is no true path. There's an actual path.
That's right. I think that's where you're confused.
I mean,
there's no such thing as the true path of the ball.
Okay.
The path of the ball is the path it takes depending on the frame of reference
I got you.
From.
So in physics, that's okay. That makes sense too.
That's why they film they film those things the way they do. They film it from the rotating frame of reference, and the ball is curving. When you film it from an inertial frame, non-rotating frame, the ball appears to go straight. It's doing both things. It just depends on where you're filming it from, where you're observing. And they do a bad job of pointing out why they're making those two different observations. But that's really what they're showing you. It is reference frame dependent. What the ball is doing is dependent on the frame of reference you're in.
Yeah, that's.
I'm astonished that you guys think that.
I'm just glad we agreed that we could put a straight ruler down on the ground, throw a ball, and know that the ball actually went straight. That was a big step forward. Step forward for you guys.
The question then, it's really because the Earth is moving. Then it's like, is it really going straight? That's the debate, really, isn't it?
Yeah, we're just trying to get down to the merry-go-round thing. So we got the ball, we got the ruler on the ground. We throw the ball in a straight line. It's just like the thing Bob denied was Coriolis. He told you it was just a visual effect. It's all optical. The ball's going straight.
It's but it's.
I've been telling them that for years, Jeremy. Years.
I know.
It's a visual effect.
No, I mean, wait a second. Is that true? Hold on. Is that Bob guy? Is that true? Is the ball really not moving and curved, or it is moving? I don't know.
When you release the ball travels in a straight line.
It's true that it's
very
visually.
Simple, man.
It's true that it's optically moving one way for one person and another way for someone else. It's true that it's visually moving one way for one person and another person. And it's also true that the path is doing one thing for one person and something for another different person.
Right.
Something can be visual and optical and apparent and also true.
I can understand that.
Oh, so are you showing Don a good time? My bad. Go ahead. Jesse.
No, it's my bad. Go ahead. That's all I wanted to say. I can't. Go ahead, Jeremy.
I can't go on with this. It's ridiculous. In a world where we can't throw a ball in a straight line, I don't know.
Yeah,
I could hand a
I'm with you.
10-year-old.
It's ridiculous.
I could hand a 10-year-old to tell him to throw the ball in a straight line. Put a ruler down on the ground, and I can, you could have a camera above the ruler and see. Oh, look, yeah, they did make it go in a straight line that time.
What is the problem with the analogy of the merry-go-round, the two kids throwing the balls backwards and forwards?
We're going to get to the merry-go-round as soon as we understand that we can throw a ball in a straight line or not. Do you think we can throw a ball in a straight line, Hugh?
Yeah. Yes,
so
of course you can. Because a child typically isn't very good at throwing. I was rubbish when I was a kid at throwing balls and catching balls. So they appear, if someone throws a ball to me, I catch it. Yeah, if it was curving and everything, it'd be very hard to catch. So I can
ball in a straight line. I know.
But is the ball really moving in a straight line? It's almost philosophical in a way, isn't it?
That's what we're trying to get to the bottom of. But as far as we know, we put a ruler.
Yeah, but the argument they're making on the globe Earth is because of Coriolis. So for a moment, if the Earth is, let's say, stationary in nature, and let's just say, I'll just use the word ether for a moment. If there's ether drift or ether wind that's causing the drift, then in that sense, Jeremy, you can't throw a ball in a straight line because it will drift.
I know, but according to the guy on the merry-go-round, we know that if we put a ruler down on the ground, we can make it go on a straight line. According to us, it's between us. It's between us standing still and the merry-go-round at this point.
Well, imagine
they don't believe in the ether, so I don't know where that came from. The ether group.
Yeah. No, I know, but I was saying that the reason that they say it you can't in this context, it sounds like from what's being said that something can't go in a straight line is because of Coriolis, because the Earth is spinning, etc. What I was saying is that if you just replace Earth spinning Coriolis with ether drift, then it's the same concept. Or it's a
I get you.
Concept.
I get you. But imagine this. I'm just thought of this. Someone slap me down if this is stupid.
Don't worry, we will.
I know you will. Imagine if there's somebody that lives on the merry-go-round and lives there. Everything will appear to be moving in a certain way, but is in fact moving in a different way. And he will only know that it's moving, the ball's being thrown, but moving in a straight line. There you go. I don't know if that was ridiculous or not, but I threw it out there anyway.
Where you're going with it. The thing is, Gio, we're just talking about the merry-go-round and us on Earth, right? Now, we know on Earth we can throw the ball in a straight line. I know they say the Earth's rotating and we can't, however, we can put a ruler down on the ground, see that the ball's going in a straight line.
Yeah, I think the Xanax probably...
Compared to the merry-go-round where you see it curve crazy, we know it's not curving crazy because it went over the straight line of the ruler we had on the ground, right?
That's right.
Jeremy,
yeah.
You will understand reference frames soon. I know God's will that you will understand reference frames. Listen, Jeremy, when you talk about the kid and you talk about the ruler and you talk about throwing the ball in a straight line, indeed he can. You can get a kid to throw a ball in a straight line across a ruler in that reference frame. In that reference frame, the ball is making a path. That ball is not making that same path in different reference frames though. In other reference frames, that ball's making a different path. So
I realize that. So in the merry-go-round analogy, we have in the merry-go-round analogy, we have two reference frames, right? You're standing still on Earth, you have the inertial frame, and then you're rotating on a merry-go-round. You have your non-inertial frame, right?
Wrong.
That's wrong.
You don't need two. It's not two reference frames, Jeremy. Nothing is. When you're throwing the ball listen, when you're throwing the ball on the merry-go-round, you're only concerned about the rotating frame of reference. An inertial reference frame makes no difference to you whatsoever. The ball is not moving in that inertial frame. It's moving in the non-inertial frame.
Zanuck, are you hearing this?
I'm involved.
Zanuck, are you hearing this, bud?
Zanuck, where are you? Big Blue is talking.
Blue needs your help with Coriolis.
No, I don't.
Xanic's not in the VC.
Oh, he left?
Dude, Blue just said it just fine, dude.
Because I even understand Coriolis.
You guys get confused by words that were written in Wikipedia, where they talk about an inertial frame of reference, but you need to read exactly what that says. That inertial reference frame is only to establish the fact that the object is moving in a non-inertial reference frame. Once you've established,
right, so in the inertial frame,
makes no difference.
Okay, so in the non-inertial frame, the ball appears to deviate. However, in the inertial frame, it appears to go straight.
It actually does deviate in the non-inertial frame. It actually does go straight, and if it were in an inertial frame.
Yeah, we know.
And it actually stands still if you pick the right reference frame.
Yeah, so the ball can be standing still and moving at the same time. Yeah, the ball's reference frame's not even a thing. All you need for Coriolis is the 2 reference frames. I don't know why he keeps bringing up this weird 3rd reference frame of the ball. It's weird, Blue.
An ant on the ball. An ant standing on the ball.
Yeah, but you don't need that 3rd.
And it's not the inertial reference frame. There are billions of them. An infinite number of inertial reference frames, none of which makes any difference. The only reference frame that matters is the non-inertial frame you're in. That's the only one that matters.
I know you guys do this infinite reference frame thing all the time to try to confuse it and whatnot. We're only concerned with 2 reference frames, the inertial and the non-inertial one. That's how it's described by major universities. Everyone that describes it uses these 2 reference frames. It's all you need to describe Coriolis is these 2 reference frames. No need to bring up the infinite amount of reference frames that could possibly exist everywhere in the universe. That's ridiculous. That's you're trying to make shit more confusing and convoluted. I know the tactics. We definitely know the tactics. You don't. I know. I mean, I know you're going to keep doing it no matter what. But
well, if you want to simplify it, drop the inertial frame because it's
exactly. He just told you 1 reference frame. He didn't say he told you a billion because he's letting you know there's a billion of them. But he's saying when you're describing Coriolis, you only need 1. There's just 1 that's being described.
Only 1.
Yeah, but you can use 2.
It's only 1 now. It's truly unbelievable how this has evolved. How they keep changing.
I wish Xanic was still here.
This is like a philosophical and like mental exercise. Like doctors should examine this kind of stuff. It's fascinating.
I have never changed this at all. Not once, Issy. I've been saying this same thing for years now.
You've been wrong for years.
It's like saying that the universe is big. The universe isn't big to make us feel small. It's just big. And reference frames aren't there to make us get confused. They're just there.
Yeah, but you've been saying for years 2 reference frames, 1 inertial, 1 non-inertial, and now you're saying it's only 1 reference frame. I mean, it's almost comical talking with you guys now, man. Seriously.
He didn't say that.
Yeah, see, I'll go back and pull out a video, one of the videos I did from 2 years ago, and you can hear me say exactly what I just said.
Well, maybe you, Blue, but everybody else says there's 2 reference frames. Always been saying there's 2 reference frames.
I've said the same thing as Bob, adamantly, and continuously, and Jeremy will tell you. So many of us have said 1 reference frame.
This is entirely new stuff, man. I don't know.
Because you look at things from 2 different viewpoints, it doesn't mean there are only 2 different viewpoints to look at it.
That's just a comparison. You're just comparing it. The Coriolis is strictly regarding the rotating frame.
In reference to what? I'll give you one of your famous things. In reference to what?
There you go, Essie. In reference to what?
That's just it. They don't use real life Coriolis. They use what Coriolis could possibly be on a model, so they never leave the in their example, they never leave the inertial reference frame. It's just some fucking fantasy shit.
We're trying to use real life examples in the merry-go-round, but we can't get past the bullshit because I don't know. They don't want to admit there's 2 reference frames. They want there to be infinite reference frames, or they want the ball standing still and moving at the same time. Like it's.
Then
they don't discuss action and Coriolis, bro.
I thought we were doing all right.
They don't discuss.
You think this is us doing all right?
Yeah.
Yeah.
It is. It's really okay.
Tell me this, Jeremy, if you want to talk about the inertial frame. We know what the non-inertial frame is. It is the merry-go-round. That is our non-inertial frame of reference. What is the inertial frame?
So now we're back to 2 frames of reference. Before there was only 1, now it's 2 again?
No, it's not. But I want to know what he thinks the inertial frame of reference is. Where is it?
It's anywhere that's not moving with respect to the non-inertial frame.
That would be an awful lot of places, wouldn't it?
Yeah, it's everywhere. Everywhere but the merry-go-round. Trying to quiz me like I don't know what the inertial frame is?
You keep saying the inertial frame. And then you say
the inertial frame.
Everywhere.
The inertial frame. I just told you where it is.
It's everywhere.
Whatever's not moving with respect to the merry-go-round.
Blue, let's see if you could expand your mind. Let's see how just a little it ain't a right or wrong. It ain't a right or wrong thing, but I'm just curious. Can you describe Coriolis, the Coriolis effect? Let's say just hypothetically speaking, they proved that the Earth's not moving. Could you then define Coriolis effect for us?
There cannot be any Coriolis effects. Coriolis can only occur in a rotating frame of reference.
Right. But can you describe Coriolis without using
the non-inertial, which means it's accelerating. It has to be rotating.
That's what I mean. Could you describe it not using the Earth as the inertial reference frame, just to entertain it?
The Earth is not an inertial frame. But
I meant the non-inertial. You know what I meant.
That's debatable.
Can you define Coriolis without using the Earth? Yeah, we do it in machinery.
Can you give me an example of a Coriolis without using the Earth?
Sure. Coriolis flow meter. Mass flow meters.
I could do it, Brian. You want me to do it?
Those exist, by the way. I've checked it out. Those are actual things, what Blue just said. That's an actual thing, not a made up visual thing. That's actually flowing stuff and being measured. Yes.
All right, you want me to do it without using Earth?
Well, the guy.
Yeah. Give me an example of an actual demonstration.
Well, the guy. It's named Coriolis because of the guy who invented it, or who came to some of these ideas. And originally, it was not connected to the Earth at all. It was connected to mechanical systems.
Blue, you can't give Brian an example of the Coriolis effect without using Earth?
I just did.
I'm sure he can.
A ball being thrown on a roundabout is an example. Anybody not on the roundabout is going to see the ball go in a straight line. Anyone in that reference frame. Pick one. Pick any.
Dude, what happened to Blue's voice?
Deja vu.
Blue's voice just went crazy, man.
What's up, Fuzzy?
What's going on? This is so simple. Imagine 20 different people standing around a merry-go-round. All of those people, all of their frame of reference, they're all in the same frame of reference, different spots in that reference frame, but none of them are spinning with the merry-go-round. Pick any one of those people. If a ball is thrown on the merry-go-round, it's going to look like it's going in a straight line. That reference frame is anybody outside.
Yes.
Yeah, exactly. How does he not understand that? And anyone standing on the merry-go-round, their frame of reference is this rotating, spinning one.
They don't get that somehow.
I don't understand.
It blows my mind, bro. Blows my mind.
What am I? Explain that again, because I'm not getting what you're saying.
Someone said there are an infinite number of reference frame of what is it? Inertial or non-inertial. What did you say before? I can't remember what you said. There's an infinite number of places where someone can stand off of the merry-go-round in the entire park. You could go to the swing, you could go over near the slide, you could go to the basketball courts, the tennis court. You could stand anywhere you want to stand in that park. You're not standing on the merry-go-round. Anyone standing on the merry-go-round, their frame of reference is now this spinning, rotating reference frame.
Okay, but hey, Fuzzy, here's a little idea I just popped in my head. What if each of the observers is walking in a different direction?
It doesn't matter. Well,
indeed it does.
Their observation of a ball being thrown on the roundabout is the ball is going to go in a straight line from their reference frame.
For my right? Where I'm understanding it, if there's 20 people watching the ball being thrown backwards and forwards on a merry-go-round, and each one of them is walking, they're looking at the ball from 20 different reference frames. If there's 1,000 people, that's 1,000 different reference frames.
I'm sorry. They're standing. No, there's only 2 reference frames. There's different perspectives from each reference frame, but there's only 2 reference frames in our example. Many infinite number of perspective options from within that reference frame.
Yeah, anybody moving would be. There could be other reference frames, but you're describing more inertial. Non-inertial reference frames. When we describe Coriolis and the way the universities and the way anywhere you look for it, except for in the debates, that they describe Coriolis being using an inertial and a non-inertial reference frame. So if you're describing people walking different directions, you're just adding in more non-inertial reference frames. But you could do that. But that's accurate. But
that's fine. But I think I
was just looking for a demonstrate. I was just seeing if Blue would give us an explanation, an example of Coriolis without using the Earth.
Yeah, he did. But I was going to say that sounds right to me. I mean, if you the ball being thrown back and forwards, and someone looks at it both are true. I think there was discussion that both things are true. So 2 things which appear to contradict can both be actually factually true.
No, but it never changes the fact. It never changes the fact.
Hold on. No, it depends on how you define what it is you're saying. When if someone's throwing the ball back and forth in a straight line, it appears to be deviating.
Yes.
So as long as you say
the ball is always going in a straight line in reality.
Okay. So it's not true. It appears to be true, if that makes sense.
Sure.
It actually curves.
Oh no! Here we go.
Oh hey, how's it going, Brenda?
Brenda, did you hear that question? Let's see if how good you can expand your mind. Can you give me a verbal explanation of Coriolis without using the Earth as a non-inertial reference frame?
Coriolis
actual Coriolis that we could demonstrate. Give me a verbal example.
Coriolis is the conservation of momentum from an inertial frame to a non-inertial frame, right?
Yeah, that's what I'm saying. Give me an example.
I just did.
Use merry-go-round or no, don't define it. Give me an example of everything you just explained.
When you have a rotating reference frame, right? And then you have
use one. Give me an example. Like use one. Say somebody's on the rotating reference frame. Actually give me an actual example, and then redefine it.
Yeah. If you're taking off, say from the equator, you have a cannon, and you shoot a cannonball north.
Brenda. The example was to not use Earth. You an example of Coriolis without using Earth.
Okay, then Mars.
No, use a inertial reference. I mean, a non-inertial reference frame that we can all see.
Any rotating body.
Anything but Earth. Anything but planets. Use something down here, down home.
Merry-go-round.
There you go. Now do the story.
Right, you're on a merry-go-round, right? You have a ball, and you try to pass it to. You're sitting, say, on the outer edge of the ball. You have a friend opposite on the merry-go-round to you. You try to pass the ball to them. The ball will curve and you will miss them. It actually curves.
Okay, does it actually curve to the other observers, the ones in the inertial reference frame?
The ball is the inertial reference frame, so nobody's on the. If I'm an ant on the ball, it would appear to me that I travel in a straight line. If I'm on the merry-go-round, it appears to me that the ball diverges.
I'm trying to get you to give an example of I'm trying to get you away from ants and planets and shit like that. I'm trying to get you to give me like a real world example of Coriolis we can observe down here on the ground that doesn't involve the Earth being the non-inertial reference frame.
Is the merry-go-round okay?
Yeah, but,
is
but
that okay?
Well, right. No, you're right.
Yes, the merry-go-round's fine.
Both traveling in a straight line, while the rotating frame of reference, in this case being the merry-go-round, rotates underneath the ball.
Hold on, dude. I want to hear do it by definition, because there's got to be an inertial reference frame in this example.
In this example, I'm sitting on the edge of the merry-go-round. My friend is opposite to me, also sitting on the edge and facing me.
So that's the non-inertial reference frame, right? Now, give me an example of.
It's not inertial because we're rotating with the merry-go-round.
Now give me an inertial reference frame.
I'm going to pass a ball. I'm going to pass a ball from me to my friend. That's the inertial reference frame. I throw it at my friend.
How can that be what's inertial? What's non-moving?
I just read something off Wiki real quick. Or never mind. Go ahead, Brenda. Go ahead.
Inertial means not accelerating. It doesn't mean non-moving.
Give me the non-moving reference frame.
No, inertial means not accelerating, not non-moving.
Brenda,
give me a
would you agree that the ant and the ball going in a straight line and somebody standing off of the spinning merry-go-round watching the ball going in a straight line are both in the same reference frame? Watching the ball go in the straight line and being on the ball going in a straight line, they're both in the same reference frame. Well, kind of, because you're not on the ball.
They're not. They're not. The reference frame is the ball.
Both people are observing a straight line. Both observations are observing a straight line.
No, the ball,
and
the coordinate
system.
Reference system is
the ball.
Yes.
Hold on, Brenda. You said the inertial reference frame is the ball, and then you described the inertial reference frame as something that's not accelerating. Is the ball accelerating?
No.
Really?
Really? I pass it to my. I pass it.
The ball a drone?
No, I just throw it. I throw it to my friend.
So when you throw something, when I throw a brick, I'm not accelerating the brick, Brenda.
Yeah, you're given it a set speed. It's traveling at a given velocity. It's not accelerating.
So somebody on this merry-go-round throwing a ball is not accelerating the ball at a certain velocity?
Right. Correct.
What are you talking about?
Correct. They are giving the ball an initial velocity, which it maintains throughout its flight.
So how can you say that it's actually curving if there's an ant on the ball that sees it go straight and it to the ant is going straight because it was thrown straight? How can you say it's actually curving, Brenda?
Well, because I'm on the the non-inertial reference frame, and to me it appears to diverge. No, it's actual.
To you, but actual is not. You can't say it's actually curving if it's just your frame of reference that makes it look like
that's what frames of reference are. It's a point of view.
But it's only an apparent
not
observation.
Actual.
The ant knows that they're actually going in a straight line. People on the ground, on the spinning merry-go-round, they look like it's curving, but the ant knows for real. Oh no, I'm actually going in a straight line. They only think they're only seeing that it appears that I'm curving.
There's no such.
Yeah, the reason the friend doesn't catch it is because the friend's spinning, and the ball is going straight. And since the friend is spinning, he's going to miss the ball that's going straight.
I missed him. It diverged because of Coriolis. It really missed him. It didn't.
They literally don't understand this. I thought they understood it. I thought they understood it, but didn't agree with it. They literally do not understand this. It's crazy.
Can I just read this off a wiki real quick? Fuzzy, please.
Yeah, go ahead. Go for it.
In the inertial frame of reference, the black object moves in a straight line.
Correct.
However, the observer who is standing in the rotating straight line. However, the observer who is standing in the rotating frame of reference sees the object as following a curved path. So,
correct.
In one instance, they say they see the ball move in a curved path. In another instance, they say it moves in a straight line.
That's correct.
Right. So if the person on the road, if your friend on the other side of the merry-go-round, would the ball hit their head? If they
no, it would miss. It would diverge.
No. Hold on. Wait. Hold on. Would it hit their head if all of a sudden now when the merry-go-round stopped, I could throw the ball, it would hit them, right? The only reason it's missing is because what? Is because they're rotating underneath it, out of the way.
Because the ball's not actually curving, Brenda. The ball's going straight. You can't say it's actually curving if it's not.
No, it actually does curve. It actually misses him. I aim for him. It
only missed him because the friend moved, not the ball.
Yeah, the friend moved. It went in a straight line. Imagine.
It went in a straight line. You're right. You're right. It went in a straight line, but it did in fact diverge and miss him. Yeah.
Okay. What if? So as soon as I throw the ball, all of a sudden the merry-go-round stops. Does the ball hit him in the head, or does it miss?
I don't. Well, it depends on where in the path of the ball.
Yeah, I threw the ball to my friend's head so that they could catch it.
Yeah.
Right? If he doesn't, right? If he goes to catch it, but then all of a sudden we spin up the merry-go-round again, he's going to miss the ball, right? He's going to be out of the way of the path of the ball.
Yeah. So the point you're getting here is not getting here. Is there's no such thing as an absolute frame of reference.
I'm not getting. Do you know what a path? Oh, I know. My God,
there are two different.
What's the argument here?
There are two different frames of reference. One frame of reference is the ball. The other is me on the merry-go-round. And so you're getting hung up on the apparent contradiction, but they're two different points of view. So it's not a contradiction. It's not a contradiction to say the ball traveled in a straight line.
Yeah, but what I asked you for, hold on. What I asked you for was a real life, observer.
I thought I gave it to you.
Hold on. Let me finish. To observe something, you got to be, you got to be an observer. And Coriolis is defined as an apparent deflection. So if there's no observer,
there's no
observer to see it go in a straight line, it's not Coriolis. Okay,
no,
Coriolis is an apparent.
Not defined.
Please finish. I'm almost done, Brenda. I'm really almost done. If I can just finish my sentence, please. Okay, Coriolis is defined as an apparent deflection, not a real deflection. Okay, it's observer dependent.
Stop saying that. You're wrong. It's not an apparent deflection. Coriolis is defined as the conservation of momentum. That's what the cause of the Coriolis effect is. The conservation of momentum. You've been listening.
Brenda, I can't even believe that you're saying this. Brenda, you're saying two things contradictory in the same sentence.
Because they're two different points of view. So it's not a contradiction.
Well, give me the point of view of the ball. Who's viewing that? The ball?
Classic dialetheism. Classic.
No matter what, she won't use an example of another observer. She won't do it.
An observer on the ball.
She really doesn't understand. I thought that they understood and just disagreed. I see that she literally does not understand actual Coriolis.
From an observer's point of view.
Ryan, we understand this perfectly.
You don't. From the
no, she doesn't, bro. I asked her for an example without using the urge.
We understand this perfectly.
Example down to earth, the way we see it, the way we can demonstrate it in real life.
I don't understand. Using the ball. What's your argument, bro? What's the argument?
Okay, to observe a deflection, to observe it, to observe it go straight, you got to have an observer, right? Could you at least agree with that?
Brenda, just the fact that you said that it's defined as the conservation of momentum, you cite that. Show us a definition where it defines it as the conservation
Jesus Christ,
of momentum.
It's in every physics textbook.
Okay, cite one.
Again, Brenda, you're arguing.
Go to the hyperphysics.
Brenda, you're arguing with people that haven't never taken a physics course.
I know.
Bro, we understand your definition of Coriolis. We're just trying to see if she understood ours, okay? And the fact of the matter is she don't. I wasn't trying to argue. All I was trying to do is see if she could expand her mind.
Incorrect.
God dang, I can't finish a sentence, man. I'm trying to be quick too. All I was trying to do is see if she could expand her mind and do it as an apparent deflection from an observer in a freaking another reference frame. I was trying to get her to use two reference frames being observed from two reference frames.
Yeah, that's not what Coriolis
She can't do it.
That's
She's not capable because she doesn't understand.
No, because that is the wrong definition of Coriolis. Nathan Oakley is
Doesn't matter. It's what I asked you for.
Oakley is a liar and a con artist. He's a liar. He's told you
nothing to do with Nathan Oakley.
Brenda,
B-ball, did you agree with Brenda? Wait, B-ball, did you say you agreed with Brenda that the actual definition of Coriolis effect is the conservation of momentum? Simply put, did you agree with him?
I'm sorry. Say again.
You said you're talking to people that have never taken a physics course, which is not true. But you agreed with Brenda about the conservation of momentum being the definition of Coriolis.
So you have taken it. So you have taken a physics course.
That's what you got out of that question, B-ball.
I'm just curious.
Wait, I want to know if you agree because you piped up and said a comment. There's lots of people in here that have taken physics course.
Yes, I do agree. I do. Yes, I do agree.
So conservation of momentum is the definition. Conservation of cite that. Cite a definition of Coriolis effect saying it is the conservation of momentum.
What are you gonna say when I find it? You're gonna say you were wrong, or are you gonna say you were incorrect?
I would say that's new to me.
It's already been posted, bro.
I've never heard that definition before.
Okay.
Yeah, and I listen. I understand that definition. I understand how y'all apply it in a fictitious model. Okay, and if the model was real, then maybe that would happen. I was just trying to see if y'all could entertain and understand the way we describe it, just to see if she understood it. That's all. Nothing more. I ain't bringing up Nathan. I'm not trying to get her to concede that that's the reality of it. I just wanted to see if she could give me a demonstration from two different observational points, an inertial and a non-inertial, with an observer, but she couldn't because she literally doesn't understand. So she can't disagree with it. She doesn't even understand what she's disagreeing with.
Goes in a straight line. She said that literally in one sentence. She said it actually curves, but it actually goes in a straight line. So it can't actually do both.
Classic case of dialetheism.
So how can she disagree with us when she doesn't even understand? That's the whole point.
This whole argument is not about defining Coriolis. We all can understand Coriolis in the way it would work on a merry-go-round. The problem is there's something called Coriolis effect, there's something called Coriolis force, and then there's the idea of the Coriolis displacement if an object is traveling in a straight line over a rotating body. And all those things get conflated, and the whole idea of Coriolis is conflated to seem like it's supposed to work on a ball, and we're not on a ball. That's the problem.
Right.
That's why
I'm trying to get her to give me real life, like I was trying to get her to give me actual real life Coriolis, something we can demonstrate.
Didn't I do that?
No.
Yeah.
You used the ant. Since I didn't let you use the Earth, you used the ant on a ball.
Yeah, where in real life do you see ants on balls observing Coriolis?
You agreed that the merry-go-round was an okay example, so I don't know what else you want.
Brenda, you said the ball's going straight and it's curving. Okay.
From two different points, Brian. From
your observer was you gave one of your points of view as the point of view of an ant, Brenda. That's not real.
Brenda,
yes, it is.
No, the ant's perspective is real because that's the actual path.
Brenda, that's why it's called an effect. Like the Coriolis, like a when something's obscuring your vision, it's like there's an effect. There's a optical effect going on.
So I could.
One is actually true. One appears to be true, even though it's not actually, because from a different vantage point, you can actually articulate. Oh, it's actually going in a straight line. These people are wrong, even though it looks like they're correct. It's an effect.
So I could just strap a GoPro onto the ball.
Yeah, you could, and it would go in a straight line, and the person underneath the ball that's moving would move in and out of the path of a straight ball, going in a straight line. Someone
Okay,
underneath
wait.
that
She
moving
just
back
said
and forth.
she just said it would actually go on a straight path. Now, are you saying it actually curves too?
It curves from a different point of view.
Appears to curve, not
What
actually.
It appears to go straight from a different point of view too.
No, it actually goes straight.
But Brenda, would you agree that in one of the point of views, it actually is in fact going straight?
That's what I'm trying to tell you, is that is wrong. There's no absolute frame of reference. It simply depends. It simply let me complete the explanation. It simply depends on your point of view, right? Whether or not it's true that you're traveling in a straight line or a curved line. If both cases are
give me
true.
An example. Give me an example of that.
I'm giving it to you.
No, both cases.
No, you didn't. You used the ant. Hold on. She just said me, and now she's saying she gave it to me, but she gave me an ant's perspective. Give me a person's perspective, okay, from both reference frames, please.
What about the vector of force that's applied on the ball? How are you applying it so that it curves?
And nowhere in your explanation did you even mention conservation of momentum, which you said was the definition of Coriolis.
The ball in the inertial reference frame, right, that's traveling from my hands across the merry-go-round maintains the initial force that I gave it when it left my hands. So
that's not the Coriolis effect. Right? That's not the Coriolis effect. That's just the initial.
That's literally the definition. That's literally the definition of the Coriolis.
No, it's not.
The initial force that you gave
it literally is.
The initial force that you gave it was in a straight vector, right? It wasn't like some spin, like Magnus effect type thing. It was just straight.
Yeah,
throwing the
we're
ball, right?
just going to assume all those things because we want to eliminate variables.
Wait, we got to get this straight. Are you saying that Coriolis effect is synonymous with conservation of momentum?
So, Mr. New Perspective, could you read? Hold on, Mr. New Perspective, can you read the thing I
Sorry, go ahead.
Could you read the thing I tagged you with in the chat, please?
This paper presents a qualitative analysis of the Coriolis force that's different than the Coriolis effect to begin with. We're talking about, that's why I made the distinction just a minute ago. We're talking about Coriolis force and Coriolis effect as if they're the same thing. And this is not Coriolis effect. This is not the definition of a Coriolis effect. That's what we asked. Find me a site. I'm not going to read a site that I didn't ask for. I asked for the Coriolis effect definition, not the Coriolis force.
Okay, what's the difference between Coriolis effect and Coriolis force?
Do you really not know, or are you testing me?
Can you tell me? Can you tell me?
No, I'm asking if you know. Obviously you don't, because you cited Coriolis force when I asked for Coriolis effect. They're two different things.
Can you tell me the difference, please?
I want to know if you know, because you didn't. I'm not going to even entertain that.
I don't. I know. Okay, sure. I don't know. So you tell me.
You're roboting. I can't hear you. What were you going to ask?
Yeah, you're roboting. I want to ask Brenda.
I don't know. Brenda. So you tell me. I don't know the difference. So tell me.
B-Ball, let me ask you a question. You or Brenda can answer this real quick.
No. I don't know the difference. So I want you to tell me the difference.
Find out, right? Can I ask you a question?
Oh, okay. So maybe he doesn't know either.
Oh, I totally know.
Let me ask you a question, man. This might help.
Okay, all right.
They don't apply to the.
Okay, what is this effect called? Okay, tell me what you call this effect here. If you have a spinning non-inertial reference frame, and you throw a ball, and you have an observer and a non-inertial, inertial non-moving reference frame watching the ball, and to the people on the spinning reference frame, the ball appears to curve, but to the viewer in the reference frame that's not moving, the ball appears to go straight. What's that effect called? There's a name for it.
I didn't really understand much of that.
Yeah, okay, I'll simplify it. You have a spinning reference frame, and you have two people, you and B-Ball. He throws you the ball. It appears to drift. Okay, I'm observing from another reference frame. I'm observing from a non-moving reference frame.
From where?
Okay, what? It appeared, and I see the ball go straight. What's that effect called?
You wouldn't see the ball go straight.
I see when you throw it to B-Ball on the merry-go-round, it appears to curve because y'all are spinning, but I see it go straight because I'm not spinning. What's that effect called?
It's from the perspective of the ball. It's not. I'm
just asking, what's that effect called? That's all I'm asking. I'm not. You don't got to explain it no more. I just gave you the situation. What's that effect called?
It's called Coriolis effect.
I'm asking them.
Yes, the Coriolis effect.
Thank you. At least B-Ball understands, whether he agrees or whatever. At least he understands that that's called the Coriolis effect.
Do you understand? It's just a point of view.
Exactly, Brenda. That's the reason we're saying that.
That's exactly what it is. That's exactly Eureka. It's a point of view, Brenda.
Hold up. He's trying
of an object.
To say it's just a point of view.
The deflection of an object is due to the Coriolis force is called the Coriolis effect.
Did she just say that? It's just a point of view after all this?
Yeah.
Just
that's
point of view.
It is a point of view. It's apparent.
Let me get this out really quick.
Yeah, exactly, right? Eureka.
Deflection of an object.
It actually curves. The ball actually curves, but it's just a point of view. It actually curves, but it's just a point of view. It actually curves, but it's just a point of view.
Deflection of an object due to the Coriolis force is called the Coriolis effect.
Due to the Coriolis force. That's the problem, bro. You don't get it. The Coriolis force on Earth does not exist. You need it to exist because when an object is traveling in a straight line over different tangential speeds, you need a Coriolis force to correct it so that the actuality of it, which is the ground is stationary relative to the plane's motion or whatever's going in a straight line. That's the reason they have to say that the Earth would actually have this Coriolis force that would match, decrease, or increase the way your definition puts it.
That's exactly right.
So it lines up.
So it doesn't exist. So why is it a thing? Why are we talking about it?
Earth is life. Here's the thing.
Why can we look up definitions of it?
In fact, should apply to the Earth, and it doesn't.
All right. Earth is life. Here's the issue.
It's like Brenda said.
Right. What causes hurricanes to rotate then? If it's not the Coriolis effect.
The Coriolis force causes hurricanes to rotate.
Force. Yes.
Yo, mic check.
Go ahead. Percentage. Sorry.
You guys.
The weather patterns are totally different than the Earth rotating.
Uncouth. All right. So the issue here is that when you guys say the Coriolis force, it's an equivocal term, okay? Because you use it interchangeably with, the spin of the Earth, and that's a problem because we can have this Coriolis force, if you want, on a moving reference frame, a moving reference thing, without having any spin of the Earth. And
no, you can't.
Conservation of momentum. Yes, if you have a merry-go-round that's spinning on a flat Earth, you'll still have this effect where you see the thing. Yes.
Yeah, but you won't have.
You guys don't do a good job of extricating. Hold up.
But you wouldn't have rotating hurricanes.
B-Ball, I was almost.
Why wouldn't you? Why wouldn't you have rotating hurricanes? You got rotating tornadoes.
Wait, hold on. Let percentage finish. Let percentage finish.
So the issue here is you guys don't do a good job of delineating the Coriolis force that actually exists on moving reference bodies from the one you guys think exists on this so-called spinning Earth.
We can prove it exists,
and it's conflationary, and that's why you have them pushing back on saying a Coriolis force doesn't exist. In reality, we know it's conservation of momentum, so let's just stick with conservation of momentum for the thing that we all agree exists, which is on a moving reference body, and then for the so-called spinning Earth Coriolis force, we'll just call that Coriolis force. We good with that?
I wasn't really listening.
No, because it's not conservation of momentum. The Coriolis force isn't even conservation of momentum.
Well,
conservation of momentum applies. Conservation of momentum applies to an object that comes from that is in sync with where the rotating frame that it leaves and the inertial force that it has and all of that and the moving body. But the Coriolis force that corrects that body to stay within the tangential speed of a rotating reference frame is the force that they're talking about. It's not anything to do with the conservation of momentum that's applied to the thing that's actually going in a straight line.
Conservation of momentum applies to
what makes hurricanes
rotate, moving, not a constant speed.
I figured it was conservation of momentum in a rotating reference frame, but maybe I'm wrong.
So what makes hurricanes rotate?
Not synonymous.
What makes hurricanes rotate?
You're roboting, bro.
Let me ask you another question. What makes other storms not rotate, B-Ball? If it was Coriolis, every storm would do that. Okay, whirlpools rotate.
Large
toilets rotate.
They're
Hold on, tornadoes
patterns.
rotate.
They're conflating the weather patterns with the rotation of the Earth, which aren't necessarily the same thing, or caused by the same thing.
No,
the Earth is not rotating. We can have a vortex. We can have the toroidal vortex causing all of those rotations in the air without the rotating reference frame.
The rotation of cyclones is caused by Coriolis force, which is a consequence of the rotation of the Earth.
You're assuming the consequence.
What about whirlpool? What about my sink? What about the drain in my sink, Brenda?
That's too small.
Too many variables. Too many variables like the shape of the sink and initial variables that are in the water itself.
So
how come the general wind
Coriolis makes hurricanes spin, but not any other storm, just hurricanes, right? Just hurricanes and tornadoes.
What about the rest of the wind?
Brian, did you know? Anytime you want to, you can pull up a weather map and find a nice, strong, low pressure center, and then pull up the winds aloft. And every time you'll see the wind pattern rotating counterclockwise around that low.
Which has nothing to do with rotation of the Earth.
And you'll never see it cross the equator either. It always comes from
nothing to do with the rotation of the Earth. We have that over a flat stationary plane.
I agree with Blue, but
this is incorrect.
There's way too many people talking at once. No one can hear anything. So please try to go one at a time.
That is the Coriolis effect.
I just got done saying
every single meteorologist.
Hold on, wait, Brian. I just got, or whoever it was, I just got done saying that they're conflating the weather patterns, which could be caused by a toroidal field moving over a stationary plane and doesn't have anything to do with the rotation of the Earth. And they're making it seem like it's automatic. The rotation of the Earth.
That's because that's what you believe.
Patterns, which isn't necessarily the case.
That's because of what you believe.
Well, there's no reason to interrupt him.
For fuck's sake, dude, hold on. Hurricanes spin and they don't always go in one direction. I live in the belt. They don't always spin in one direction.
Yeah, they do. They virtually always do. Yes, they do.
Always do, Brian.
Clockwise in the northern hemisphere, always. You can't find
they don't.
Hurricane ever, Brian.
Dude, we've already been through this, and I pulled up a couple. It ain't many, but it happened.
That stands to reason on if it actually is being caused by a toroidal field in certain directions, then that stands perfectly up to reason.
What toroidal? I'm going to be able to say this. I can't say this word.
What's spinning Earth? What's spinning Earth? Show us
the spinning Earth. Exactly. What's spinning Earth? We aren't spinning.
Point at the Earth. Point at a toroidal field for me, please.
And Blue could actually.
What about when the hurricane changes past the spinning Earth?
Show us the spinning Earth.
I think there is
same exact objection.
I think there is a real life toroid, even in the Glober mainstream scientific narrative.
Where?
In that, when you have a ferrous magnet, the force lines are in the shape of a toroidal field.
Yeah, but sometimes the hurricanes change paths. They backtrack. Sometimes they'll back up and then continue back forward.
That's right. They do, Brian, but they always rotate counterclockwise.
No, they don't always. There's been examples. There's been a couple examples where they haven't, Blue. I'm telling you.
No.
What's the argument?
There is no such example.
They never cross the equator. They start off the coast of Africa.
The argument is they're saying the Earth is spinning because of tornadoes.
Let me tell you.
And there's a reason why they don't cross the equator.
They fall apart at the equator. There is no Coriolis force at the equator. Why?
So when they start coming back, right. Hold on. No, they shoot north. When they turn around, hold on, real quick. When they turn around and backtrack, wouldn't they have to spin the other way when they turn around and backtrack, Blue?
You guys need to settle down and speak one at a time, man.
And the spin vector.
You're arguing in the weeds with them, Brian. Why are you doing this? You're in the weeds with them. There's no way you're arguing a sub point.
So can we take it? Yeah, can we take it step by step? Quick flashback of the argument. I'm sorry, I'm a latecomer. So argument.
They're basically saying the Earth is spinning, and we know this because tornadoes.
No, that's wrong.
No, never said tornadoes.
The Earth is spinning.
Okay, I'd like someone from
the Earth is spinning.
The argument to clarify it. Hold on, percentage. Let them make it.
The Earth is spinning, and we know it because due to the Coriolis force, you can determine your latitude.
What about the wind?
Literally what
yeah. Okay. Walk me through it. How do you determine your latitude through the Coriolis force, quote unquote?
Correct. You would set up a Foucault's pendulum at your location, and the deviation, you'd measure the angle of deviation, right? And then you can do some math, and from that you can calculate your latitude.
Can I respond to that?
No, but you're trying to prove an argument. Wait. Calculating something is not proving an argument.
Okay.
Yeah,
I mean,
it is.
I would like to. Okay, I asked if I could respond to that. The other guy made his point. Now I'm gonna make my response.
Hold on, he wasn't done making his point, Numpty.
Oh, I'm sorry.
I'm done making my point. I'm done making my point.
Not you.
You can use a Foucault pendulum.
Dude, Gio, I mean,
Brenda,
this guy's talking.
Almost exactly was making his point.
I thought you were talking about me.
And then you after.
No, I thought you were talking about me.
No, I was talking about almost exactly.
Yeah, at best, you're begging the question. I mean, you're not presenting any relevance to your argument. You're not making any point. You're saying because pendulum, which swings back and forth, makes some movements that you predict according to your model, your mathematical model.
It's not begging the question.
Therefore,
wait,
that is.
No, I'm responding after.
It's literally not.
I'm responding after, not you, sir.
Yeah,
so I'm going to make my response now.
Our room's too hot. I don't think I can make a point. So go ahead, Numpty.
It's kind of hectic. But go ahead, no.
Okay, so basically we have the observation of this pendulum swinging at different rates depending on your latitude being based off of...
Incorrect. It's the
that's not
angle.
The observation. That's the hypothesis.
It's the angle. It's the angle that it deviates within a given amount of time.
Okay.
It's the amount of deviation. It deviates when you set up the Foucault's pendulum and you give it the initial motion. Right.
Besides the
point. It will deviate from that line.
Your interruption is besides my.
Yeah, that's just
I wasn't interrupting. I was just continuing my sentence.
No, you weren't.
It was a technical correction.
Gio.
Go ahead, Noah.
Yeah, so we have this Foucault's pendulum that deviates from the straight swing depending on what latitude you're at
That's the claim.
In a predictable manner. Okay, so I'm going to give you that. Okay, so you have an observed phenomena and you have a map based on latitudes, which I believe is based on the equator, which is based on the sun. So locations on the Earth based on how the sun revolves around the Earth, or the Earth revolves around the sun, independent of your model. It's going to change. It's going to change the deviation of the straightness of your pendulum. Now that's the observation, and these are the facts. Okay. Now this is where you guys come in with your globe model, and you say when we use a globe model, what we are observing is perfectly explained by this globe model. That's what's happening. So you have the observed facts, and then you come in with a model that then explains it, but that does not preclude flat earthers with coming up with a separate explanation that explains it just as well. So that's all. This is all.
It's a valid point, but I think you're being too generous, Noah. I think you're being too generous by giving them this so-called observation. I don't think they've actually shown that their hypothesis is true.
Yeah,
they've never once done. Hold up. I'm almost done, Brenda. So they've never once actually shown that multiple latitudes with the same apparatus, with all of its same sources of air, will yield different results. The only thing that you change is the latitude, and therefore this different result. Plus, when you say they have the observation by setting up the apparatus, they only set up the apparatus because they came up with this idea. There was no actual observation. You know, you
can't test the apparatus itself is questionable.
So how about a bunch of you guys get together?
Set up to
show
what you want to
interrupt. Almost done. And okay, you interrupted, and Brenda was next anyways. So.
No, really quick. So how about a bunch of you guys get together and do it, and then prove that it doesn't work?
Shifting of the burden of
proof. That'd be a good way to do it. That'd be a good way to do it.
No,
instead of claiming that it doesn't work,
I'm going to deny it until you prove it.
Okay. Well, you can do all you want, but I mean, if you really want to see if it doesn't work, just do it.
Well, we're obviously not spinning, so it's up to you to prove we are, and this apparatus does not do that. Sorry.
It's a very small. Well, there's a very small percentage of you that think we're not spinning. So, I mean,
Jeremy.
Yo, I'm big.
What are you talking about? Percentage of who? Of flat earthers? There's flat earthers that think we spin?
Yes. Very small percentage of flat earthers.
So I guess the most legitimate way to do it would be to use the same pendulum and take that pendulum on a tour. Like we could start.
Absolutely.
We could start.
No, you can all use the same thing.
We could start with the pendulum. We could start with the pendulum in Panama and bring it up through Mexico, up into the States, and maybe all the way into Canada. And we can, I guess, we could use that same pendulum. Because that's the thing is
you wouldn't have to.
He didn't say you have to. He said that's the best way, and he's right.
That assumes validation of the device itself.
What's going on in this server? All these museums, they all have separate pendulums. Yeah, none of these pendulums go on tour. So I guess actually an actual scientific way to prove our observation would be to take a pendulum on tour, which I've never actually seen before.
Exactly, because science is changing the one variable that you think is causing it, right? They think latitude is causing the different precessions. That's the only variable you should change. You should have the pendulum in like this chamber, which is controlling for temperature and pressure, and having the same micro deviations in the gimbal, all the different issues with the pendulum. And you do it at the equator, where it's absolutely straight. You're going to calibrate it at the equator, basically, because the model says that it'll be going straight at the equator. And you don't change anything except its location to a different latitude, and it should be going at a different
percentage.
Yeah, Gio, that's actual science.
Wait. How hard would it be for all of you guys to get together, buy the same materials?
You just tried shifting the burden of proof 2 minutes ago. Why are you trying again?
Buy the same materials, the same length of string, the same weight, right? Use the same mechanism, and you just do. Everyone lives at different latitudes, right? And you just do it. There's been several globe proponents that have done group projects, right?
No, you're not getting it.
No flat earthers have ever done any group projects to prove anything.
You're not getting
I have to ask flat earthers something.
You're not getting our point. You're not getting
real quick, Noah, real quick. Aren't you validating the legitimacy of the device itself, which uses a gearbox and magnets and all kinds of things to make it do what it does?
You don't need a gearbox and magnets. It's just a string and a fucking weight.
Earth.
Right. That's not how it works. Look into it.
You're not getting the point.
That is how it works.
Earth is life. You're not getting my point.
That's all you would need. That's all you would need.
Earth is life. I don't think you're getting my or Gio's point.
Your point is you want to take a single pendulum on tour because you want to use the same exact pendulum at different latitudes. Is that what you're saying?
Yes. We need a controlled apparatus, basically.
When you could just buy, everyone could buy the same exact materials and do it the same exact way.
Yeah,
right?
Could
you not do that?
Just get a 10 pound. Get a 10 pound weight and
he's saying we could all do that, but here's the thing that leaves a room for dishonesty. Each person can calibrate. Each person could calibrate their pendulum differently depending on their latitude.
How do you calibrate a pendulum?
Whereas if we start out with one apparatus and it is controlled and never changed, and basically calibrated at the equator.
How would you calibrate a pendulum? A swinging weight. It's just a piece of weight on a string. How would you calibrate that?
Have you ever let something go on a string and seen it revolve in a circle instead of going straight back and forth?
Yes.
If you push it into a circle, then it will go in a circle.
If you're using a different apparatus, you're going to have different starting forces.
Then you do it correctly.
So to control for those, if we're going to do it correctly, we're going to use the same apparatus each time instead of using a bunch of different apparatuses where you can vary it as much as you want and get whatever results you want, depending on how you slightly vary the way you start the apparatus off.
I think that's just an excuse to not do it. I mean,
Okay, well, that's all I think. That's your opinion. I'm done making my point.
People could falsify the data, but that's why you have, like in science, we have a tradition, right, of people who check the work, they reproduce it. There's peer review, right, and scientists do commit scientific fraud. It does happen, but eventually they get caught.
Okay, well, I think the touring pendulum's a good idea.
Just have it.
I think it'll give more confidence to the. I think it'll give more confidence to the argument. If you want to argue, I really don't understand what you're arguing, because in no way do I find it that it would decline from the confidence of the pendulum argument.
Well,
it would only add to it.
You could just
you're just doing a more legitimate test by taking the pendulum on tour and giving your side more validity. But if you don't want to do that, that's fine.
We don't have to prove it to you.
I don't need to fucking.
Yeah,
you don't need to. You don't need
we
to.
don't have to prove it to you.
Did I say you have to?
You kind of implied that we do have to prove it. You
making a point that you don't have to prove shit to us is really not adding to the conversation at all. We're just saying.
It seemed to me that that's what you were saying.
Your point more. If you did this, it would give more legitimacy to you. We're not commanding you. We're not Caesar. We're not Caesar commanding you to do it. We're just telling you what would make your side more legit. You can take it or leave it, but you don't need to give your opinion on it.
It won't make our side more legit. It will just. So what you could do is you could set up a Foucault's pendulum, set up a proper one with a weight and a good string, or I don't know what you would use, and do the experiment yourself. Calculate your latitude.
Yeah, I actually tried to do that before, but my apparatus was not accurate enough.
It has to have. I can tell you why. I can tell you why. You need to have a really long. The string needs to be really long, so you need like a stairwell. Or it needs to. It can't be just in your room. It needs to be really long. That's why it didn't work.
I think it didn't work because it ran out of momentum. I don't know if the length of the string has something to do with that, but the reason mine didn't work is because it wouldn't go long enough for me to be able to measure any deviation.
That's why you have a longer. That's why you have a longer pendulum arm. Yeah.
I was thinking of even getting a heavier weight. I think it also might have to do with the weight.
That would help. Yep. That would help. Look at the video that I posted by the gentleman physicist. He shows how he did it.
Yeah, I'm thinking about doing this myself too. I have a warehouse where I could have a pretty long string, so be on the lookout for that.
Anyways, to say that nobody's doing these tests, I mean, I guess I didn't complete the test, but I at the very least attempted it, and I don't.
Yeah,
I don't appreciate you. I don't appreciate you claiming that I'm not actually trying to test these things out. I feel like it's an overgeneralization.
I don't think anybody's saying you in general, because I mean, if you did, good on you. But I mean,
I totally agree.
Yeah. But I mean, if you guys want to say something doesn't work, then you guys should be getting together, like, hey, let's fucking do this shit, man, and let's see if this shit, let's see if the Glovers are right what they say. Let's do it correctly, and we'll see if it actually works.
Hey, Noah, I'm not sure. I'm not sure which Foucault pendulum you're talking about. I just put a bunch of links for stuff I've saved for Foucault pendulum, including patents and troubleshooting how to fix it when the magnetizer isn't working right, or if it stops, and all the variations. If it's just a string and a ball, I'm not familiar with that type of Foucault pendulum. I'm not sure if that's the one that they would tour with to make sure it's accurate. But there's a gearbox, there's magnets, there's all kinds of things that make it do what it does, and there's ways of fixing it to make sure it does what they expect. So it's not really a scientific tool, if you're calling it.
The only thing that the magnet does is keep it going. That's all the magnet does. Just gives us a push. That's it. Doesn't push it in a specific direction.
Okay.
So when I said it was magnets in a gearbox, and you said no, it's just a ball and a string, you were wrong, right?
Yeah, that's one that if you want to keep it swinging and not have a guy stand there every single time it stops, then yeah. But if you want to just make one at home,
rotation, it shouldn't stop swinging. If it's due to the Earth's rotation, that's what's causing it.
So if you swing something, it's supposed to swing in perpetually.
I think
Perpetual
there's
motion?
Well, if the Earth is perpetually spinning, that's what it's supposed to be showing, right?
Oh my goodness.
Okay,
All
I
right,
think
man.
there's some.
Yep.
I think
Yep.
there's
You
some.
got it.
I think there's some confusion because a Foucault's pendulum doesn't necessarily have to have a magnet. And I think if we were going to take a Foucault pendulum on tour, we would take specifically the one that does not use a magnet. The one I was trying
I
to
would love to
design.
see one
The
working
one I
without a
was
magnet.
trying. What the fuck is wrong with this? Goddamn fuck. Never mind.
Yeah, allow it, Noah. Don't let it get to you.
Anyways, like I was saying, the one I was trying to design does not use a magnet. Not all Foucault's pendulum, according to the theory, need a magnet. The ones that have the magnets are the big ones that go forever that they keep in museums. We're not going to be building those types because we're not here to do a display. We're here to do science. We're here to actually test this theory out, right? So we want to eliminate as many variables as possible, including magnets pushing things.
You're not going to ever eliminate electromagnetism. It's basically impossible.
No, I'm not saying we're eliminating electromagnetism. I'm saying we're eliminating a machine that sits at the top of the pendulum, literally pushing it with a magnet.
Absolutely.
So that the apparatus is more simple, less fuckery, more controlled, and all we have to do is then put that string and that weight on in the fucking box, in a glass box, calibrate it at the equator, and move it up from there. I mean, I've tried to make Foucault pendulums in my house. You don't need to put a magnet in it, and I think using the magnet is kind of dishonest because I mean, if you have that magnet driving it, I mean, it's nice for displays. You know what I mean? It's nice for a museum display, but when we're trying to actually test this, I think eliminating it is a smarter idea.
Yeah, but the magnet's not
it doesn't work without the
in a
magnet.
specific direction. The magnet's not pushing it in a specific direction. It's just to keep it swing. That's it.
You don't know that,
dude. I don't think you're getting my point. We're eliminating it.
Yeah,
so
I understand.
There's less.
I understand your point because you guys think that the magnet is it. You think that the magnet is what's making it precess.
By definition, it has to. Earth is life. It's impossible
no,
if this thing
the
is
magnet
processing.
just
Hold
keeps
up.
swinging.
It's impossible if this thing is processing that it's therefore pushing it perfectly dead center. Like it would have to account for the speed at which it's processing, and then and then because it's processing and it's off center, it would have to push it deliberately a little bit off center to get it to be perfectly straight. That doesn't make sense.
How come people that have made them without magnets they still process then?
That okay?
Well, then why would they need the magnets? Why would they need the magnets to keep it going then?
Here's the thing.
Just to keep it swinging.
Here's the thing. Earth is life. Here's the thing. Earth is life. I'm not denying. I just think that when we're talking about a magnetic mechanism machine in the thing that none of us have designed, none of us has verified for ourselves, we can't actually say we know what's going on in there because we're not the engineer. We're not the guy who set it up. And I think making a simpler machine, because, you know, instead of making the debate more complicated, we can make it simpler by just not using the magnet. Absolutely. And I'm not denying the observations of people who didn't use a magnet or who did. I'm just saying for our specific test that we would do, eliminating the magnets would make the argument so much more simpler. So much more. No one could claim that we're doing some sort of magnet fuckery, okay? I'm not saying...
Can I add something to that? Like, and even if it did do what it was supposed to do just with a string and a ball, there could be another cause for it besides the Earth rotating. Again, same thing.
I want to. Hey, but before we leave the topic of the storms, B-ball. So the winds spin faster at the equator, right? Than they do up away from the equator, correct?
Winds? You said winds spin faster? What do you mean?
I mean the Earth spins faster, whatever you want to call it.
Yes.
So
yes.
So wouldn't the spin come from the equator? Like wouldn't if the Earth was spinning the way you claimed, wouldn't the storm spin clockwise in the northern hemisphere?
No, it's because the wind is going into an area of slower angular momentum.
Right. So the faster winds coming from the winds toward the equator, okay, the faster wind should spin out first, right? the faster wind should outrun the slower wind, correct?
What are you saying,
I believe so. I think
that would give you a clockwise storm. It's exactly backwards. Them making all these claims.
I think it's a little more than that, man.
No, it would have to be.
Physics
It would
going
have
on
to be
there.
because y'all's claim of Coriolis is backwards because the equatorial winds should outrun the winds higher, which would make them clockwise.
Brian, so okay, are you saying that all the meteorologists and physicists are incorrect when they talk about Coriolis and hurricanes?
No, I'm saying the way y'all describe this shit.
Hold up, guys.
No, listen, I just
are hurricanes and cyclones are hurricanes?
I mean, but that's basically what you're saying, though, right?
Hold up, Brian. Are they
clockwise where they don't always spin counterclockwise in the north? I posted it just about 5 minutes ago. Okay, the tornadoes they say spin and hurricanes, and I just posted where there's examples of them not doing that. Okay, but besides that, I think the way y'all are describing it is wrong. The way y'all describe the conservation of momentum, because the winds at the equator would have to be faster, meaning they would outrun the winds higher up. The way y'all describe it, which would make clockwise rotation in the north and counterclockwise in the south. That's exactly backwards.
Daddy? Yes. Okay. So I see what you posted, but how often does that happen? Is it it must pretty rare, right?
All you need is one, though.
It ain't that
all you
common.
need is one black swan, right?
All you need is one, right? But okay, so again, are you saying that all the meteorologists are incorrect?
Well, if they're claiming that all hurricanes are clockwise because it's the north, and then you have one that's in the opposite direction, then you have a problem.
The low pressures stem off of the equator anyway, so they're bound. I mean, they don't have much choice but to spin counterclockwise in the north. But if y'all are attributing it to Coriolis, y'all are exactly backwards because, like I said, they should spin faster.
So the meteorologists have it incorrect? Who's incorrect here?
I don't think meteorologists really consider that. I just was looking it up, and the meteorologists who claimed it was saying that
they're all clockwise, then yeah, they have it
incorrect. The same meteorologist was saying that toilets flush different in different hemispheres. So
if
that shows you what they know, right?
Man, that's it's your word against theirs, you know.
No, if we actually have knowledge and data showing that one of them was not going the way that they say all of them go, then they're incorrect.
Is there a reason? What was the reason why?
What do you mean? What's the reason? As long as it's not
what was the reason why that one
as long as it's not man-made synthetically being caused, then it doesn't matter the reason.
So what was the reason for that one tornado to go in the opposite
direction? It doesn't matter if they say that all hurricanes are going clockwise because of the Earth's spin. Then and it's not. One isn't, and we're not affecting it. We're not causing it. That means that they're wrong.
It's two questions. How did it happen, and how long did it happen for?
I don't know.
I've been in a lot of hurricanes.
Those are pretty good things. Those would be two pretty good things to research about that.
Not really.
I got a tree on top of my house
not
that
really,
they don't always
in the opposite direction. Earth is life. Then
and there's a reason why.
Hold up. If it's going for to the opposite direction, even if it happened for like a minute, it would have to take a while to happen because you have to decelerate the clockwise motion in the opposite direction and then reach like the apex or like the 0 point, and then finally let's start spinning in the other direction. So even if it lasts for a fraction of a second, it's still a lot of work is being done to undo what they say is always happening. This Coriolis forces the Earth spin. Did the Earth suddenly stop spinning in that area?
It
obviously doesn't make sense.
Probably the right conditions were present for it to happen, and then it probably didn't last that long, because again, Coriolis probably took over and was like, "Oh no, sorry, dude.
Yeah, you're making an argument.
We're gonna rotate this way."
You're saying it's false,
because
but you don't know why it's false.
Because I can when I let the water out of my bathtub, I can spin it one way, and then all of a sudden it'll stop and start spinning the other way.
Yeah, that's you man-made affecting it. If it happens without any man-made intervention, without us interfering in it, and it's a natural process, then you can't say that they always spin clockwise. They are factually,
because I put my hand in there
to say that.
Because I put my hand in there, right, and it spun for a little while, and then it spun back the other way.
Did you hear what I just said? You're
yes, I heard
synthetically producing.
I heard what you said.
Okay, so actually respond to what I say instead of repeating the same thing I just refuted.
Yes, it was the conditions that were imparted onto the water. That's why it rotated.
There's difference in synthetic conditions and natural processes. Okay, you guys are saying it naturally always goes clockwise due to the Earth's rotation.
The conditions that were present wherever this hurricane or whatever, I'm gonna look into it. Wherever it happened, there's probably a really good reason why it rotated the opposite direction, and it probably didn't last that long.
Who knows? But the point is, they don't always go in that one direction.
Listen, which way do things deviate due to the Coriolis effect in the northern hemisphere? Does anyone know?
Clockwise.
No, let's let a baller answer though.
No, they claim counterclockwise, but that's opposite. It should be clockwise percentage, but it's counterclockwise. That was my whole point.
Never mind.
Yeah, sorry. That's what they claim.
Yeah, I'm sorry too. Yeah. Let Jeremy ask his question again, see where he goes with it.
Which way does the Coriolis effect dictate the deviation will be if we're in the northern hemisphere? Does any of the ballers know?
I'm gonna be quiet because I don't know. I'm gonna act like I don't know, so I'm gonna be quiet.
Man, don't play around with his life. Just it's your time to shine.
No, if you don't know, you don't know. It's fine. Anyways, carry on. Never mind, I guess. All right. Nobody knows.
Jeremy.
Okay, let me take over.
Nobody knows, I guess.
Okay. You got him scared. You got him running for the hills, man.
B-ball knows not to fuck with me.
They claim right to left, you know.
I didn't answer your question, but it got talked over.
I thought.
Oh, okay. Which way does the
it goes to the right.
Which way does your model dictate that the Coriolis deviation will happen in the northern hemisphere? I don't. Did you hear me or?
He said to the right, north,
it deviates to the right, which would mean.
Is that clockwise or counterclockwise?
Clockwise.
So Coriolis deviation, the Coriolis effect deviation is clockwise in the northern hemisphere?
Yes.
You sure about that?
Yes.
Which way is the deviation of the hurricanes? Which way is the deviation of the hurricanes in the northern hemisphere?
Clockwise.
That's incorrect.
Yeah. You would think that would be clockwise because the wind's moving clockwise, right?
So y'all are welcome. I just pointed out their fatal flaw in it.
What do you mean? I did it. I'm the one that did it.
I know, but I'm the one who pointed it. Well, I'll share credit with you. But you got them to fucking.
Nothing with you. I did that all by myself.
I just came in and said that they're claiming that they go the fucking counterclockwise. Oh, I'm about to say, but I'll still share it with you because you got them to say it.
You get 10%.
I'll take 10%, man.
All right. Yeah. Come on, B-ball. You think it's clockwise, bro? The hurricanes debunk you.
Sorry, please explain.
Well, hurricanes deviate counterclockwise due to the Coriolis effect in the northern hemisphere.
Okay, so why do they rotate?
Why do they rotate counterclockwise in the northern hemisphere?
Yeah.
I don't know, but clearly you just got debunked by hurricanes.
But why do they rotate at all?
It's because of the predominant westerlies coming off the coast of Africa, man.
That's beside the point. I was gonna bring you to a whole other place that would have rocked your whole world if you would gotten that question right. You want to change your answer? I'll let you change your.
Just figure out why they rotate at all.
I'll let you change your answer to the right answer if you want. You want to change it to counterclockwise?
No, just figure out why they rotate at all.
No, you don't. You don't want to change it to the right answer? Okay.
I suspect the reason why the winds are going clockwise, but they claim hurricanes are always going counterclockwise. First off, they're wrong. They don't always do, but I imagine maybe a majority of them do. Like there might be evidence to that end, and I think it's because maybe as it's creating kind of like a vortex around this area where the hurricanes happen, right? I think it's just like mostly in the ocean, like in a specific kind of I think it's like the Pacific Ocean or something like that it happens in.
Yeah, the low pressure.
Sorry, the Atlantic Ocean.
Low pressure. the low pressure systems come from the hottest water, which is over the equator, and cause them westerlies, and to get it spinning counterclockwise, man. And dude, all these hurricanes do the same shit every year. I've been through so many of them. I'm on the east coast of Florida.
No, but is that actually it? That it's just because the westerlies? That doesn't really make sense.
Yeah, well, the hot air, the system, yeah. I mean, it's predominant.
No, but
westerlies.
hold up. Above you have like so you have the westerlies above, right? And then you have like in the equator, close to the equator, like to the south, you have the northeasterlies or whatever, right?
Yeah,
and you would imagine that both of those together would have it going clockwise. But in the Atlantic Ocean, where these hurricanes are actually happening, it goes counterclockwise. So I think it's because maybe there's like the pressure fronts are causing it somehow to like cause like this induction of it going the opposite way. So I'm not sure, to be honest.
So after further research, yes, Jeremy, you were right. They spin counterclockwise in the northern hemisphere. Now we can continue. Now we got to figure out why they rotate. Now we got to figure out why they rotate.
Right now, me and you, right here. Ready? Wait, which is the Foucault pendulum showing us the Coriolis effect?
Yes.
Which way does that deviate in the northern hemisphere?
I'm not sure.
Well, go look that one up. I'll be here. I'll be here. Go look that one up, and I'll be waiting for you.
Oh, but again, why does it persist at all? That's the real question.
Debunk you. Just go look up which way.
Why does it? No. Answer this question.
In the northern hemisphere.
Why does it persist? Why?
We can be sure it's not.
What's the reason for its precession?
I'll tell you right now.
You don't want to see that. See, that's the question nobody wants to answer. No one wants to answer.
Brian, let Jeremy answer.
Why does it
stop asking the same question when he's trying to answer it.
Okay, go ahead. Answer.
We can be sure it's not the Coriolis effect because if you knew the answer to which way the pendulum was deviating, and it's claimed to be the same effect as the hurricanes, going in opposite directions.
Okay, so again,
let me back that up real quick, B-Ball. I just posted documentation from a DCS document from a GPS, the engineers of the GPS, saying that the precession in the Sanyak is not due to Earth spin, and this is the documentation. The link is in the video I just posted. It's a 2-minute video, and even with the precession with the GPS, they don't even attribute that. They give another reason. It's not because of Earth curve.
So they rotate clockwise in the northern hemisphere, right? So now, why is it rotating?
Counterclockwise.
So do things deviate in the northern hemisphere clockwise or
pendulum always rotates clockwise in the northern hemisphere. Why? Why does it rotate?
Do things deviate in the northern hemisphere?
I'll go on mute till you figure out why they rotate.
I can figure out why it's not right now, because in the northern hemisphere, things are going both ways due to the Coriolis effect, clockwise and counterclockwise. So I don't want to hear that Coriolis bullshit of why things are deviating in a certain direction, because they're not. They're deviating in both directions. You need to figure out why that's happening, not me. You're the one making claims of why it's happening. And we already know that's not the case because you got shit going in both directions.
True.
So percentage, you mentioned that you think the hurricanes might be formed that way because of the northeasterlies and the westerlies. My question would then be, why are the hurricanes spinning the same direction regardless of whether it's Florida or California?
Don't worry about the thing I just said. That's not important. That you have shit deviating in both clockwise and counterclockwise.
You still can't answer why it's deviating at all.
Let me respond.
You still can't figure out why it's deviating at all.
Neither can you. Neither can you. Your reason doesn't explain it.
If the Earth isn't
your
rotating,
reason doesn't explain it either because you. Your reason doesn't explain it either because you have stuff going in different directions in the same hemisphere.
If the Earth isn't spinning, nothing should be fucking deviating at all.
I just told you, no. If you take a plate and you wave it through the water one direction, you'll get two cyclones. One going clockwise on one side, and one going counterclockwise on the other side. The hot water, the water with all the energy, is coming from the equator. They don't cross the equator. They come from the equator and they go north, and then some of them, like in Pacific, whatever, shoot south, like the ones toward Southeast Asia and shit. Okay, the point is that the system coming from the all the energy from the waters above the equator.
You're about to say waters above. Anyway, Brian, Earth is not Earth. Brian, listen, right? Listen, Earth is not rotating, right? We're not spinning. Earth is not rotating.
Now
I don't think we are.
This is all irrelevant.
Why are pendulums precessing?
Yo, falsification is independent.
According to you, it's due to the Coriolis effect, and the Coriolis effect dictates that things deviate which way in the northern hemisphere?
It's always with the rotation. With the rotation.
It's not always with the rotation that you have things deviating clockwise and counterclockwise in the same hemisphere. You might have missed that part.
Can you show that?
The Foucault pendulum is deviating clockwise, and hurricanes are deviating counterclockwise. Same effect, Coriolis effect.
I think you need to really look into why there's a difference between the two, because I don't think
They're both the Coriolis
there's a reason why.
Yeah, they're both due to the Coriolis effect. Is your reason why the Coriolis effect? Yeah.
Is the pendulum? But hold on. Is the pendulum
in the same hemisphere?
Hold on. But is the pendulum moving to a different latitude? No, right?
Yes, that's why you don't get. That's why you don't get deviation at the equator, because it's not changing latitude.
One pendulum.
Yes, one pendulum at the equator is not deviating.
Is that one pendulum moving while it's precessing? No, right?
This pendulum is swinging. Yes, the pendulum is swinging. Yes,
but it's not moving to a different latitude. So its precession is going to be. Its precession is going to.
Are you debating whether the? Are you saying the pendulum's not the Coriolis effect?
No, I said the pendulum is not. Is deviating differently at different latitudes. Now, a hurricane deviates because the winds are moving. The winds are moving to different latitudes, and they're slowing down as well. Actually, I'm not sure exactly, but I know this. The reason why is because they're some of the winds that are moving north are moving faster than the rotation of the Earth. So it's going like into a slower reference frame.
Okay. In the meantime, you have the Coriolis effect deviating things in different directions in the same hemisphere. You need to figure out why they're deviating, not us.
No, I mean, there's probably a reason out there. But the reason, I mean, I'm sorry, remember really quick. The ultimate thing to figure out is why they're deviating at all. Because if the Earth isn't spinning, then nothing should be deviating, nothing should be rotating, or nothing should be happening.
In the northern hemisphere, they always go counterclockwise. There is no clockwise hurricane.
Yeah, the Coriolis effect makes the hurricanes deviate counterclockwise in the northern hemisphere. Coriolis effect. We also have another example of the Coriolis effect, the Foucault pendulum, which is making the deviation happen clockwise in the northern hemisphere. Same hemisphere, different direction deviation, same effect.
And you think because those things are different that the Earth isn't rotating?
No, I don't think they're different. I think it's the same effect, Coriolis effect.
Okay, so what's causing that?
We can be sure it's not Earth rotating, because if Earth rotation was causing things, hold on, B-ball. If Earth was rotating and Coriolis effect dictates the directions in a hemisphere, we know it's not the Coriolis effect because we got shit going in different directions in the same hemisphere, right?
And there's probably a good reason why, which neither one of us probably know. I could research why, but I mean, again, you'd probably deny the research.
You can come up with whatever excuse you want. In the meantime, we've got the Coriolis effect making things deviate in different directions.
Well,
you can research it all you want. In the meantime, we'll still have. I know, B-ball. You're a menace to the voice chat.
It would be your word against the physicists, man. You know.
It's not my word. The Foucault pendulum is the Coriolis effect. It's deviating clockwise in the northern hemisphere. Hurricanes are deviating counterclockwise in the northern hemisphere, and that also is the Coriolis effect. That's not my word versus anyone. No one even disagrees with that.
Those straight facts.
Well, you guys disagree with the cause, right? What's the cause?
Yeah.
You disagree with the cause, right?
The Coriolis effect. Coriolis effect. Earth rotation is the cause, homie.
Thank you. Thank you for agreeing with that.
Yeah, and your model, Earth rotation.
So what makes it happen in flat Earth? Because flat Earth isn't rotating.
It doesn't matter.
I'm not worried about that.
You're assuming the consequence. You're assuming the reason. You're assuming it's the Earth rotation. You can't do that because you don't know that.
Okay, so what's making it happen then?
We know
we have a reason.
We know that's not it. We know that's not it because we have the same effect that's supposed to dictate which way things deviate in a given hemisphere, and we have it going both ways. We know it's not the core. We know it's not Earth rotation.
What you should do, you should research why they're going different ways.
I ain't worried about why. That's your problem.
Man, I mean, you're searching for the truth. You should be all over this, man.
Yeah, and if Earth rotation was causing the Coriolis effect deviation to happen in a specific direction in a specific hemisphere, we know that's definitely not happening because Foucault pendulums are going one way and hurricanes are going another way.
You're still forgetting the cause. You're still forgetting the cause, man.
Earth rotation.
If Earth
rotation
isn't rotating,
is supposed cause.
Yeah.
Earth rotation is supposed cause, and it's showing us the Coriolis effect.
You're assuming the cause. You're assuming the cause.
Okay, so if Earth isn't rotating, right, then what's causing it?
Well, saying toroidal field is just as good.
One second. Just because I debunked
can you
come on, man, I cut off perspective for what, you to go? Because we debunked
your question, that's why. Go ahead.
Statement of fact. Just because we debunked your goofy shit doesn't mean I have to come up with my own goofy shit.
What did you debunk? What did you debunk?
I debunked the fact that the Coriolis effect is going in different. The Coriolis effect is going in different directions in the same hemisphere.
Okay, now what's the reason? There's probably a good reason why.
Yeah, the Coriolis effect is your reason why that's happening.
So how does it happen on flat Earth?
I don't care. I don't have to come up with some goofy. It's like you don't hear what I said. It's like you didn't hear what I just said. Falsification is
absolutely care.
Falsification is independent of replacement. B-ball, do you know that?
Are you okay with being ignorant about it? You just like
but you don't know the reason. You don't know the reason either.
Care why. You don't care why. I just know it's not on a.
Hold on, guys. I'm fine with not knowing things. What I'm not fine with
you shouldn't be fine with not
knowing things. Jesus, B-ball, man, you are tough to
be fine.
You're talking all over everyone nonstop. I'm gonna have to just back off and not engage because.
Go ahead, man. Go ahead. I think there's a delay, man. Go ahead.
There's no delay, dude. You're obnoxious. That's what it is.
No, I mean, every time I say something, go ahead. Sorry, go ahead.
Do you know falsification is independent of replacement? I don't have to come up with some of my own goofy shit just because your shit got debunked.
That's something you heard from Witsit, man.
That ain't nothing.
Hey,
dude, that's a fact.
Jeremy, B-Ball just said he doesn't know why it goes in a different direction either. He just said, I imagine there's a good reason for it. So it's not even a good reason.
In his model, it's because Earth's rotating.
Yeah, it's an assumption.
Yeah, it's the Coriolis effect because Earth's rotating in his model.
And that Coriolis effect is totally different.
I don't know why he would say he doesn't know the cause. I don't know why he would say he doesn't know the cause. His cause is Earth rotating.
No. The cause of why you're saying that, okay, the Foucault pendulum is rotating one way, hurricanes are rotating a different way, and you want to know why that is, and you think because those things are different, it can't be Earth rotation. Is that what you're? That's what you're basically saying, right?
Yes.
Okay.
Because
Now, what I'm saying
the
is,
Coriolis effect. Hold on. Because the Coriolis effect dictates that it should go a specific way in a specific hemisphere.
well, yeah. But what I'm saying is, there's probably neither one of us know why those two things are rotating differently.
Yeah, they're probably right. There probably is some goofy excuse they made up. And in the meantime, while you're looking for that,
Why does it have to be made up, Jeremy?
In the meantime, while you're looking for that, while you're looking for your excuse for why this problem happens in your model, we'll still be sitting here with the same effect and different direction rotations in the same hemisphere. So
why does it have to be made up though?
People, you're saying, oh, you're fine with not knowing things, but you don't even know why that is yet.
Yeah, but guess what? I'm gonna find out why. I'm not gonna say, oh well. I'm gonna find out why.
If your model comes up with it, you can't assume the cause is Earth rotation because it has nothing to do with the weather patterns, and the Earth rotating are not necessarily the same thing.
Okay,
people, you're not going to find out why. What you're going to find out is what they're going to tell you something.
So
you're not going to find out why. You're going to find out.
So if I go
you're
and
going to find out their excuse for why. You're
Well,
not going
if
to
I
find
go
out why
out-
yourself. Go ahead, B-ball.
Why do you think? Okay, so if I go and find out, why do you think they would say that? Is it because they just made it up, or you think it's because people studied it and they tested it?
Yeah, let me address that. You're not going to. You're not going to find out why. Hold on. I thought you were done. My bad. What'd you say?
No, go ahead.
You're not going to find out why.
Go ahead.
You're not going to find out why yourself. What you're going to do is you're going to go look up on Google and see why other people told you why. So
yeah, but there's a reason
you're not
why.
going to find out why yourself. You're not going to find out why yourself. You're just going to look at what somebody tells you and then come back and tell me you found out why.
Well, what I'm saying, why would it say what it says then? Because
that's what's going to happen.
They just made it up. Is it because they just made it up? Yeah,
right, that's what's going to happen, right?
That's how you research things. So we can't research things anymore. I got to reinvent the wheel. Exactly. That's exactly what's going to happen. Yeah.
Maybe
try actually find out why.
Your own. Try pondering.
Do I have to reinvent the wheel?
A reason.
Do I have to reinvent the wheel to find out why the wheel?
Stop, man.
You just asked me the same question like 10 times. I told you, yes, I'm going to go and research.
Hey,
I know, but you keep over talking me every time I try to say it.
I'm not going to try to get in anymore. I'm just going to say one thing.
No, go ahead.
Well, it's me instead of him. Real quick. B-ball, just real quick. Yeah, it seems like there is something with the weather patterns, and there is some consistency to it.
Can you hear me?
Actually, go find out why. You're not going to actually go find out why. What you're going to do is you're going to go on Google, and some guy's going to tell you why, and you're just going to believe him and come back and tell me this is why. Not that you know it for yourself. You're just going to regurgitate what some guy told you.
We can't research things anymore. We have to. I have to reinvent the wheel and do everything myself.
Reinvent the wheel. Are you going to know why, or are you going to know why some guy told you why?
Yeah, probably the reason why is because they probably researched it, or they probably actually did an experiment to find out exactly why it does what it does.
Yeah, maybe. If you find if you ever have an experiment, I'd be dumbfounded. Holy shit, you are mad difficult to talk to.
I had to go drop off.
I'm not gonna lie, man. You're mad difficult to talk to. It's something with maybe there's a lag, or I don't know.
You're roboting a little bit, Jeremy. Real quick, I'm just going to add one thing, and I got to jump off for a minute. B-ball, there does seem to be some consistency with the northern and the southern areas of the plane that have weather patterns that seem like there could be reasons other than the Earth rotation, like a magnetic or the toroidal field. Those are just as good as just an assumption that you're making about the Earth rotating. Has the Coriolis effect in terms of the weather patterns is totally different than the Coriolis effect with straight lines of balls and planes over a rotating reference frame. Conflating those two things to mean the same thing is the reason that you guys get all caught up, and everybody on this side does too. So assuming one thing doesn't make it, another assumption is just as good as your assumption. Don't say that you know
magnetic
it.
fields. So magnetic fields dictate weather patterns.
I'm saying that that assumption that it could be a toroidal field is just as good as your assumption that the Earth is rotating because we're not spinning.
How could we test for a toroidal field?
That'd be a good idea to do. That'd be a really good idea to do. But I got to go. Don't just stop conflating and demanding that your assumptions are real.
No, man, just research, man. That's all I do.
Yeah, just research why it happens. You won't know why. You'll just know why they told you why, and then you'll come back and tell us why. Even though you don't know why, you just know they told you why.
Well, I mean, I know they didn't just make it up.
Do you know that? How are you going to know that?
I mean, is that what you believe, Jeremy? Come on.
I'm just saying, you're not going to know why. You're just going to know why they told you why. Big difference.
Yeah, but there's probably a good reason.
Big difference, Bebo. Would you agree? Would you agree there's a big difference in somebody telling you why something happens or you knowing why something happens?
Yeah, but if a lot of people agree with that, if a lot of people agree with why something happens, obviously it's because at one point someone did some sort of experiment, and then other people did the same experiment, and they all agreed. They
don't all attribute it to Earth curve. That's new shit. The same thing.
If you come back with an experiment, B-ball, let me know.
Earth spin.
Let me know if you come back with an experiment or scientific experiment, right? I don't know. Is there another kind of experiment?
I don't think so.
Yeah. If you come back, if you have a scientific experiment, B-ball, I'd love to see it. Don't tell me the cause of it is Earth rotation and then not manipulate your independent variable, though.
Well, I mean, if the Earth isn't rotating, man, then it should be easy to understand that nothing else should be rotating either.
Why?
Because what would be influencing the pendulum?
Whatever's making the stars go counterclockwise in the northern hemisphere could be what's making the hurricanes do the same thing, you know?
You guys got no scientific experiments, nothing. You got assumptions based on assumptions.
But I mean, don't you think that the flat Earth is all assumptions?
I'm not saying we don't have assumptions. You guys are the ones claiming you know that it's happening for a fact, and it's an assumption. I couldn't tell you why a Foucault pendulum deviates or why hurricanes tend to rotate in a counterclockwise direction in the northern hemisphere.
Oh.
I'm not making claims about that. You guys are the ones making claims about that.
Well,
that
I mean, the claims
homie.
are made based on observations and experiments by other people who have done these things.
Bro,
cool,
I mean, I don't just make it. It's not blind.
Yeah. Give me an experiment.
They have to be blind if they observed these things going two separate directions and said it was the same thing causing it.
How often do we see a hurricane go in the opposite direction, though? I mean,
you made a claim you have experiments. You gonna let them off the hook, guys, or do we want to hear the experiment?
I'm pretty sure they're out there, man. They're out there.
Yeah,
me personally, no, I haven't. No, I haven't personally.
Unicorns are out there. Unicorns are out there, yeah.
They tried everything to prove fucking Earth curve. Back with Einstein and all that shit, they failed, bro. In fact, you could argue they proved the exact opposite.
They proved the opposite of what?
I said you could make an argument they proved the exact opposite. They set out to try and prove that shit, and they couldn't.
Opposite of what? Of Earth rotating.
Of Earth rotating.
Opposite of what? I don't think so, Brian.
I'm just saying, man.
I don't know.
You got to at least consider that the Earth might not, might not be rotating. We can't prove it either way.
Can't,
You
dude.
you
They can't.
give some evidences that you believe, and we can give some,
Well, it
some
sure
good
does look
strong
like it. That's all I'm saying.
evidence, but we can't prove it either way, man.
Yeah, but it
At
sure
least
does look
consider
like
that
it.
it's not.
From what I see, it sure does look like it.
And can your senses be fooled, B-Ball?
Sure they can.
So, yeah, there you go. Just because something looks like something doesn't mean that's what it is, right?
You're absolutely right.
Yeah. So it looking like it is a meaningless statement, or
No, but I mean, you can consider like, hey, this kind of looks like it's rotating in it. Let me see if I can recreate this on a small scale. Hey, this looks exactly like the large scale. And then I can say, well, if it looks like this, it might, not 100%, but I would say 99.9% is probably doing the exact same thing. Now, I could be wrong, but I mean, that's, you have to consider that.
Fair enough. I'll concede that. Yeah, maybe it is spinning, but and to me, it's 90%, 99, maybe about 95 that it's not. And I don't think we could prove it one way or another. But I think the evidence
what do you
against
base
is
that
better,
on,
in
though,
my
Brian?
opinion. In my
What do you
opinion, the
base that
evidence
on?
against it's better.
we didn't
What
hear
do
you
you base your
the second time.
99%
The
on?
second time, Leaky, we didn't hear you
I
because
ain't
you
gonna say
overtalked you
I ain't gonna
twice.
say 99, man. I'm not that fucking sure, but I'm gonna say I got a 95% opinion that we're not spinning, man. That's where I sit. I couldn't, but I don't think we could prove it one way or another. But I think the evidence is real strong that we're not. Although you might see it some other way, but at least you're honest about it. At least you're conceding that, hey, maybe not. You're 99% sure, but at least you're honest about it. I mean, I could talk to somebody like that. At least you got an open enough mind to say, hey, maybe I'm wrong, even though you don't think you are. At least you concede the small possibility you might be. That's fair to me.
He said ivory soap, bro. 99.9% sure it's rotating.
Yeah, but how often do you get one to say, I might be wrong? Never.
All the time. They always say there's a chance there's wrong. 99.9 whatever percent.
That's going to be our litmus test. We're going to ask them that.
They'll always tell you 99.9% or something near that. They all say that same shit B-Ball says.
I ain't heard it, but I ain't arguing with you, but I haven't heard it.
I don't know. Let's ask another. Is there another Glober in here? They're going to say something else just out of spite, to spite me, I know.
I've heard him say that with science. Like 99.9% sure, with scientific shit to them. But
Leaky, they tell you they can't prove. Leaky, they tell you they can't prove anything ever in reality, so they're never going to say 100%. That's the Glober's thing. You can't prove anything in reality.
Yeah, but have you ever heard them say they might be wrong? I mean, they might say we can't prove nothing.
Some Globers say they were 100% sure Earth is round and it's rotating and all that, so I take that back. But most of them will say
Imagine hearing Jim Panda say, yeah, it might not be spinning.
I might have heard him say that. I mean, he'll say the 99. I don't know if he said that or not, but a lot of those guys will say that you can't prove anything, so it's never 100%.
If they ask me, I'm not going to say I'm 100% nothing. Not because of science doesn't prove things. I don't believe that. I believe science is the only thing that proves things.
There's very few Globers that'll say you can prove something in reality. Very few Globers. I've only come across maybe one or two Globers this whole time.
I will say this. And a lot of the tests I've done, man, it's real hard. Like Mother Nature has a funny way of not wanting to get pinned down with nothing, dude. It seems like there's always fucking wiggle room in every fucking test I do, man. There'll be some like possible other explanation. It's so hard to pin shit down in reality, dude. Mother Nature's funny like that, man. That's why I say God must have a good sense of humor, man.
That's why I always say if you could find a shorter sailboat route for these races, you would win, and it would be incredible.
We went over this distance thing.
Yeah, I know, and you still don't have an answer for it. So
you can't prove the distances. That's all. I don't need an answer for it. You need to be able to prove your distances.
Right, I can show lots of evidence that we know the distance.
I know.
What distance is he talking about?
The Vendée Globe. Speaking
Oh
of
my
which,
God,
Brian,
dude.
are you gonna fix the video on your channel that still has the glaring errors that I pointed out to you multiple times?
What glaring errors? I looked up the facts and posted them, and then gave my opinion.
Brian's gonna change his video.
You looked up.
As soon as
you looked
Brian's
up.
gonna change his
hold
video.
on. Hey, hold on. I was asked a question. I'm going to respond.
Go ahead.
The glaring fact that the Vendée Globe is an upwind boat race, but the maximum speed that you based your calculations on was a beam reach speed.
Was a what?
Not an upwind. Was a beam reach speed.
What is the beam reach speed, bro?
It's when you're on a beam reach tack, and it's the fastest tack a sailboat can do.
Yeah, that's what I said in the video. I said, doesn't it seem like it'd be faster with tailwinds?
No, first of all.
No, I said, quote, imagine how fast they could do with tailwind.
Kool-Aid. I'll tell you what. We'll get.
Hold on, Jeremy. I'm going to address this topic.
Yeah.
So I'm going to tell you that would be slower on the Imoca 60.
Yeah, you've already said that, and I don't deny that.
So when are you going to fix the video on your channel?
It didn't matter. In my video,
yeah, it does.
When I said imagine what they would do in tailwinds, didn't matter because they didn't claim fucking tailwinds, did they?
Right.
Slower.
So that didn't have no effect on my numbers, bro. I just got the numbers they gave me, and then gave my opinions, and I also tabulated.
You gave their max possible speed under optimal conditions. Literally on the sea trials of Aprava is where you got that number,
bro. No, I gave the fucking 24-hour. The main point of the video was the 24-hour record.
Trial, dude. Would you like
the world record? You pulled it from? Why do you ignore the point of the whole video every time we talk, bro? Can you please not ignore the point of the video? Please.
The point of the video is irrelevant when you consider in the factual inaccuracies you have.
Maybe you think it is irrelevant. Maybe other people might also think it's irrelevant. But let's talk about it because it is the point of the video. What I did was I took the world record speed. I showed boats in both races. Okay, I said, does this boat look like it's going such and such? And I said, you know how fast they would have to be doing. I mean, how fast it says they're doing on a globe, and how fast that would average out over the 80 days. Okay, and then I said, here's the world record for 24 hours. Okay, and the race from the south. And the reason I did the 24 hours is because in all these years of them doing the race and all these boats and different places, you'd think in the north and in the south, both places would have one great day where they would have done their best. It'd be pretty comparable, where the best conditions,
not at all. The sea conditions alone are drastically different. Why you think you would find identical sea states in the north and the south hemisphere is beyond me.
So the whole way around the globe is different in the south than it is the north.
Yes, sea states are very different depending where you are.
Bro, you're making wild claims, man.
Kool-Aid, I'll tell you what. We'll get Leaky to change his video when you get Blue Marble to change his gas pressure without a container video. How's that sound?
I've never seen that one.
That's a classic, man. You never seen that video?
Bro, he's asking me to change a quote. Imagine if they had tailwinds, unquote. That's just a fucking, And if he says the tailwinds would be slower,
why not base it on the average? Brian, why not base it on the average speed though? Why use the world record speed?
I did. No, average speed. I put out the you can't say average like a complete average, but I averaged the pretty much the time. You know, I just divided the fucking the time that it took and the distance they went. Right.
What you're doing is you're conflating.
I'm sorry. Go ahead. I'm sorry.
You're conflating boat speed with VMG, and those are very different concepts. And what you're doing is you're saying, why is their VMG speed not their boat speed? And that is where I have a problem, because a VMG, a velocity made good speed, is going to be drastically less than the actual boat speed because the boat is traveling over longer distances. You're saying these numbers.
So that wait, you just said it. So that could also cause it, right? A longer distance could also cause that too, though, right?
Longer distance of boat travel results in a lower VMG, regardless of boat speed.
Right, but if the distance was longer than the map projected, it would show lower speed, right?
If the are you insinuating that these world-class sailors don't know how to measure a nautical mile?
Bro, you can answer a question honestly without being right or wrong. I'm just saying, wouldn't that?
Yeah, they know how to measure a nautical mile, and these best sailors in the entire world know how far a mile is.
Well, one of them came forth to Globebusters, and that's what they even had me look into it, because he said that he didn't feel like they were doing like 7 or 8 miles an hour the whole race, you know?
You heard one guy on Globebusters, and all of a sudden...
That's what made me look at the stats. And you know what? I said, you know what? I got a funny feeling that if I look at these stats, that they're going to be slower in the south because they're probably going further. Now, would you at least concede that if the distances were further in the south than what's on the map, that it would show slower times mathematically?
Brian, I have a question.
I'm not trying to get you to say that it is. I'm just trying to get you to concede the concept.
Let's pretend you know a thing about this race. How many people are on board each boat of this during this?
One. Listen, you're quizzing me. You said that the race didn't even cross the Indian Ocean. Hold on. No, my turn to ask a question. The first time we discussed this, you argued that the fucking boats didn't cross the Indian Ocean when they go around the entire sphere. So
they don't.
I mean,
they don't go to the Indian Ocean.
How can they get around the Earth in the southern hemisphere?
They don't go to the Indian Ocean. Wait, are you talking about the Vendée Globe?
Yes.
They don't go through the Indian Ocean.
How can they go around the world south of the equator without crossing the Indian Ocean?
Brian, they travel south, right? Then they go around Antarctica. Then they travel north, around the same direction. They don't go
already went through this. I went and posted it. He conceded. Now I got to do it with you. You can't go around the world. Antarctica touches. Listen, Antarctica touches 3 oceans. Listen, Antarctica touches 3 oceans: the Pacific, the Indian, and the Atlantic.
So the guy from Globebusters, what position did he hold on the Vendée Globe?
I don't know. I'm not even sure.
Hold on. Does the Atlantic? Does the Indian Ocean touch?
Hold on.
Does the Indian Ocean touch Antarctica?
I'm gonna get this out. The final is he claimed to be a crew member on the solo race, the Vendée Globe.
No,
he was a crew member on the solo race. Maybe I'll say it one more time and that'll sink in. He was a member of the crew on a race that had no crew.
We heard you. Does the Indian Ocean touch
Okay, listen. The south. I'll give you the southernmost part of the Indian Ocean. I'll give you that.
So they definitely go through the Indian Ocean.
The southern.
Right?
Yeah. Okay. If you want to stretch it that far, sure.
What do you mean if I want to stretch it that far? I don't want to do anything. I just want to know if the Indian Ocean touches Antarctica.
Sure.
So do they go around Antarctica?
Yes, they do.
So how could you go around Antarctica without going through the Indian Ocean?
Okay, so I guess they did. So they did. Okay, so they went around, right? Okay.
All right, Brian, you got that one.
Now, whether this guy even raced in that race, it got me thinking, let me check out these stats. And what I thought, this is why I even looked at it. I thought, you know what? If the distances are further than they say, what could I do to prove it? Or what could I show? I could never prove it, but what public records could I get to demonstrate it? And I said, you know what? I bet you that I got a funny feeling that the fucking times are going to be slower in the fucking South, man, compared to the North. And I'm not saying they're all slower and shit. So what did I do? I just went for a 24-hour world record, and it turned out to be quite a bit slower.
That southern,
which I don't say it proves anything. I just say that
you said it was time dilation.
That's what he just said. I say is that it's possible. I'm just trying to get them to concede the fact that if the distances are further than what they have listed on the maps, that would show with slower times.
See, there you go, slower time.
I'm not saying that that's for sure the case. It would seem to be. It could be.
Oh, let's just say they did travel around the flat Earth. How long do you think that would take?
If they were averaging, I think it come out to be about 22 miles an hour or something. Then
to go roughly 78,000 miles around the flat Earth.
No. That's the very widest point. They travel around it like
all right.
They average like 45 degrees.
Let's say 60,000 miles. How long would that take?
No, it ain't 60,000, bro. It's about 45,000.
All right, so going 22 miles an hour, how long do you think that would take?
Well, let's do the math. 22 miles an hour, that would be 22 times 24 per day. So I'm just guessing. Let me see if I remember right. That'd be 528 miles a day. So if I divide that by 40,000, let's just say.
I gotta say, having a VMG of 22 miles an hour.
That'd be 75 days. That would take 75 days to go 40,000 miles. So yeah, 45,000 miles, about 80 days. Yeah, going about a little over 20 miles an hour.
But I think they went a little further than how far.
It seems like they go a lot faster than that too, B-ball.
So how far do they actually go? How far is the actual race?
28,000 nautical miles.
It says 20. I forgot. It says 26,000 statute miles, but they come down from like France, I think, and then they go around the southern hemisphere.
I still think time dilation is.
Trust me, the numbers are a little fishy, bro. You look at. I'll post a video. I'm not okay. First off, it's fishy. I mean, if you can't give me that, I don't think that's an honest stance. It's like, damn, why are these numbers so fucking different? I'm sure there's an explanation of the rough seas in the south, whatever, but it's different,
Just to throw a wrench into your plans, Alex Thompson on board the Hugo Boss actually set the speed record for the Amoco 60s in the Southern Hemisphere on that race. So, yeah, good try.
Yeah, I know. That's all the information it's in the video. And he was in second place when he did that.
Right, and because of
another thing I said, I bet you he broke the record by a continent. And sure enough,
no,
he broke the record right south by Cape Horn, because if they were going to get rid of the distances, it'd have to be out in the middle of the ocean. So I knew the world record would be by a continent, and sure enough, it was.
He broke his boat doing this and didn't go to Africa, but went to Australia because it was close.
Oh, whoa. Right? So he broke his boat doing 22 miles an hour. That's it. So these boats that can go 45, 50 miles an hour, he broke his boat going 22 miles an hour, bro?
Brian, do you understand what the concept of VMG is? Because you keep conflating boat speed and VMG, and they're not the same thing.
Bro, you can't just keep going past my questions. At least give me some kind of response. A fuck off or something, bro.
Yeah.
I'm asking you his average.
Okay.
You can explain to me what BMG is, but answer my question. Averaging 22 miles an hour, broke his boat. Is that what you're telling me?
Right. at an average of greater than 22 miles an hour. By the way, it's killing me to talk miles an hour. But he did that for a VMG, a velocity made good. His boat speed was well in excess of that as he went back and forth across the VMG line and ended up with an average VMG speed of over 22 miles an hour. Now, if you have a VMG speed, let's make the numbers easy. You have a VMG speed of 10 miles an hour, and you only step 1 foot to either side of the line, you could theoretically be going 12 miles an hour, and you're only 12 miles an hour boat speed to get the 10 mile an hour VMG. However, sailboats don't work like that, and you actually have to go much further, meaning you generally have a boat speed of 2 to 3 times what your VMG is.
Listen, bro.
So when we average that out and we say he has a VMG of 22 miles an hour, that means he would have a boat speed reaching peaks of 66 miles an hour. That's a big difference. And
for every time he hit 66, for every time he hit 66 miles an hour, he would have had to go 0 for 1.5 times that amount. Okay, listen, he averaged 22. You say however you want, but he went like 514 miles. Okay, or right around there. Okay, say it however you want. Say BMG. Say whatever fucking letters you want. The 24-hour distance record. Okay, which equates to 22 whatever miles an hour is right a little over 500 miles, bro. Period.
That's his VMG. His actual orthogonal was almost 600 miles.
No, the miles are how I got the fucking speed, dude.
Right. You're basing it on the VMG miles, not the orthogonal boat miles, not the boat speed.
Bro,
you're showing you don't understand what
I'm basing it on the world record. I'm basing it on the Bandy Globe world record 24-hour distance travel.
It's the VMG distance. VMG.
It could be whatever distance. Okay, I'm not talking about speed. I just said it's the world record distance traveled in 24 hours in the Bandy Globe race. Okay? I got the speed. Okay, hold on. I got the speed by I got the speed by dividing them miles by 24 to get his miles per hour. They didn't give me the speed.
That's not his speed. That's where you're wrong. That's not his speed. In no way is that his boat speed. That is his VMG, not his boat speed.
Who cares? He went 500 something miles, barely.
No, he didn't. He went almost 600 nautical or 600 statute miles. His VMG was just over 500. He almost went an extra 100 miles. You're not taking into account. That's why.
How do you know that?
Between a VM.
How do you know that?
Because I know what a VMG is.
So what's different in the north? What's the BMG difference in the north?
The BMG doesn't care about what hemisphere it's in.
Okay, then the fucking numbers are still fucking warped. They're lopsided. Right. So you're gonna say the BMG didn't apply to the north because it'd be the same bias, bro. The fact of the matter is the distance, the world record distances 24 hours are way further in the north.
That's just not true.
Dude, why do you come with all this shit, dude, instead of just fucking...
As you cited yourself in your video, Alex Thompson has the world record in the Southern Hemisphere.
Yeah. No, he's got the Bandy Globe world record. Yeah, in the Southern Hemisphere. Okay, that's not the world record.
In the Southern Hemisphere.
The northern race, okay, for the monohull open category is fucking way faster than that, bro.
Right, because that's not it. Because you're talking about an Imoca 60, a very specific type of boat, and you open it up to all monohull opens, which is all hydrofoils. I believe Sailfast or Sail Rocket is actually the fastest at 110 miles an hour. However, there is a team that's trying to beat that right now. And they did have a crash a couple weeks ago where they were about 100 miles an hour when they crashed out their ship.
Now, guess what? I'm going to say this again. Hopefully you'll listen this time. Okay, well, know what? Let me throw this in there. Even if he did go 600 miles, that still only comes out to 25 miles per hour for 24 hours average, okay? Maybe there's BMG, but I'm talking about average. Even if I give you 600 miles, and that goes to say that he broke his boat averaging 25 miles per hour. I started off that video showing a guy going 41 miles per hour and says that this storm's been going for the last 24 hours and he hopes it's been going fucking all day and he hopes it calms down. He's in a race. He's averaging 41 miles per hour, okay? And he's hoping the storm calms down in the next 24 hours, okay? And you're telling me that the world record flag for broke his boat going 25 miles per hour. Don't you think that's a little fishy?
Do you know the reason why the boat broke? Maybe because it was in really choppy waters.
Like I said, I started my video off showing choppy fucking waters in a boat going almost twice that fast for a long period of time.
The video you show at the beginning yours is a sea state 1, maybe a sea state 2. A sea state 2 is considered a mild day in the Southern Ocean.
If you can't admit that it's a head scratcher at the very least, like, damn, that's
no, not if you understand
you're not
anything
being honest,
about
bro.
boats.
I can't keep talking about this with you, dude.
Right,
because you want us to believe that it's somehow fake. Somehow, is that what you're saying, Brian?
No. I'm asking a question. Okay, if the distances are further than what's on the map, okay, would that translate to slower times?
Are they actually further than what's on the map?
I'm not getting you to concede that. I'm just getting to see your honesty. If they were going further than what the map said, would that change the time?
Of course. Well, then it's not. But
he won't
they're
admit
not,
that,
though, right?
That guy won't admit that. See, I'm not trying to get you to concede that
are
it
they?
is.
Are they though, Brian?
I don't make that claim. I leave it up to the viewer to decide. It would seem that way. In my opinion, it's pretty obvious, but I still don't make the claim.
So you want to try and lead someone to a conclusion that's not correct
with facts.
He wants to say that he knows.
How do you know it's not correct? All I gave was time, bro.
The guys and girls who have dedicated their lives to open ocean sailing know more about sailing and have spent more time on the boat than this guy spent with a pencil in his hand. But he knows more about sailing than they do.
So how dare me put up their numbers? How dare me fucking show footage of the race and fucking and quote them guys? How dare
you lie? Because for some reason you think they're lying about the race and about the distances.
Did I say anybody was lying even once?
That's the whole point of your video, wasn't it?
The whole point of my video is after I seen that guy on Globebusters, I had a sneaking suspicion that the fucking world record times or the average times, whatever, are going to be slower because they're going fucking further. And it was just a hunch. And sure enough, it was fucking a good bit slower, bro. It's like I said, to be honest, I'll post the numbers that they give, that they're the world record numbers, the fucking and what that equates to over a 24-hour span. I show the boats and I show how fast they're capable of going. I show them quoting how fast they're going and for how long, and I just give facts and I give my opinion, and I don't make any obvious claims. I mean, to me, if you don't at least concede that, man, that does seem a little fucking like, damn, that is a good bit different, man. And from what I'm seeing, they seem to be going a little faster than 22 miles per hour, and that broke his boat. Damn, it's a head scratcher at the very least.
My question once again is, why are you using the numbers and you're conflating VMG with the boat speed? You're also completely disregarding the fact that this race passes through the doldrums twice, in which they are not going to get a VMG or a boat speed of 22 miles an hour. In fact, if they get a VMG of 10 miles an hour, I'd be impressed. The doldrums are characterized by a light to no wind.
Well, to be fair, bro, I didn't use BMG in the north either, and that's what I did was compared the two.
Yeah, you
so
did.
If the BMGs are that much different in the south, then you'll have to prove that, okay? But they didn't give me BMG world record times. They gave me the distance.
Yes, they do.
I didn't see it.
Brian. Right, because you don't understand sailing, and that's why I've been harping on this.
No, okay, I understand what 514 miles is, bro.
Didn't you understand when they say that they're talking the VMG line, not the orthogonal? Because no one cares about the orthogonal speed. VMG is all that matters. So when when they say that the race is 26, hold on, let me get this straight. So when they say the race is 26,000 nautical miles, or whatever statute miles or nautical statute miles, is that 24,000
VMG miles?
miles?
Is that VMG miles or what?
Yes. If you
look now, when they tell me that the 24-hour world record for the Vendée Globe since its beginning race, and every contestant included, the world record distance is don't quote me, but it's like 514 miles. Was it wrong for posting that?
What you were wrong for is
comparing
you were wrong for comparing his BMG to a boat speed. Because the 514 is a VMG. It's not a orthogonal distance.
Well, you know what? If he had did 22 miles an hour the whole race, he'd have finished, like a week before the record time. So, I mean, it all fits pretty good, Yeah, it all fits in pretty good.
I'm looking at one of the races now. It says 24,365 nautical miles.
Yeah.
And over the ground is 28,530.
Yeah, there you go. 28,000. That's it. 28,000 nautical. That's their statute. That's it. Anyway, I'm gonna post a video for anybody curious to watch it. It's a good video. I don't make any claims. It's just what I thought what I was gonna find. I found. And I didn't put BMGs for north or south. To be fair, I didn't know what that was, but I didn't post it for north or south. So at least the comparison I made was at least equal.
No, that's not true. The 514 number, those numbers you're getting, that is VMG numbers. That's what those numbers are, dude. It's not boat speed numbers.
It's 12 knots in miles per hour.
I think it's like 1.3. Hold on. I think 38. It's like 1.3. I think. I know that. I think 38 miles per hour equates to about 30. Fuck, I forgot. I'll look it up, and I'm gonna post that video real quick. It's worth watching, and anybody who watches it, I was pretty conservative in that video, and I didn't make any definite claims because I don't know for sure. That's an honest stance. I just posted the numbers I found, and you want to try and ream me for that, or if that's being dishonest.
It is.
That's bullshit, dude. That's fucked
22
up.
miles per wait. Hey, 22 miles per hour that's kind of a fast average speed.
That's what I was thinking.
Yeah, so I'm looking at
in the north. It's like fucking like almost 30 miles an hour.
No, I picked one of the guys when he was like in 6th place. His average was about 13.8 miles per hour.
Yeah, they're going way faster than that in the north, man. Let me post the video so you could look at the numbers
Maybe that was because of the conditions of the wind on.
It's a pretty cool video, if nothing else, too, people. I'll say that it's a pretty cool video.
Go ahead, Kool-Aid. I'm sorry, I may cut you off, man.
No, you're good. I just whipped up my calculator, but you already did the math. 2.8. Yeah, but I think it's dishonest that you conflate VMGs and boat speed. I understand that you probably didn't realize it, which is why the first time we talked about that it was nice, and I have been nice every time since, because now you are willfully spreading disinformation. So please make an amendment. Just add a note. Hey, these numbers are wrong. They represent different things, and we'll call it a day.
Hold on, you do realize that it could make the fucking stats even worse, bro. I did not post the BMG for the North either, bro. You realize that this could make the fucking, and usually when y'all do shit like this and we go check it, it usually does backfire on y'all. This could make the
No,
numbers
so
even
okay.
worse for you, bro.
Hold on 1 second. Hold on 1 second. So 28,000 miles, right, was the roughly the distance, right? So going at 13 on average speed of 13 miles an hour, that would take about 2,153 hours, right? Divide that by 24, that's 89 days. That seems about right? Don't you think, Brian?
Yeah, if you're in a fucking, yeah, now watch my video and watch what these boats are doing. Even in storm chopped out bullshit, they're fucking flying, bro. These are world class yachts,
I mean, it
bro.
might look like that, but they're probably not.
No, you just watch, okay? And that's the whole thing where you got to give your opinion. But you're gonna look at these boats. I'll show them in sunshine. I'll show them in storms and everywhere else. And if you ever see a boat in that race doing 13, then I don't, I'd say you're smoking something, bro.
No, it could go up, it could go down. That's 13 is an average.
Them fucking boats are fucking flying, bro. They're meant to go fast. I'm sure that
but they're
the
only
whole race they're not
sailboats,
doing
man.
that fast. But I guarantee you, their slowest average, in my opinion, the slowest they average would be about that. That'd probably be their worst couple days, if even that slow. That's my opinion.
You think they're doing that while sitting in the doldrums?
I think they rarely go as slow as 13 miles an hour. That'd be my guess. But if they're averaging 14 miles an hour, that means that
Would you like to
hold on, that means for every time they're doing 35, that means that they're fucking sitting still completely for fucking however long they were doing 35 for.
Would you like to see a video?
If they do 12 hours at 28 miles an hour, then they have to average 14. They have to sit still for 12 hours.
Right. Would you like to see a 4-hour video from Pip Hare where she was actually repairing the rudder on her vessel? She was in the doldrums.
That's why I used world records, bro. To avoid all this nonsense.
Hey, Brian, she was in the same race. It was during that race. She was sitting in the doldrums.
Why I use world record, bro, to avoid any nonsense.
Right.
Yeah, but that wouldn't be an average speed, right? I'm using a world record.
It's an average over 24 hours.
On the high, that'd be like a high end speed.
Right. It's the best case scenario. So they're going around the entire globe.
Wouldn't we want to use an average?
Thinking that all these years, hold on, in all these years with all these contestants in the North and the South, you'd think that in the North and in the South, they'd fucking at least once get best optimal conditions for 24 hours to be at least comparable, considering that in the South, they're going around the entire fucking globe.
No. You got to look at the path of the
He just automatically says no, B-ball. He doesn't even consider the fact that he won't even consider that they might have had an optimal 24-hour fucking span in the South. He won't even consider it. But B-ball, let's take a minute and watch that video. It's not that long, but just watch a little bit of it and tell me what you think, man. I mean, let me at least get a second opinion on this, B-ball. Yeah, I trust you'll at least be honest with your opinion.
Sure, I'll watch it if you watch my video on Southern Hemisphere flights.
On what? I'll go watch it right now.
Southern Hemisphere flight.
I'll go watch it right now. Post it.
What's up, guys?
Where'd B-Ball go, man?
He ran away.
Dude, I'll tell you what, he did a video. I mean, I already seen that video, but I watched the whole thing that he made. And two things, like he had a better video than that. Like he did a compilation of like globe proofs, and with like extreme bias, like the exact opposite of making a flat Earth compilation video. He did a little globe Earth version of that. Way better than that video. But no, I wanted to talk to him about the video because like the video I made about the Vinny Globe was just numbers, numbers anybody can look up. He kind of went extreme with his numbers. In fact, he used a flat Earth of 78,000 miles in circumference on the outer edge. So what he did is he split that in half and used 36,000 miles for the distance. When Sydney and Santiago, they're both at 30 degrees latitude. So if it just went a little bit around, I mean, if you drew a straight line, you'd have to go over California and shit. But that would put it at about 14,000 miles if it's 12,400 miles to the from the equator to the edge, or in Antarctica in their model. If it's 12,000, so that's if you take that same line and bring it up to 31 degrees south latitude where Santiago is, it's going to go way past the North Pole as far as straight line distance, and that would be 12,400 miles. You'd need to add probably another few thousand miles onto that to get to 30 degrees, 31 degrees for Sydney, 32 degrees. They're both just barely over 30. So you're talking a straight line distance would be around 15,000. So if you just throw a couple thousand as far as going around miles, then you're looking at between like 16 and 20,000 miles. That's still a bit far. It would have to be some big winds, but I mean, I read somewhere. I wish I'd have saved it. I don't know if I could produce it right this minute, but them flights, Qantas long haul flights, they have different planes, and they have extra fucking paint and shit. They have special paint jobs, and it's like that's almost admitting, man, that they're fucking going faster. I heard some of these planes, when they get to the runway, they got smoke coming off of them, and out there in that cold ass air, they got to be hauling complete ass to fucking be smoking when they fucking land. And for a plane to need special paint and extra layers, I mean, that shows they're hauling ass. They'd have to be really hauling ass. But the problem I have is, okay, the distance probably ain't right according to the AE. I'll say that it looks like it's off, okay? And I'd have a hard time explaining that distance. But it could be that they're a little closer. But let's say this: if they are closer. Wait, hold on. That wasn't my point. My point was, when I watched, the only thing I could really verify for sure. Well, I can't even really verify this for 100% sure, but Max Egan did the shit live on Globebusters, and he slept through some of it, but he showed what the compass said, and checked his compass before he left and when he got there, and it showed the globe route, and it showed that they'd be coming in from the southwest. They'd be going west, southwest, and west most of the flight, and then coming on the approach. The whole entire approach coming in from southwest. But what it showed, the whole entire fucking flight, it showed northwest. And what it showed is the beginning of the flight. It was showing northwest instead of southwest, which is what the globe said. And then on the approach, they're coming in going southwest instead of fucking northwest. When on his screen in the plane, it had a picture of a fucking globe saying that they're coming in from the southwest, and he shows his compass a few times, and the whole time they're coming in from the fucking northwest. That holds true with a AE map or a flat Earth map. That doesn't work with the globe. The globe, I mean, he showed it, the compass and the screen while on that flight. I think the flight, took, I think it was about 15 hours or something, which it'd have to take longer than that on a flat Earth. For the AE map, it would, even if they went, they'd had to go 1,000 miles an hour to get there in 15 hours. But to get there in about 18 hours would match a hell of a tailwind, But B-Ball he went a little bit to an extreme, like he used the rim measurement, like the very, very edge, and said that, it would be 36,000 miles. So, if they fucking trace the edge of the known Earth the whole way there, it shows them going south to the edge, and then and then tracing the wall, and then coming in from the south on the approach to Australia. But anyway, like I said, my main point there is that Max Egan showed his compass. It didn't match a globe, so the flight times don't seem to match the AE map, but the directions don't match the globe. So take your pick. Like I said, Mother Nature, it's got a funny way of getting pinned down. She's hard to pin down, man. It's always different possibilities, different variables, Certain basic shit we can pin down, but it seems like every test I've done, man, it's like there's always multiple interpretations and a little wiggle room in all these tests. It's crazy. It's kind of funny, man. It's weird how Mother Nature hates to be pinned down. It seems like, for lack of a better way of describing it.
Listen, Brian, all you got to do is dig a ditch, bro. 1 mile long ditch. Okay? Seriously, that's all we need to do. We spend all this time fooling around, arguing with these guys. We got to do something to prove it definitively.
Oh, dude, you just reminded me. Okay, so I've started this video, okay, where I'm asking normal people who don't know anything about the fucking the flat Earth globe debate, right? And I'm explaining to them and making sure they understand completely when I ask them this. I'm asking them all. So far, it's a few people, okay, just random people. That if you take I mean, I knew them. I knew the people, but they're random as far as this debate. They've never even heard of it. And so I asked them, okay, if you have I explained to them that, and I tell them at the beginning, there's no right or wrong answer here. It's just a little quiz on your opinion, okay? And I say, okay, if we have a super fishing line, like 500 pound, that we could stretch tight over 20 miles, okay, just hypothetically, okay, and it's neutrally buoyant, so it floats in water perfectly, okay. I say I'm at one end of a 20-mile lake, and you're at the other end. We have 20 miles of line stretched out. We're on each shore across the lake. Okay, we walk out. I hold my line under the water 1 foot. 1 foot from the surface. You got the other end, and you hold it on your end 1 foot underwater from the surface. And I got them all to explain so far, so you understand what's going on. And I say, okay, now we pull it just semi-tight. In the middle, we have it down 5 feet. We pull the middle down 5 feet lower than the end. So at each end, we're down 1 foot from the surface, holding it semi-tight. And in the middle, it's weighted down 5 foot under the surface. If we pull that line tight, and is in a hypothetical line that can pull straight as an arrow, whatever, or just, or neutrally buoyant, completely buoyant. I said, what would happen to the middle of the line if we pull it tight and as tight as we can without it snapping, what'll happen? Every one of them said it would come up to 1 foot. Every fucking one of them. That goes to show you everybody's common sense when they're not thinking about the debates. Don't think about water fucking bending. Don't think about level being curved. They think that line. I guarantee you, if anybody who's never heard of this debate, every one of them who understand what you're saying, who've never heard the flat debate, are going to answer, whether they're flat earthers or globe earthers. Just their natural response is going to be that line, when pulled tight, is going to come up to 1 foot underwater. So I'm gonna try and get about a dozen people. So it's gonna take me a minute to put this together. But I'm gonna film it all, and
All right, you know what would be what would be better if you called surveyors, because even surveyors don't think anything about water bending. If you ask a surveyor about level and horizontal, they'll use them interchangeably. Bye. Have a good night. They'll use those same words interchangeably.
Yeah,
I've heard several phone calls of people calling surveyors and just asking general questions, and they will literally just use those words interchangeably, level and horizontal.
Yeah, and what was that guy's name who did the test? Like he had a series of questions that they get graded on, but it was just a bunch of questions, and the questions, there was like 20 questions, and one of them was like where do they get the distance to the oil rigs in the Black Swan, and then what do you consider or whatever. You remember that dude what was his name? That guy who came in here for a while asking that test, that series of questions. Remember his name, Jeremy?
I don't know.
You know who I'm talking about, though?
I have no idea what you're talking about.
You didn't hear the questions?
Yeah. Jeremy, it's the guy that had the questions about does light travel in a straight line? Does the salt shaker across the thing? His name is he went by physicist, and it's not the physicist that's Lemon, but he went by that for a bit, and then he started going by something else. I'll remember in a sec. But yeah, what about?
He was all right, man. I mean, at first I was like, man, I'm not going to like this dude. But after hearing him out, he wasn't too bad, man, to communicate with. But I think he agreed with me that anybody's common sense who ain't in the debates is going to answer that line will pull straight. That it'll pull straight. I asked that to him, but then I thought about doing it, and I just happened to ask somebody, and then I was like, I might as well keep this going. But I was like, man, just to see, because my common sense tells me, dude, everybody's going to think the middle's going to come up. Nobody considers.
Yeah, anything intuitive would say that we're on a stationary plane. Anything intuitive.
That should mean something, Brian, man, especially if I put surveyors in there in that lineup.
Yeah, if you mix surveyors in it, that's when you'll have something, because they use the word level and horizontal interchangeably. I've heard about, I don't know, maybe five or 10 conversations of flat earthers talking to surveyors, and they will literally just use the word level and horizontal just interchangeably, like they're the same exact thing. So
yeah.
Roland my boulder, I remember his name. Roland my boulder.
Let me.
The guy that.
Hey, Jeremy, let me explain the skateboard paradox.
Brian, did you hear what I said just now?
No,
did you hear
what did you say?
his name?
I didn't hear you. I did not hear you. What'd you say?
Roland my boulder is his name, just to let you know.
Rolling my boulder. Okay, thank you. But let me give you insight on the skateboard paradox that I didn't cover the other day. That I understand the way the Glovers. I understand the way the Glovers. I understand the way their model works, how the angle's different and shit. But just for food for thought, when you ask them about the water level, right? And you take a man, and you take a water level with 3 upspouts, and you're at one end and they're at the other end, and the one in the middle is and say they're all eye height. Let's just say 5 foot, and they say that the one in the middle is going to be higher, right?
Yep.
So and that's because you're looking down. You're looking basically like a chord.
Hold on.
And
Explain the scenario again.
Okay, we got water level with three upspouts. Okay, and we got the water filled up to 5 foot in each one of them.
Okay.
I understand the way their model works. I think SE does too, but I just wanted to throw this perspective out there to show you where he's coming from. Okay, now they have the one in the middle because the angle we're at. So we're looking at each other, and we're 10 miles. We're 10 miles, so we're looking down toward the ground to see each other. But the one in the middle is higher than us, right?
Yeah, not higher than you.
No one's going to say
higher
that
than
the guy in the middle is higher. Not on any model.
Well, they have to. They don't like to call it a hump, but they will say the one. Well, they tell you to get a line of sight. If you shoot, that's what they tell you to do is line up the beginning and end.
Talking about higher from a chord or higher elevation? Because elevation
higher than
no one's
I'm not talking about elevation. I'm talking about line of sight. Line of sight.
Higher than the line of sight to the last vial. The one will be in the middle will be higher.
Right.
Yeah.
The middle will be higher. Line of sight, right? Line of sight. Okay. Now, if we take that line of sight, and I'm at one end and you're at the other, and the one in the middle is higher. Okay. If we track, you go to that fucking that one in the middle that's higher with the line of sight, and they go from the other end to that middle that's higher. They both have to be going down on their model, but they're claiming the one in the middle is higher.
Not higher.
I understand.
It's not higher. That's a problem
their
of words.
explanation and everything, but it's just counterintuitive. Is my point.
You got to eliminate that word higher from your wording.
Oh, you said line of sight, right?
When you say higher, line of sight from which line though? There's a difference. Are you
From
making a chord line
yeah.
or a horizontal line?
Chord line.
Then a chord line, yes, the guy in the middle will be higher than the other two.
Yeah.
So
So
they will both be down.
we both go to the middle. If we both go to the middle, we're traveling down to go up. You know what I'm saying? It's counterintuitive.
They're both down. One's a little bit less down. The one in the middle is a little less down.
Yeah, but we got to travel on a globe model. We got to travel down to get to that. But we just said that from line of sight, it's higher.
No,
so
that's why I changed the wording on that to see if I could help you out with it. The looking
I understand.
down.
Listen, I understand the model and the angles are different. I do understand the model explanation.
You keep saying it weird, which I'm trying to make it more intuitive. It's less down. Both of them are down. If it was at 2 miles, one would be 8 inches down. The other one would be 16 inches down?
I get it.
32.
I'm just pointing out the counterintuitiveness of it. If you thought of the Earth being a plane, it would bring counterintuitive to you too. Not that I don't understand the explanation and that it works as far as the angles go and shit, but it's just counterintuitive. So that's why he calls it paradox. But the main reason I think he calls it the paradox is because like if you look side to side, and that's Bev did that in his live stream. He went off to the side and shot the 3 spots on the level, and they were all the same fucking height. And but either way, side to side, we won't see any curvature at all. We won't see none. But what we'll see is if we're traveling that way on whatever given day, is that it'll appear lower in the distance, but side to side you don't see any fucking drop. But so in other words, if I'm looking at y'all two traveling toward the middle, then I'm gonna watch y'all traveling on a straight line, level with each other, going toward the middle, which is also gonna be level with y'all. But if I'm on one of them boats, I'm gonna have to travel down to get to that center mark, and I'm gonna see what you could take as curvature, but you can only see it from that path. But third and finally, and most importantly, is that wait, I forgot the most fucking important point. Oh yeah. Thirdly, and most importantly, if you took that straight line, like if you went to let's say LIGO and lined up a flat line, and with the concrete slab, you made a straight line out of it, and a exact straight line. It would be a bowl with a dip in the fucking middle. Actual straight line would be concave. It would fucking, all the water would race toward the middle. And so if you were looking at a bridge that was truly straight, a true straight line in their paradigm, they have to picture the water, because the water's flat. If you're looking at it from the side, the water's going to appear flat, and the bridge is going to, the straight line is going to have to appear to curve up on each end.
No, to water it would appear to curve up, but if you were looking down that range, and let's say you had something at 6 feet at 3 or 4 places along the route, all of those would line up perfectly straight.
Yeah, but that's the whole point. Is it's all optical, man.
No,
it's all water, and it changes. It changes constantly.
The
water changes, bro.
Changes constantly. I don't know what that means.
Wait. Why would the water appear straight and the straight line appear to be a bowl?
It wouldn't appear to be a bowl.
The water would certainly appear to be straight.
But you wouldn't see any curve, but the water would tend towards the middle, and over 8 inches of it would be in the middle.
Well, if you take Lake Pontchartrain, okay, and you say 13 miles to each end, hold on. Okay, let me see real quick.
You would see no curve in the Lake Pontchartrain example.
Okay, hold on, it'd be 112 foot. Hold on. If you had a true straight line, and let's say the middle was 20 foot above the water, okay, then each end would be 13 miles to each end. We're calling it 26 miles. I always thought it was 26. I've been over that bridge a million times. I live right there.
24, 26.
I think they said 24, but I always thought it was 26. But anyway, I was younger. But anyway, so 13 miles each way, 20 foot above the water in the middle, 132 foot above the water, 20 foot to match the middle line, and then 112 foot for the drop over 13 miles. So 132 foot above the water on each end. That would be a straight line. So if you were off to the side, you'd probably have to be, to see the whole 13 miles, you'd have to probably be about 3 or 4 miles back, maybe even 5 miles, but to see the whole span. But you'd see the middle of the bridge would be the left side of your vision, and it would be 20 foot above the water, and the right side of your vision would be the right side of the bridge.
All right.
And it would be 132 foot above the water, and that would be a straight line, right?
Can you stop rambling a little bit? This is getting very long. Okay, so you're trying to see all 26 miles in your field of view.
13, bro.
Okay, you're trying to see all 13 miles in your field of view. How are you going to see a 100-foot drop with it in your field of view?
You're going to have to back up about 5 miles. I mean, if you back up 5 miles, if we could see 45 degrees, if it was all we could see, then we'd see 5 miles. But we see way more than 45 degrees in our line of sight, right? So we wouldn't be that far back, would we?
5 miles, and you want to see, let's see, how much?
Our field of view is about, what, 130 degrees? I mean, we might not even have to be quite 5 miles back. It's more like about 4, right?
Right, but you're going to be, I don't even know how to do that. Jesus Christ. I don't know how you would do the, you'd have to start measuring to each point on the bridge. Your distance from each one of those points on the bridge is
be a little
what you're measuring. And I don't expect to see that much.
So we'll say 6.5 miles. We'll put it in the middle. And we'll say 6.5 miles to the right side and 6.5 miles to the center, and you're in the middle of one side, and you're 6.5 miles back. And no matter how you look at it, the center is going to be just barely above the water, and then the right side is going to be 132 foot above the water. Whether it looks a lot smaller from that distance, it's going to be way the fuck higher, right?
No.
Okay, so over 6.5 miles, you don't think we could see 132-foot fucking building, bro?
I don't think you're going to see 132 foot.
Bro,
that's
how tall
132 foot over. That's 132 foot over 26 miles.
No. You're missing my point. We're only looking at half the bridge, so we're 6.5 miles off the shore. Okay, and we're 6.5 miles, and we're also 6.5 miles back away from the bridge. So, diagonally,
how much drop is there in 13 miles?
What?
How much drop is there in 13 miles?
112.
In 13 miles?
Yes.
I'd have to check that. Hang on.
Well, it's 13 times 13 times 8 divided by 12. It's 112.6. So plus the 20 foot, the center's off. So the center's going to appear to be right on the water, right? But if you figure, you're talking 132 feet, that's like a 12-story, 13-story building, bro. We're most certainly going to see that over that span for fucking sure. Even if we're missing a little bit of it, we're going to see it's obviously going to be fucking up in the air.
Well,
but anyway,
if you have 13-mile field, actually no, you have a 26-mile field of view. If you're seeing that whole bridge,
why do you keep saying 26 miles,
you are
bro?
saying 13. Okay, you are saying 13. Okay, so
yeah.
You're trying to see 13 miles in your field of view, which is how many degrees? What do you want to call it? 120 degrees?
I'd say let's call it about 100 degrees, man.
Okay, so you got 100 degrees. So you're going to be looking for a couple of pixels over 100 degrees.
Why would you say that? I mean, how far would we have to be, bro?
What is the angular size of something at that distance?
Over 6.5 miles?
You're going to have to be zoomed all the way out.
Over 6.5 miles.
The far end of this thing is going to be 13 miles away.
I need it right there. Thank you so much, Anthony.
Hold on, man. I'll work out the angular size. Hold on.
We don't care. Well, thank you.
You hot micing again?
My bad, guys.
Let's see. Okay. Shit. Okay. Okay. Fuck. Wait. Angle A is. Wait, that's wrong. Fuck. One more thing real quick. Hold on. 0.5 times 5,200. Wait. Okay, I got it. I got it right here.
Okay, so 112 feet over 13 miles. What is that?
Hold on. Okay, the angular size would be it'd be less than half a degree. It'd be like 0.22 or some shit.
So you're looking for 0.2 degrees over your full span of vision of 100 degrees.
No. That's just for the height. Oh wait, and I only used 112 too. Wait, what did I use?
That's
okay,
what you wanted.
Yeah, that's the 132 feet. Not
me,
the.
you, and Manny. Yeah, I got it. I'm going around doing that right now.
Hey.
Yeah, I got a real set of keys. Guys, my bad.
That's okay.
Yeah, but we'd still see it though. It's above the. Yeah.
Half a degree over 100 degrees.
Okay, well, let's do this then. Let's do this. We could equally do this. Let's put the middle at 100 feet. okay, or let's put the middle at 120 feet, and we put the right side. That would put the right side at 232 feet. So that would move it up in size. That'd make it, bigger than the sun. That'd make it bigger than the sun.
The sun is only when it's a filter, and if the sun is small. Try and use the moon; it'd be better.
No, I'm just saying it's 0.5 degrees. As far as the moon, I'm just saying we'd see it. It ain't like we wouldn't see it. Also, you're acting like we wouldn't see the bridge. I mean the end of the bridge above the water. It'd be about half the size of the moon, but we'd still see it towering over the water. It would appear over that distance. It would appear to be sitting on the water in the middle, and it would appear to be. My whole point is, I mean, can you at least see where I'm coming from? That a straight line would appear to bend
subtly, very subtly, no different than looking at the horizon. Except in this case, you have a bridge on both sides that dips under the water slightly.
Not only would it appear to bend, the water would rush to the middle. Maybe not rush, but it would go to the middle. The water would accumulate in the center of the straight line.
What are you talking about straight line now? You've now changed from concentrate back to the LIGO?
No, it doesn't matter. A straight line on your globe, a straight line is concave compared to level. So that puts the middle at the lowest point. If curved is level.
What are you talking? Oh, forget it. Have fun.
If curved means level, right? In your paradigm, curved level is curved, right?
It goes down in all directions. There is no arguing this.
Wait, I'm just trying to get a simple point across.
It may be curving up. It doesn't curve up.
Why are you fighting and being militant to me trying to get a simple point across that doesn't prove nothing? Is in your paradigm curved is level is with the curvature of the Earth, right?
That should be easy to agree to, right, Moya?
I don't know why he's. So my whole point, I'm just trying to make the point that a flat line ain't dropping down, so it's not level in his model, which means the middle point, if that's the tangent, that's the lowest spot. It's a low spot. If level is curved, then straight is concave, and that means the water's going to all rush to the middle of a straight line. That's the only point I was trying to make. I don't know why he was being so fucking feisty about it. Like acting like you don't understand that level is curved.
Yeah, their model level's curved. Now, what's up with the skateboard paradox, bro?
Well, that's what
Tell me the paradox.
That's why I'm explaining to him. That's just it. The water.
Simple one sentence.
A flat line.
One sentence with the paradox.
Okay. Okay. One sentence. A flat line on their globe. I'm gonna fucking coast down to the fucking middle of it.
That's right. If the flat line is tangent, is horizontal at the middle point, then you would go to the middle of the wherever the line is.
Yeah, straight line. So to put it in one sentence, that'd be the best I could put it. Is a dead straight line.
Well, how's that a paradox?
If I'm at one end, I don't think it's reality, but if I'm at one end of a straight line, then I can coast down to the middle of a dead straight line.
Yeah. So what's the paradox though?
I mean, to me, that's just like as far as intuition goes, it's paradoxical. Doesn't make sense that a dead straight line means you'll coast down the middle of it. You know.
I mean, I don't agree that would happen either, but.
Yeah, in reality, I don't think it would, but and I do. I know that they have an explanation, and he acts like he don't understand that, but he understands their explanation. He just doesn't buy it, and he doesn't agree with it. But what I was trying to tell them is they act like that on every fucking point. Not all of them, but the majority of them. They don't ever concede shit. They won't hardly, like he was just doing just now when I was trying to say level's curved. He wouldn't. What are you talking about? Level is curved on my model. Like, dude, it's a simple thing. Like they're like that constantly with us. So if they act like that aggravates them, then they should have fill in our shoes. We get that shit all the time. So I don't blame them for scratching back, clawing and fucking biting a little bit back, because that's the medicine we get constantly from them.
Maybe he's just, fatigued from the repetitiveness of the, question. I don't know, Moyak. He kind of blew up there for no reason.
Yeah, I mean, it was a simple question. I haven't got any gotchas. I'm just showing them, just telling them the way we'd see it. I wasn't trying to exaggerate or I'm just trying to show them what it would mean, the implications of it. Not proving nothing, but I understood his points. But Jeremy's got a pretty good way, good methods of fighting through that mode of them. I mean, I got
man.
it. Sometimes I can fight through it.
With these guys. I don't, bro. I'm losing my patience with these guys.
Yeah,
I gotta stop
when they get in mule mode.
I gotta stop arguing with these guys because it's not. Like I said, we're wasting our energy. What? We're not going to change these guys' mind. Who? You know what I'm saying? Like, what are we doing? We should be talking about how we're going to get some definitive kind of test going. Like, I missed that on Brandon's show. We went like 2 months, which is, just trying to figure out some kind of definitive test.
Yeah, and it led to shit.
That's what
led to shit. I went out and got
it's gonna
that
come
one.
down to, bro.
It led to White's World going and getting that one line. It led to me going and getting that 1 mile
We
of
can talk
fish
till
line.
we're blue in the face. You could go ask
Yeah.
everyone on Earth what they think is going to happen with the line. It doesn't matter because nothing's going to change until we prove something.
But you're right though. Throwing out them ideas, man, just one after another, and granted, most of them we strike down, but everyone we fucking improved upon as good as we could and took it to its limits. And like I said, through that we came up with, White's World got the shit to do that one test. I went and got the 1 mile of for the preliminary test of the line. Just we were doing shit. Maybe not as fast as we could have, but we were talking about it and we were fucking taking steps, man, and even that discussion, bro, we were reaching like common ground, like we even had Rumpus on board with if we had a solid wall, a certain distance, and we flipped it over, pushed over, but it'd have to be connected, but we were even able to reach common ground with the fucking Rumpus guys. So yeah, man, I'm
he was
that
actually
channel too, man. But
he was actually a huge help through all that. Kinda.
Do you hear my definitive test that
Yeah.
even Zanuck agreed would work?
Oh, let's hear it.
You're roboting a little bit, Jeremy. Well, it's about the straight lines with planes, so maybe Rakia or his brother or somebody could actually do it. It's not definitive because you'd have to trust that the person that's flying the plane actually got the results they got. But if you could use a star, I guess the North Star might work best, and go from one city in the south to one city in the north and use the star as your reference for a straight line towards the star. And then you don't have to worry about the ground coordinates matching up with the spinning ball Earth. And then if you're off the 200 miles that the Coriolis effect would have, or the Coriolis displacement would have on the plane, then you'd be on a ball because you'd be off the amount that you're expected from the ball spinning out from underneath the plane. And if it's not, then if you line up exactly where you aimed at in straight line with the city and the star, then it's flat or it's motionless at least, because you ended up where exactly the line was aiming at the star in a straight line with the city.
yeah, if we had a fucking plane, dude, I mean, we'd do all kinds of shit like that. I was thinking about if we had two planes.
Brothers. I mean, I'm not looking for globe. I'm not looking for flat Earth proof. I'm not looking for globe contradictions as much anymore. They're all right there. They don't have answers for them. They would have had answers for them. You know, I'm convinced it's not a spinning ball. I'm not hoping that there's going to be something or any longer that's going to make me convinced it's a ball again. I don't think that's even
Yeah,
possible.
but I mean, sometimes I think like that, but most of the time, I want to fucking I want that test. I want to do everything in my ability to think of the best
Right. Definitive.
method I
Right.
can come
Excellent.
up with and do it, man. I want to see it. I want to see the proof one way or another. If I could come up with a test, even if it only satisfies me and a handful of other people, mainly me, I want that 100% proof because I've already went down the beach with the fucking. I tried doing the overlapping string lines, but that was fucking way too tedious. It's already tedious just going down with the instrument with the fucking auto level and shit. But and I'm like, dude, I stopped early because I'm like, how could it start curving? If I just fucking shot fucking, short of 2 miles or whatever, or really short of 1.5 miles. But how could it start curving in the fucking next 1.5 miles if the fucking previous 1.5 miles didn't curve at all? Didn't make sense. But then when I came and told them, they told me that I was changing angles and I didn't know it. So they got a fucked up explanation for everything, whether it's true or not, they still have a fucking explanation.
Oh, it's
And
brilliant.
that's why I get bent out of shape when they say they
Not
measure
everything.
the curvature. They don't measure it. They can explain it, but they damn sure ain't measuring it.
Right. They don't have answers for everything. There's some they don't have answers for. There's some they have, slightly adequate answers for. Some that are just terrible answers. So if you're ever on a plane, Brian, and you're landing, right? Have you ever seen the earth move left to right underneath you when you're landing on a north to south runway? Ever? Slightly even?
No.
No, the runway is just there, straight dead ahead of you. You aim at the runway, you land on the runway because it's stationary. There would be no timing of it to land on a moving runway ever, no matter which direction.
Did I tell you when I was out doing that test with my 1 mile line? I seen a plane, and I was under a cedar tree. I was waiting on my buddy to get the other end of the line. I'd already got the one stake from the other end and shit, and we had to cut through a little strip there from the road. It was like a tiny little strip of woods, like 20 feet. He had to cut through this little trail to get to the water, and so I'm under a cedar tree, and I see a fucking plane, and I shit you not, it was fucking drifting. Like I forgot if it was like right or left. It was drifting, but it was sure enough, dude. There wasn't no clouds. That was compared to the tree. It was going forward, and it was drifting off to the side. Like I could see it compared to the fucking tree. And but then I was like, damn, that's Coriolis. But then I realized, dude, I looked at where I was at in the fucking direction. It was traveling fucking straight fucking west. It was so that ain't what would happen on a globe, dude. And for a split second there, it had to be wind. But for a split second there, I was like, what? Coriolis, but it wasn't, dude.
Well, even if it was traveling in the right direction, the winds they would just call it Coriolis winds. It's the same thing, right? Sorry, go ahead, Gio. Did you start to say something, Gio? Is that you?
New perspective. Have you seen my fucking Vandy Globe video that they're talking about?
No, not yet.
Dude, you got to watch it, man. It's fucking.
All right.
I mean, you got.
I heard you talking about it enough. I know that you got the different times that indicate that it might be that they're off on that, and then like you just said, if the VGA actually makes it worse for them, that would be hilarious.
Yeah, it probably would. The whole point is, okay, I didn't consider that shit, but I just went by their numbers, but I also didn't consider it equally for the North. It could make it even worse for them, but I just compare the numbers that they give me. I compare the numbers, and I don't expect them to be dead on, but as suspected. But there's a catchy tune in the motherfucker, dude, and it just, it gives the numbers, but what it does, it shows the fucking boats. It starts off by showing the boats in the North, and how they say they're making good time and they're going decent speed, but then it shows the boats in the fucking South, and them bitches are fucking flying, Jack. And then it shows how long they're going. But yeah, dude, please just give the half of it, man. Just at least watch till the song starts.
All right, sure. Hey, Globus, were you trying to say something?
I know. It's just saying that that wasn't Geo. I think that was Awaken that was saying that what Brian was saying was a crosswind, which would be correct.
Yeah.
Like
And it
how
would have
many-
been a north to south, north or a south wind, which doesn't go along with their easterly winds that would be the atmosphere trying to catch up with the earth, like they say.
That's right. Absolutely.
Yeah, I think Coriolis kills the ball. I mean, as soon as you talk Coriolis, it's done, in my opinion.
I posted it in live chat. Just watch it until like just a few seconds of the song. When you see the boat cruising, that's the boat that got the world record and it claimed 22 miles per hour. So just watch it until the song starts, and just watch just a few seconds of the song, and you'll see what I'm talking about.
Okay, I'll do it right now.
Anybody who has the patience, man, I would appreciate if they just take a look, so they'll know what these fuckers are fucking throwing at me, man, when they're coming on with this bullshit. I'm just throwing numbers that they give me.
Well, I appreciate what you do, man. It's awesome. Anything I can do to help.
Fucking love that video though, man, because I love the song too. I love watching them boats fucking haul ass. It's one of my favorite videos that I made, to be honest.
All right, cool. I'm watching it right now.
All right, cool.
Have we figured out what creates the jet stream? Jetstream 1-2, Jetstream.
The obvious answer is the rotation of the Earth.
Well, gee whiz.
Obvious to some.
Yeah, as obvious as unicorns causing it, sure.
So, Brian, why is it that they say that what's the reason they say you can't go fast in the south, but you can in the north?
Say that again.
What's the reasoning that they can only go 22 miles per hour as a record in the south? Like, why?
No,
What's the reasoning?
that's the speed. Look, they went 524 miles. That's the distance. The 24-hour. It's been going since. It's been going for, I guess, a little over 30 years or whatever. The Vendée Globe. And,
Yeah, but why
for
would
every
22 miles per hour?
the world record for the Vendée Globe, the world record distance in 24 hours is 524 miles. In the north, the world record distance is the average fucking speed is faster than 22 miles per hour. And in the north, the world record's over 700 miles for a 24-hour
I
leg.
understand. What's their excuse for it going slower in the south?
They won't fucking give me one, dude. They won't even acknowledge going through the fucking Indian Ocean. It's weird.
Oh, that
Did
seems
you hear
like
the beginning of that song?
alone.
No, that fucking
Yeah.
that
Yeah, like-
so then you've seen the Hugo Boss. That bitch is flying, dude.
Yeah. So what I mean, regardless of your figures and whatever else, why don't they have like why would the record holder be only at 22 miles per hour? Right there, it doesn't make
And
any
how
sense.
could that fucking how could that break a boat when we just seen a guy who doing 41 knots, which is like 46 or 47 miles per hour, all day long, saying that he hopes it clears up in the next 24 hours, but it's a fucking washed out mess, and he's fucking flying, dude. And his boat didn't break. And why did he get a fucking record if he's going that fast? Because he was out in the middle of the ocean. The record I knew was going to be right by land, where the distances have to be more accurate. And sure enough, when I looked, it was right there by Cape Horn, right by the continent, where they couldn't stretch the fucking distances. It's just a hunch.
Well, what I don't understand is if they're all lying about because they know they're going faster than 22 miles per hour, but they know that it's recorded as that because of the, distances being.
How would they know? How would they know? The only
I don't know.
thing they got to
You
go
can
on
look
is
at the boat, right?
Look, if a pilot doesn't really, no, if all they got to go on is the fact that, hey, we went this far and our average speed over 24 hours, all they could do is take the distance the map says they went. And yeah,
Right.
I think they'd
But
have
they
to
would
be
do- they
suspicious.
might
Like,
be
damn, it
puzzled.
seemed like I was going faster than that, right?
Yeah,
You know?
that's what I'm saying. But they would know intuitively that they were going faster.
That's why I feel like that dude came on Globebusters, man, because he fucking, because if you take the so 22 miles per hour, so if you took that speed and you did it for 80 days, fuck, dude, you'd go probably around the world twice, dude. If you just average, I think it was 14 and a half miles an hour, you'd go 50,000 miles, which is about 45 latitude on a flat Earth, or 40. It's if you averaged about 14 and a half miles an hour. So what they're saying is what they're saying is basically they're averaging like 8 or 9 miles an hour. That's horse shit, man.
Right. So they must be puzzled. That's interesting. I was going to ask why, if they're going to lie about the results of the speed, then why wouldn't they just make it seem like it went a different speed with the results that would match what the globe model says,
GPS is going to tell them. Think about it. If your GPS is giving you global coordinates, then it's going to also tell you that you're doing 22 miles an hour when or averaging that, and you're going to think, hey, the GPS ain't lying. And and then in the north, if you're doing the same speed in reality, if the distance is shorter, it's going to show you your GPS is going to say you're doing, averaging 29 or 30 miles an hour, going the same exact speed in reality. But what are you going to argue with the fucking GPS or in the map? People don't think like that, But the one dude who did, who did the math and figured, fuck, dude, how could we only have averaged, 6 or 8 miles an hour in this race when these boats go fucking faster than that, And so it was that one guy who even gave me the idea to look in the numbers, and I just had a hunch what I'd find, and everything I figured I'd find. Like I said, Mother Nature, man, it's got a fucked up way of.
Are they
shooting
using the
shit down.
same boats, Brian?
Yeah, it's open
Are they
class.
using the same boats
Yeah,
in the
monohull.
north that they're using in the south?
Yeah, it's
What?
open class monohull, the biggest of the best.
Are they literally the same boats?
I think some of them are. I'm not sure. That's a good question. If I could find the actual exact same boat in a race, then I could do some further comparisons. But no, I just looked at the world records. I didn't.
Same class of boats.
Yeah, same class. But yeah, that's a good question.
Same style, same sail size, everything.
I mean, I'm sure there's a variety, but it's open class. It's the best of the best. There's no limit. You know, it's monohull. That's the only fucking.
So the Vendée Globe is the best of the best, and this in the north is the best of the best too.
Yeah, open class means anybody could fucking enter it if you got a
So
monohull.
the fastest boat.
Fastest boats, fastest in the world.
It's a race, right?
It's a
So they're
fucking
gonna
race.
put the fastest boat.
It is a race, and they're fucking flying too when they're going good. That guy seems to think just because I made a comment in one of the videos. I made 2 videos actually. But the one I always show is the darn those pesky statistics.
That was weird that they wouldn't admit you went through they went through the Indian Ocean. I don't know why that would even be in contention. Like, why would you contend the Indian Ocean of all things? Doesn't even make sense.
I was having problems, man. I was chatting away, dude. Disconnected. But there is a.
What were you saying?
No, they're by themselves in the southern race, man. And they say they only sleep a couple hours a fucking night. But I'm sure there's some legs where they don't sleep at all. Some nights, if they're making good time, or but if they sleep for a couple hours, that is an advantage for the northern boats, you could say. But I'm sure that but they don't stop in the race. They have a couple hours of autopilot, and but so there is one advantage to the boats in the north, but it's pretty lopsided because the world record speed 24-hour leg, if you applied that to the North Atlantic race, it'd barely make it past halfway. Not only would it not win the world record, if you applied that world record speed to the whole race up north, it wouldn't even, not only would it not win the normal race, it would barely make it over halfway when the guy did win. The top guy did win. The South world record would just be passing the halfway point. Or a little ways past halfway, but not that much further past halfway. It's lopsided.
I gotta jump off again for a little bit. Hey, I just DM'd you, Brian. There's a video I sent you.
Cool. I'll check it out. If I don't talk to you, if I don't see you here later, I'll see you later here.
All right.